Hey, welcome to this massive Python course where I'll be teaching you everything you need to know about Python, from setup to basic concepts like variables, data types, lists, to advanced topics like modules, object-oriented programming, etc. Then we will build 8 cool projects to enhance the learning process. Here you can see the projects. First, we will build a PDF merger, then an internet speed meter tool, then a password manager, then we will build a system resource monitoring tool, then a screen recorder, then a voice assistant with speech recognition and TTS, meaning text to speech, then we will build a to-do app, and finally an university management system. So this will be a quite long course, so take a coffee and have some patience and sit on your desk. So before starting this course, I want to give you some instructions. If you are an absolute beginner, you may need to watch this lecture twice, and I suggest you to practice writing after understanding. Sometimes try to write code before me. I may seem to be going fast or slow, so use the video player settings to control the playback speed accordingly. And another thing is that you will find all the resources and useful links in the description of this video. Lastly, who am I? I am Adil and I will be the instructor of this lecture. You can subscribe to my YouTube channel, Programming with Adil, for upcoming awesome lectures. You can follow my social accounts from the description. And if you are feeling generous, you can buy me a cup of coffee or become a patron. So without wasting any further moment, let's get started. Hey, welcome to this amazing lecture series where I'm gonna teaching you everything you need to know about Python. So before we start learning Python, we need a nice introduction about it, like what is Python, why we need it, where we use it. So let's understand this in this video. So first of all, what is Python? Python is a high-level, easy to read and write programming language. What do I mean by high-level language? High-level means it is easier for human, not for the machine, to read and write. Then it gets compiled in a machine language so that the machine can understand. So it is high-level because human can understand it easily. Python is an interpreted language, which means the code we write in Python, it turns into machine code line by line. So in a code we have multiple lines, but what interpreter does is it first compiles the first line, then it goes to the next line, and then it goes to another line. It is not like the compiler. Compiler compiles the whole code in a single go, whereas interpreter turns the language into machine code line by line. Python is a general purpose programming language. What do I mean by general purpose? General purpose means used in various fields. It can be used for web development, data science, automation, AI, and more. Python was created by Guido van Rossum in 1991. So let's understand why is Python so popular. This is popular because it is one of the easiest languages to learn. It is very simple and its syntax are like almost English. It has a massive community, so there are so many developers who are working Python, so the community is huge. So if you learn Python and work in Python, you will get plenty of support and libraries, and it is versatile as well for the community, you can say. So let's understand where is Python used. Python is used in web development. So frameworks like Django and Flask were invented so we can create web applications with Python. So let's do not go in understanding that what are frameworks and this kind of things, because this is not the right moment. We will understand them later. Python is also used heavily in data science and AI. There are plenty of tools like Pandas, NumPy, and TensorFlow. It is used for automation and scripting. game development, and also cybersecurity. For example, ethical hacking tools. So how to get started? So to get started, first we have to install Python on our machine. Then we need a code editor or IDE like VS Code or PyCharm. Then we can start writing our Python program. So conclusion is Python is a beginner-friendly, powerful programming language and also holds various career opportunities. So let's start learning this amazing language and see how far we can go. So we can write Python codes and execute them in two ways, either in our machine or in an online compiler. So if you want to write and run Python in one line, what you have to do is you just need to open your browser and just search for online Python compiler, and you can go to this website, and here you can write Python code. So in Python we have a built-in function which is called print. So if I write print, then inside I'm gonna write hello world. So this is a Python code, and if I run this code, you can see hello world output is being printed. But it is not the right way to learn, write or run Python. It is always preferable to write and run Python code in your system while learning and also developing enterprise softwares. So we are not gonna use this online compiler. We're gonna set up an environment in our own system. So if you own a Windows machine, if you have a Windows device, what you have to do is you have to open your browser. To set up, first we need Python, obviously. So in the address bar you have to just write Python and search. Then go to this first website, which is welcome-to-python.org. Here you have this download section, and you get this button which is download for Windows. Click on this and Python will be downloaded on your system. So it is complete. I'm gonna minimize my browser and open my file explorer. If I go to my downloads, you can see here is the Python executable file. I'm gonna double click on this. So before you go ahead, make sure to check this, otherwise you will face some issues or you have to do extra setup. As a beginner, I don't want that you go through those. So just check this box and click on this install now button. You will ask permission, yes, and Python will be just installed on your system. So as you can see, setup was successful and Python is successfully installed on our system. So I'm going to close that, and to check if Python is installed or not, open your terminal. So if you don't find your terminal, just open start menu and search for terminal, or you can use command prompt as well. Here it is, you can search command prompt and open that as well, and after that just write here Python and enter. You can see we have a shell where we can write Python. So if I write here 2 + 3 and enter, you can see Python is giving the output 5. Here you can write the Python codes as well, but it is not the right place to write all the Python codes, because as you can see it does not have auto completions, or it is not developer friendly actually. So we need a proper code editor where we will have some helping hands, some tools built in. So for that we're gonna use PyCharm. So there are many code editors and IDE like VS Code, PyCharm and Sublime Text, but PyCharm is favorite among the Python developers. So what I'm gonna do is I'm gonna go back to my browser and in a new tab I'm gonna search for PyCharm. So you can see the first website, which is from JetBrains. Open that, then you get this download section, so click on that. So it is PyCharm Professional, which is free for 30 days, but then you have to make a payment, so we don't want that. Let's see where is the free version, and this will show a community download button here. So click on this download button and it will download the community edition of PyCharm. So the file is pretty much big, so I'm gonna pause the recording. It will take some time to download it. So the download is complete, so I'm gonna close my Google Chrome and close the terminal, and again go to my downloads folder, and here you will see that here it is, which is PyCharm community.exe. Double click on this, then it will start installing PyCharm on your system. It will ask for permission. Click on yes, then click on next, then again next. So you can check this for some useful settings. Then click on next and click on install. It will take a while, so let's wait a bit. So the installation of PyCharm is done. Now it is suggesting that after installing this PyCharm application or software on your system, you just want to restart your computer. Means you just need to shut down your computer or reopen it. So you can check this reboot now and finish, or you can just check this I want to manually reboot later and then finish. I'm gonna close the file manager and let's open PyCharm Community Edition. Accept the agreement, then continue. It is suggesting to import settings from Visual Studio Code. I'm gonna skip import. So after restarting your computer, open PyCharm Community Edition, then click on this new project button. Here you will see bunch of options like project env, Vaisconda, custom environment. I'm gonna select custom environment and give your project a name. So here you can see that I have a red warning. You will not see this. I am seeing this because I have another project called Python project. So I can't create two projects with the same name in a same folder. So I'm gonna change the project name. Like I'm gonna call this first project. Make sure you don't have spaces or special characters on your name. You can change location as well by clicking on this. I'm gonna stick with the default and just click on this create button. It will create a custom environment for us. Here you can see our project got opened, and here what I'm gonna do is I'm gonna right click and a new, then a Python file, and I'm gonna call this main. Hit enter. You can see a main.py file got created. Now let's write our first program in our local machine. So as we have learned earlier, we have this built-in function which is called print. So I'm gonna write print, and in curly braces in between double quotations I'm gonna write hello world. Then save and click on this play icon. You can see the output hello world in the terminal. Congrats, you have wrote your first Python program in your local machine. So that's all for now. See you in the next one, where we are gonna set up Python environment on a Mac device. Now let's set up development environment in our Mac device for Python. For that, just go to your Google Chrome and search for Python, because to write and run Python on our system, we do need Python in the first place. So search for Python and go to this website, which is welcome-to-python.org. Then in the download section, you can see the option download for macOS. Click on this button. You can see the Python installer got downloaded on my system. I'm gonna click on this. You can see the installer. I'm gonna click continue. Again continue. The license, I'm gonna click continue and agree. Then click on install and give your password, and it will be installed on your system. A few moments. Okay, Python got installed on your system. I'm gonna close the installer, move to trash. Let's check in the terminal. So if I write Python 3 -- version and hit enter, you can see the Python version. That means Python is now installed on our system. If I write simply Python 3, you can see a shell where I can write Python code like 3 + 3. If I hit enter, you can see Python gives me the output 6. And if I write here print, and in between curly braces and double quotation, if I write hello and hit enter, you can see the output hello. But it is not the right place to write and practice code, because we have better code editors and IDE. For example, VS Code, Sublime Text, and PyCharm. So among them, PyCharm is one of the most popular in the developer community. So I'm gonna use PyCharm in this lecture series. So I'm gonna close my terminal and go to my Google Chrome again. And in a new tab, I'm gonna search for PyCharm. I'm gonna click on this first website, which is from JetBrains. You can see the download button. If I click on this, you can see PyCharm Professional, but it is paid. You can use this for 30 days for free. Then after that, you have to pay them money. But there is a free version here in the bottom, which is the community edition, which we are gonna use in this series. And it is absolutely enough for us. Select your operating system and a processor, if that is Apple Silicon or Intel. In my case, it is Apple Silicon, so I'm gonna download this version. So it will be downloaded in a few moments. It can take a while because the file size is almost 800 megabytes. Okay, the download is complete, so I'm gonna click on this PyCharm Community Edition. Then I'm gonna drag and drop this to my applications. And PyCharm got installed on our system. So if I go to my Launchpad, you can see here is PyCharm Community Edition. I'm gonna click on this to open this. Open. So you will see this interface. Then you can customize, install plugins, and you can do many more things, but let's not go there for now. And in the project section, you can click on new projects. Then here you can see the location where the created projects will be located. You can change this. I'm gonna stick with the default one. You can see the project name is here Python project. Let's call this my project. Here you can see there are many interpreter type like project env, base conda, and custom environment. I'm gonna select custom environment and click on create. It will create a new project. So here it is. You can see the my project folder, and if I click on this and then new, I'm gonna click on new Python file and I'm gonna call this main. So it will create a main.py file inside the my project folder. And Now here we can write our Python programs. For example, we learned the print function, which is a built-in function. So let's write print, and in between curly braces and double quotations, we're gonna write hello world. And then if I click on this play icon, it will run the program. You can see the output hello world. So congrats, you have wrote your first Python program in your local machine, which is a Mac. In the previous video, we wrote in a Windows machine. So you can play with the PyCharm now. You can make changes in the code. For example, instead of hello world, let's write hello Adil. And click on this play icon again. You can see the output hello Adil. So that's all for now. See you in the next one. For that moment, play with Python and the PyCharm. Now let's say I want to write a bank account details or a bank account number instead of this hello Adil text. So let's say the bank account number is H3893 or some gibberish. Let's say it's a long text. Now if I run the code, you can see it prints the bank account number. But let's say you have many lines of code in this file. Then after 15 lines of code, you thought I need to print the bank account number again. So what you have to do is you have to write the print statement, and in between curly braces you have to write the bank account number again, and you have to look to this text and match that here. So you have to write H383 and so on. Otherwise you have to go to the app and copy this line and come here again in the bottom, then paste here to just write this bank account number again. Then you have to run this code. You can see the output. For assume that you have other codes in between these two lines. Here can be many lines of code. So then think again that you have another bunch of lines of code here. Then again you have to write the bank account number again here. So what you have to do is, again you have to go to the app and copy this text and come to the bottom and paste here. So you can see it is not quite efficient, right? So to solve this we use a variable. So what does variable means? So variable means a container where we can store some value. So let's say I have this variable which is bank account. Then I can write the equal sign, and in between double quotation or single quotation I can write that bank account number H382 or something gibberish. Let's say this one. Now this is a bank account number. So now whenever I need to print this, I have to just write the print statement, and in the print statement I just have to write bank account. And if I write this, make sure to write here without quotations, without a single or double quotes, so just the name. So now if I run this, see we have the output here. Now let's say you have multiple lines of codes here. So let's say here after 15 lines, now you have to print that bank account number again. So just write bank account and then run again. You can see the bank account number got printed 2 times because we wrote print 2 times. Now again, if you write many lines of code, for example, think here are many lines of code, then you have a requirement that you have to print the bank account number again. Then you just have to write the print statement and here just write bank account. Then if you run the code, you can see that the bank account number got printed 3 times. So what did we learn? That a variable is a container where we can put some values that we can use later by that variable name. Now if you want, you can change the value inside the container. So for example, if you write a bank account and equal, then in the text or in the double quotation if you write the other text, then after this if you print again bank account, and if you run the code, you can see that first 3 times it printed the old bank account number, but after you set the bank account number to a new one and then you write the new print statement, you can see it printed the new bank account number. And if you ask that can we just put text inside double quotation and store that in variable, the answer is no, because we can store number like integers and floating point number and booleans as well, truth or false values in a variable as well. So if you have letters, then you have to use the quotations, otherwise you will face error. So what do I mean? If I remove the quotations and now if I want to run the code, you can see I got an error because the interpreter thinking this one as a variable too. So but this is not a variable because we haven't declared this. It does not hold any value inside it. But if I copy this and above that if I paste here and I make this equal something else, now this is also a container. It holds the value something else, and when I say bank account equal to this one, it goes there and finds that it has something else inside it. So what it does is it puts this one inside this container. So now if I run the code, you can see first 3 print statement prints something else. Then when I change the value of bank account, then it changes. So what here happening is this is a variable, it holds this value, and this is another variable. So when I am saying that this variable equal to this one, as I don't have any quotations, it will think that it is a variable. So it will look for if this variable is declared or not, and if declared, what is inside this. So which is this one, this text, which is something else. So now if I select everything and remove, we can go further. For example, as you saw that we have a variable, let's say now the name of the variable is name, and if I store here Adil, it's not like that we can't put a value other than text. We can put a value like integer, for example age. So we can say his age is 10. So now if I print name and then I say print age and run the code, you can see it prints the name Adil and the age 10. And if I name a variable like price of potato equal $2.99, now we can also print that. So I can write print price of potato. Now if I run the code, you can see the name, the age, and the price of potato. So I hope you understood what is variable and why we use it. Now let me clear the codes and tell you some restrictions while defining variables. So when you define a variable, there are some searching rules. For example, your variables can contain underscore, letters, and number. So if you declare a variable, for example name, then if you put the value Adil, then this is okay. But for example, if you ask that you want to make this variable name as first name, so what you have to do is you have to write first name like this. But if you say I will write like first space name, then it will throw an error. It is not allowed. Instead of this space, you can write here underscore. Then it is a valid variable name. You can write underscore later. That is also valid. You can write underscore at the first of the variable name. That is also valid. And in the variable name, you can use later You can use numbers as well. For example, first name 1, that is allowed. If you write numbers in between the variable name, that is also allowed. But if you write number at the beginning of the variable name, that will throw an error. So this is not allowed. So now if I clear this gibberish and make the variable name first name equal to Adil, and let's see an example. If I write here print first name, then run this, you will see the output Adil. But if you put this in between single quotation or double quotation, then if you run this code, it will run first name, because now it is a text, not a variable. When you want to print the value stored in the variable or a container, you have to write that without quotation. So that would be first name. So now if you run the code, you'll see the output. Okay, let's say you are working with a big code base where will be thousands of files or lines of code. Then there will be many functions and features, but you can't remember or memorize them all. So the problem is, when your project will need update and you are going to work on that update after 6 months, you will forget the code and you won't understand that what this print function is doing. So let's say I have a print function which prints my name. So for example, here we do not have one line of code, but we have here thousands lines of code. So after 6 months, you will usually forget that why you wrote this line or why you wrote this code. So what was the purpose? So to solve that, we have comments. So what are comments? It's not comments what we do in social media, like any social platform, but this is a self note for you. So when you write a comment in a program, this comment is ignored by the compiler or interpreter. What do I mean? So let's say if I write here something, hello, or some gibberish, and if I run this code, you can see there is an error, because Python turns code into machine language line by line. So it is not understanding what it is. It is not a variable, it is not a text, because it does not have a single or double quotations. So it is throwing error. But let's say you want to write a note for yourself that this print function prints my name. So this is a note for yourself, but it is throwing error. So what is the solution? Because here we have one line of code, but when you have thousands of lines of code, then without self note you will forget, because you will work on multiple projects, so you will forget them easily. So to overcome this, we use comments. So if I put a hash before this line, you can see the errors are gone. So this hash is telling the interpreter that ignore this line from compiling to machine code. So just ignore this line. This is not a code, but this is a note for the developer himself. So now if I run the program, you can see the interpreter ignores this line and straight goes to this line and prints my name. So this is called a comment. But now if I write other comment below this line, other comment, you can see it is throwing error again, because this line is not comment either. So to make this comment, just include the hash before this line. Now let's say you want a big descriptive comment which has 10 lines. You want to write a description for other developer. For example, you are working on an enterprise software where 3 developers are working. So now you want to write a note for them to understand what this print function do. So they won't understand in one line if you write shortly. So for them, you thought that, okay, I will write a big description what this code do. So for that, writing 10 line and making them comment with this hash sign can be time consuming. So for that you can use multi-line comment. So to overcome this, you can write 3 quotation, then again 3 quotation, and in between these, no matter how many lines you write, the interpreter will treat them as comment. For example, this is a multi-line comment. This will be ignored. So now if you run the code, you can see still this part is ignored by the interpreter. Comments are also used for debugging. So let's say if you have preprint function which prints 3 names, Adil, then John Cena, then let's say print Naruto. So if you run the code, you can see it prints the 3 names. But you want to see if you comment this line how your code behaves, or let's say in this line your code is throwing error. So you want to check if commenting this fixes, because when you will comment this, it will be ignored by the interpreter. So it is used for debugging. Now if I run the code, you can see it prints Adil, it ignores this line, then it prints Naruto. So I hope you understood how to write comments and why it is so useful. So let's understand the modules and pip in Python. So while writing a big program, as a programmer, you should not write everything on yourself. There are some self-helping functions or codes written by other developers. That is, we call them modules. So think like that. Here we are writing a code. Now let's say we want a feature which has been already developed by other developer and they are experienced developer. So we can bring that code in our program and use that here in our program. So this is the concept of module and pip. So think like you have a store, for example, let's say Amazon. So you can either buy a dress from Amazon and wear it, otherwise you can just create your own dress and wear that. So here also pip is a delivery man. You can think like that. Experienced Python developers already wrote some amazing codes and stored in a store. So when you need them, you just tell pip that, hey pip, install that module or that code, I want to use that. If I go to Google and search here module types in Python, you will see that Google is telling there are 2 types of modules, built-in modules and user-defined modules. So what are built-in modules? Built-in modules are which are included in the Python itself, means which modules or packages are developed by the official developers of Python, and we don't have to install anything using pip to use those modules. It is included in the Python itself. Remember we installed Python earlier, so while installing Python it included some modules or codes which are from the official Python developer. Those are called built-in modules. Those are here to help us to interact with the machine easily, so we don't have to write everything by ourselves. And user-defined modules are written by experienced Python developers and stored in a store. We can install them using pip and use them in our project. If I search for built-in modules in Python, then you will see that Python docs here. First link, if you visit, then you can see the built-in modules here. You can see these are the built-in modules which are provided by Python itself. You don't have to install anything. You installed Python, these are included with Python. And there are some external modules as well, or user-defined modules. So if I search for external modules in Python, you can see there are many. Here is a list. So in short, modules is a dress and Peep is a delivery man. So dresses are stored in a store. You can tell Peep to install them. You can wear them or use them in your project. So I hope you understood what is module and what is Peep. We'll learn more about this topic later. So let's talk about data types in Python. So before that, what I'm going to do is I'm going to create a new Python file and I'm going to call this data types and hit enter. So as you can see, the file got created, and here I'm going to write print data types in Python. Run the file, you can see the output. Then I'm going to go to my Google Chrome, and here I'm going to search for data types in Python. Then open the first link, which is from W3 Schools. Here you can see a bunch of data types what are available in Python. So first we have text type, which we call string. So what is that? Anything in between single quotation or double quotation is a text data type or string. So if I write here data type in Python, and this is in between double quotations, so this is a string. Then we have numeric types, which includes integer, float, and complex number. Then we have sequence type, which has list, tuple, and range. Then we have mapping type, which includes dict. Then we have set types, which are set and frozen set. Then there is a Boolean type, which we call bool. Then there is a binary types, which includes bytes, byte array, and a memory view. Then there is a none type, which means not specified, or there is no type of that data, you can say. So let's see what is string and number type in this video. Later we will have dedicated videos about all these data types. So let's delete this. So if I declare a variable, for example name, and if I write here Naruto, then this is a variable which holds a string because this is bound by double quotation. If I use here single quotation instead of double quotation, again that will be a string. Then if I declare another variable age equal 20, then this is a number data type, specifically an integer. Integer means whole number, so there is no digit after a point or period, so it is a whole number like 1 2 3, not like 1.20, just whole number 3 4 5 6. If we have some digit after the period, then that is also number data type, but specifically that is float. So if I write here $29.99 price, then this is a floating point number, so the data type would be float. But let's say if I declare a variable called new age and I set that to 20 in between double quotation, then this 20 and this 20 is not same. It is a number, an integer, but this is a string. So if I print them, for example name, then let's say print age, then we can print price, then let's say print new age, and if I run the code, you can see the output. So that's all for now. We will see every data types in details part by part with dedicated videos. Now let's see some in-depth things about a number data type. So in the previous video I told that it is integer, it is float, or it is string, but why would you believe me if I do not show you example? So let's see some example. So first we have in number, we have first data type, which is integer. So if I declare a variable, for example age, let's say 23, then in print, if I write here age and run the code, you can see it prints the age, but I am telling it is integer. But how to prove that? For that we have a built-in function in Python, just like this print function. So what we have to do is we have to write the type function which is offered by Python. It is a built-in function. So as it is a function, if we call that, we have to use parentheses. So before, while writing print function as well, we used parentheses. Now we are using type function as well, so we have to use parentheses. And in between that, if we pass the age variable, then let's see what it prints. So I'm gonna run the code. You can see it says the data type is integer. You can see int here. So it is proved that it is integer. Then we have float numbers. So float. So if I again write a variable called price, and let's say the price is $29.99, and if I write print, and if I call the type function, and in between parentheses if I pass price and run the code, you can see then we have the data type float. Then in number we have another data type which is complex. So if you are from math background or mathematics background, there is a chapter called complex number. So this is related to that. So while we studied math, we used I to represent complex number, but in Python we have to use J. For example, if I write or declare a new variable called some var, and let's say here in W3 schools you can see how to write complex number, and if I write here 20i, then let's try to print this. If I write print, and if I want to print this some var and click on this run button, you will see an error because we can't write complex data types using I. We have to use J. Now if we run the code, you can see the output 20j, and if we pass this some var to the type function, let's see what it prints. So I'm going to write the print function, then I'm going to call the type function, and in between the parentheses I'll pass the some var. Then if I run the code, you can see the data type is complex. So that's all we have in number data type. See you in the next one. So in the previous video we saw how we work with the number data type, for example int, float or complex. In this video, let's see how we work with or deal with the string data types. So what I'm gonna do is I'm gonna write a comment, work with string data type. So if I declare a variable called first name Adil, or let's say Naruto, then if I print that, so if I write here print first name and run the code, you can see the output Naruto. And again if I write the print function, and here if I call the type function and pass the first name here, and if I run the code, you can see the data type is string. The short form is str. So there are many things we can do with string data type, or there is a concept called concatenation. So let's understand that. Here if I write print, and in between double quotations if I write my name is, then after the quotation if I write plus, and then if I write first name, then what it will do is it will put Naruto here. So what it will print, let's see. If I run the code, you can see it is printing my name is Naruto, but is and Naruto is attached to one another. So what we can do is we can give a space here, and if I run the code, you can see the output which is my name is Naruto. Then we can declare another variable which is last name, and that would be Uzumaki. And again after writing first name, if I write a plus and write last name, and if I run the code, you can see my name is Naruto Uzumaki. But here is a problem. You can see Naruto Uzumaki is attached to one another. So how to give a space here? Even if we add space here and run the code, the output is still same. They are attached to each other. So how to solve that? You can say that we can add a space here after Naruto, and if I run the code again, then it fixes, but it is not the right way, because here also it added a space. You can see here it is a blank space, but we don't want the space there. We just want the space here in between first name and last name. So to solve that, we can remove that space from there, and after the plus we can give another plus, and here in between singular double quotation we can give a space. Now this space will be added here. So if I run the code now, you can see it prints my name is Naruto Uzumaki correctly. After understanding string data type, let's understand string formatting as well. So if I write here print, then in between double quotation, if I write my name is, then let's say I want first name, which I want to replace with Naruto, then you will tell that writing in between quotation, the variable won't be work as expected, and you are right that it will print first name as it is. It won't print Naruto. But for this moment, let's go with the flow, and I'm gonna write my name is first name, then last name, and I will be the nth Hokage, and I will declare the variable n equal to 7. Now if I run the code, you will see it is not printing Naruto Uzumaki and 7th. It is just printing first name, last name, and nth Hokage. You can say that to solve this we can use string concatenation. Like here we can close this, then we can use a plus, then after this first name we can use another plus, and after this last name we can use another plus, then after that we can use again double quotation, then here we can close the double quotation, then a plus sign, and after n again a plus sign, then again double quotation. But here you can see a problem. It says can only concatenate string to string but not integer. It is telling this because this n holds an integer. So if this holds a string, then it will work as expected. But if I give here other data type instead of string, it will throw error. You can see it is throwing error because concatenation does not work with string to integer in Python. It has to be string with string. For example, this first name is string and this last name is string. So to resolve this issue, we can use string formatting. So what I'm gonna do is I'm gonna remove this part, and again I'm gonna write the double quotation, but before the beginning quotation I'm gonna write F. This means formatting. Now let's see what happens if I write here my name is, then in between curly braces I can write first name or the variable names I mean. So it will print my name is Naruto, then after a space I can give curly braces again, and here I can give last name. So it will print my name is Naruto Uzumaki. Then I can write here and I will be the, and in between curly braces I can write n, which will print 7, then th means 7th Hokage. Now if I run the code, you can see it is printing as we expected. My name is Naruto Uzumaki and I will be the 7th Hokage. And it has another use case. So let's say you have a variable, for example num1 equal 12, then num2 equal to 13, and if you say num3 equal num1 plus num2, then in the print function if you write num3 and run the code, you can see it prints 25, which is the addition of these two. But let's say you want to do that in the print function. without this num3 variable. You want to calculate the addition of num1 and num2 in the print function. How to do that? So if I remove this, and here I can write the addition is. So what we can do now? So you will tell that we can give a comma, then here we can do num1 plus num2, and if I run the code, it will work as expected, but we don't want that comma and then doing plus there, but we want to do that in the string. For that we can use string formatting again. So if I write here f, and in between double quotation and in between curly braces, if I write num1 plus num2 and run the code, it will work as expected. We can do other calculations as well. So if I write here multiplication and run the code, you can see it prints the multiplication result. So the result is 156. So you can see there is a beautiful use case of string formatting. Now let's understand Boolean type data type in Python. So here I'm gonna write Boolean, then let's define a variable. For example, incident occurred. Here answer can be yes or no, and for that we are gonna use Boolean. So if I write here true, you can see it is throwing an error and it is not allowing me to do that. Or here also I have a spelling mistake, sorry. So still it is not allowing me to write true. In other languages, typically this one is a valid Boolean, but in Python the T should be in capital letter. Now it is a valid Boolean. You might ask why this true is working, but the true with the small letter is not working. The reason is Python is case sensitive. For example, if I declare a variable called age equal 20 and another variable with a capital A, and let's say it is 23, then this age and this age is not same, they are different. If I print age and if I print here this age, if I run the code, you can see it is printing 20, this one, and then 23, this one. If they are happen to same, then what it would do is it would overwrite the value of age. What do I mean by that? So if I write here again age with every letter small, then if I write 29 and if I run the code, you can see that it is printing the age 29. It has changed 20 to 29. Understanding the both are not same. If this age and this age were happen to same, then Python would have overwrite 20 and put 23 in this age. But as they are different, it didn't happen in the previous example. So let me remove this portion. So this is Boolean. So writing the small t won't work here. So now if I write here print, and then if I write here incident occurred and run the code, you can see it prints true. But you might ask, hey, what we put inside a variable print function prints exactly that. But you can see we are not using single or double quotation here. That means it is not string, means it is something else, and that is Boolean. So to make you believe me, what I can do is I can write the type function, and in the curly braces I can pass this incident occurred variable. If I run the code, you can see the type is now bool, means Boolean. If I write here false, it will throw error, but if I make the F capital and then run the code, you can see still it is bool, means Boolean. Okay, so far we have covered number data types, string data types, means text, and Boolean data types. Now we have some more data types. In this video, let's talk about binary data types, which includes bytes, byte array, and memory view. So I'm gonna go back to my PyCharm, and here what I'm gonna do is I'm gonna create a new file, a Python file actually, and I'm gonna call this binary data type. Hit enter. The file got created. So the first question is, what are binary types? In Python, binary data is essential when dealing with files, images, network data, and cryptography. Python provides three built-in types to handle binary data. First, we have bytes. It's an immutable sequence of bytes, and then we have a byte array, which is mutable sequence of bytes. Then we have memory view, a way to access object's memory without copying data. So let's explore each of them in detail. So first we have bytes. It's an immutable sequence of integers between 0 and 255. Think of it is a string, but for binary data. You can create a bytes object in multiple ways. So let's see how to create bytes object. First, let's declare a variable. Let's say it is b1 and equal. We're gonna write bytes, then parenthesis, and in between parentheses we're gonna use square brackets, and here let's say we have 65, 66, and 67. These are integers, but we can express ASCII values with these as well. So what do I mean by ASCII values? So if you go to Google and search for ASCII table and open one of the images, then if I open this image in a new tab, and if I zoom this, you can see each decimal indicates some value. So for example, this 33 in ASCII, 33 means exclamation sign. The 35 means the hash sign. Like this, 65 means A, I mean the capital A, and 97 means the small a. Then 66 means capital B, and 98 means the small v. So we can express this ASCII values with decimal numbers. So when I write here 65, this means A, 66 means capital B, and 67 means capital C. So this is a byte object. It follows the list syntax. I haven't teach you the list as of now, so I don't expect that you will understand all the concepts in this video, but I suggest you to watch this video twice or thrice and try to understand what I am trying to explain. So the first element here in the square brackets has something called index. So the index of the first element is 0, and the index of second element is 1. The index of third element is 2. So the concept here is elements index is position minus 1. As you can see, the position of 65 is first, but you have to minus 1, so it becomes 0. So the index is 0 for 65, and index of 66 is 1, and index of 67 is 2. So this is how we write a byte object. So now if I write print statement, and here if I pass b1, and if I run the code, let's see what happens. It says b, then in between single quotation it prints A, B, C. Here you can see the B prefix that indicates a byte literal. So it expresses that it is a byte object, and in between single quotations you can see ABC. As I had told that 65 means A, 66 means B, and 67 means capital C. So now let's clear what do I mean by immutable. Immutable means we can't change anything from this byte object. I'll come to this topic after explaining byte array. So I'm gonna make another comment, and here I'm gonna write byte array. So I'm gonna declare a variable called BA, means byte array, and then I'm gonna write byte array, and in between parentheses again I'm gonna write square brackets, and then I'm gonna write 65, 66 and 67. So here also we have some indexing. So here 65 has the index 0, 66 has the index 1, and 67 has the index 2. Means position minus 1 is equal to the index. And 65 represents again capital A, this represents capital B, and 67 represents capital C. Now again, if I write the print statement and pass the BA variable and run the code, you can see it prints byte array, then in between parentheses it says byte, means the B prefix, and in between single quotations it prints A, B and C. So both are kind of similar, right? But this is immutable and this is mutable. So immutable means we can't change anything here, but as this is mutable, we can change the ASCII value from this byte array object. What do I mean by that? So if I write here BA, then again if I write square brackets, so as I told, this has some index, so this has the index 0. So if I write here 0, then if I write here equal, and then if I assign 68, what will happen? It will change 65 with 68, means it will go to BA here, as you can see BA, and it will find the 0th index element, as we gave 0 in third bracket or the square bracket, and put this value in that element place. So after writing this statement, if I write the print statement again and pass BA, let's see what happens. Let's run the code. You can see first this statement prints byte array B, then in between single quotation ABC, but this one made byte array, then B prefix, then DBC. So 68 means D in ASCII value. So if I go to Google Chrome again, you can see that 68 means D. If I zoom more, you can see 68 means D. So it replaced 65, which is the 0th index of BA, with 68. So that's the concept. What did I mean by mutable? So here we can change some value from byte array, but we can't do that in bytes. So if I write here B1 and in between square brackets, if I target the 0th index element and try to assign 68, as you can see it shows warning already, it is not allowing me. So if I write print, then if I pass B1 and run the code, you can see it throws error. So we can't change anything from the bytes as it is immutable. So that's the concept of immutable and mutable. This is immutable and this is mutable. So I think these concepts are clear now. Then we have another thing, which is memory view. Now this is a powerful tool that allows you to work with binary data without copying it. It provides direct access to an object's memory, making it super efficient for large data sets. So for example, let's say I have another byte array. So I'm gonna call this BA2, and let's say byte array, and in between parentheses and square brackets I'm gonna write 65, 66, 67 and 68. Then let's declare a variable called MV, which means memory view. By the way, you can name this anything, as these are variable. And then I'm gonna call memory view and pass this BA2. Now let's print MV, and in between square brackets I'm gonna pass 1. So I'm trying to access 66. It is in the first index. You will understand indexing and these concepts better when we will learn lists in Python. So now if I run the code, you can see 66. So it prints the actual decimal key of ASCII, but it represents B in the background. And we can also modify byte array through memory view without copying it, so it is super efficient. So let's see how to do that. So what we can do is we can write MV, then let's target the 0th element, means this 65, then replace that with 90, which is capital Z in English letter. So after doing that, if I print BA2 and run the code, you can see it prints byte array B, which is the prefix, then in between single quotation it prints ZBCD. So we have modified the byte array by directly accessing the object's memory. So it is super efficient for large data sets. The key takeaway here is that memory view allows efficient manipulation of large binary data without unnecessary copies. This is especially useful in performance critical applications like file handling and image processing. So when we should use each of these? So the answer is use bytes when you need immutable binary data, for example cryptographic keys and network data. Use byte array when you need mutable binary data, for example modifying file contents, and use memory view when working with large data sets efficiently, for example handling image processing and large file I/O. So don't worry if you haven't understand anything in this video or some topics have not clicked you. Watch the video again if it feels confusing. I know this topic is a bit hard than the previous topics, but gradually it will become easy. So follow the next videos and you will learn more concepts of Python. Then this binary data type will be more clear to you. Hey everyone, welcome back. In today's video we are diving into a fundamental concept in Python, the none data type. If you have ever seen none in Python and wondered what it actually means, then this video is for you. Let's get started. So first, what I'm gonna do is I'm gonna create a new Python file and I'm gonna name this none data type. Hit enter. The file got created. So let's understand the none data type now. So I'm gonna write a comment, none data type. So in Python, none is a special data type that represents the absence of a value or nothingness. It's not the same as 0 or false or an empty string. It's a distinct data type of its own, none type. So if I write the print statement and call the type function, and if I pass none, make sure to write the capital N. If you write small n, then it will throw error because it will think that it's a variable, but we haven't defined that. So make sure to use the capital N. So now if I run the code, you can see the type of this is none type. Unlike 0 or false, which are actual values, none means there is no value at all. This makes it super useful in programming. So now the question is, where is none used? Now that we know that what none is, let's explore some common scenarios where it is used. So it is used as a placeholder. For example, sometimes we don't have an initial value for a variable, so we use none as a placeholder. For example, let's say we have a variable called x, but we don't know at this moment that what value it will hold. If we keep it like this and try to print x, it will throw error because we have to put some value in this variable. But let's say at the moment of declaring this variable, you don't know what type of value will be in the x variable. So to solve that, you can assign none as initial value in x. So now if I save and run the code, you can see it prints none. So while declaring, you did not know what a value will be in x, so you put none in the variable. Then after some time or some operations, you have a value to put inside x. Then you can update the variable like x equal to 10. Here it is showing a warning which is redeclared x defined above without usage. So it doesn't matter, it's just a normal warning, it don't throw any error. So if I run the code, you can see it prints 10. So we can use none as a placeholder in a variable container. Then we can use this none type to reset a variable value. So what do I mean by that? So let me write a comment which is reset a var. So let's say we have a variable called age equal 23. Then let's say we print the age. If I run the code, you can see it prints the age 23. But let's say after some operations you want to reset the age variable. So how will you do that? So if you write age equal 0, then age will become 0. But we don't want that. We want to completely reset the value of age. So in that case, we can use none. So if we write age equal none, then write the print statement again. And if we put age here and run the code, you can see now age is none. So the value is reset. Then we can use the none data type to check for missing values. Check missing values. For example, let's say we have a variable called user input, and if I write here none, then let's say print, and if we want to check that if user input is none or not, means while we take input from user, we can check if that is available or not. So if we write user input, then the is keyword, then none. So if I run the code, you can see it prints true because here user input is none and we are checking if user input is none. So the statement is true. Now let's understand the difference between none and other values. Difference between none and other values. People often confuse none with false, 0, or an empty string. Let's see how they behave differently. So if I write the statement print, then if I write bool and inside parentheses if I pass none and run the code, you can see it prints false. And then if I write the print statement again and if I write the bool and in parentheses if I give 0 and run the code, you can see still it is false. And if I write print and again if I write bool and inside parentheses if I give empty string and run the code, you can see it is also false. To understand more clearly, we can compare them with none. So if I write print and if I write none equal 0, so we are checking if 0 and none is same or not. So if I run the code, you can see still it is giving the output false. That means none and 0 is not same. Again, if I write print, then none double equal, then empty string. If I run the code, still it is giving the output false, means empty string and none is not same. Even though all these evaluate to false in a Boolean context, none is not the same as 0 or empty string. It signifies the absence of a value, not a specific false value. So for assigning and comparing none, you should always use the is keyword instead of double equal to check if a value is none. What do I mean by that? So if a variable is z, which holds value none, so if you want to check if z is none, instead of double equal, use the is keyword. So write print statement and write z, instead of double equal, write here is keyword, then write none. So it will check if z is none. If I run the code, you can see it prints true, means z is none. The statement is true. And that's a wrap up. Now you know what none is, how it works, and when to use it. Let me know in the comments where you have seen or used none in your projects. Don't forget to like, subscribe, and hit the bell for more amazing Python insights. See you in the next video. So as of now, we understood the none data type. So next we have sequence types, which includes list, tuple, and a range. So let's take a brief understanding of these topics, then we will have dedicated videos on these topics. So I'm gonna go back to my PyCharm and create a new file, a Python file actually, and I'm gonna call this sequence data type. I'm gonna hit enter. The file got created. So first we have list data type. So to write a list, let's take a variable called fruits, and I'm gonna write the equal sign. So it's a variable. Fruits is a variable which will hold a list. So to write a list, we have to use the square bracket. Now we can have multiple elements of different data types, like string, numbers, like integer, floating point numbers, and Boolean as well. So being in the context for fruits, let's say we have free fruit. First up we have apple, so it's a string as it is a fruit name. Then we have banana, and then we have orange. So it's a list of free text or a fruit name. So if you are coming from JavaScript or C or other languages, you might know the concept of array. So list in Python is similar to array in other languages. So after defining the list, if I write the print statement and give here fruits, and if I run the code, you can see it prints the list. So list elements have something called index. So it is the first element, which is apple, and the index of apple is 0. It is the second element, which is banana, and the index is 1. It is the third element, which is orange, and the index of orange is 2. So as you can observe, index is equal to position minus 1. So the position of apple is 1, means first position, but the index would be 0. So if I write here a comment, index equal position minus 1, we can access these elements using the index. So if I write the print statement and write fruits, and again in third or square brackets, we can pass the index to print the specific element. So if I write here 0, it will try to find the 0th index element in the fruits list. So the 0th index element is apple. So now if I run the code, you can see the second print statement prints apple. And if I make this 1, it will print banana. So keep that in mind. Index is equal position minus 1. And we can change an element using this index. For example, if I write fruits, then in square brackets, if I target the second element, which is banana, using the index 1, and if I try to assign, let's say, cake, and then if I write the print statement and write here fruits, and if I run the code again, you can see the first print statement prints apple, banana, then orange. The second element was banana. But when I told to update the second element to cake using the index 1, it replaced banana with cake. So when I wrote print fruits again, it printed apple, cake, and orange. So this was list. As you can see, it is mutable, means we can change elements from list. So if anything can be changed, we call that mutable. So lists are mutable, as we can change the elements. But let's say you want list kind of thing with the similar features, but you don't want to allow the program to change the elements. So for that we have tuples. A tuple is similar to a list, but it is immutable, meaning its elements cannot be changed after creation. So if I write a variable called colors, and in between parentheses, look carefully, we used square brackets while writing list, but when we define a tuple, we use parentheses. So in between parentheses, I'm gonna write red, then another color name would be green, then let's say we have another color name which is blue. So now if I write print colors, and if I run the code, you can see it prints the colors. These also have index. The concept is similar like list. So index equal position minus 1. We can access them by their index. So if I write the print statement, and if I write colors, then in square brackets, if I give 1, it will print the second element. So run, you can see it printed green. But as tuple is immutable, we can't change the elements. So if I try to write colors, then if I target the second element using the index 1, and if I try to make that yellow, you can see it is not allowing. So if I print colors and run the code, you can see it throws an error which says tuple object does not support item assignment. So it is immutable, but lists are mutable. After tuple, we have another thing called range. It is also included in sequence data type. Range is a built-in function used to generate a sequence of numbers. It is commonly used in loops. For example, if I write a variable called numbers and equal, if I write the range function, it's a built-in function offered by Python, and in between parentheses, if I pass 5, then let's try to print numbers. So if I write here numbers and run the code, you can see it prints range 0, 5, means it has a range 0 to 5 and in between. You will understand it more clearly if we do some type conversion. We will have a dedicated video on type conversion, but let me tell you in a brief in this topic. So if I write the print statement again, and if I write list to make a range to a list, and in between parentheses, if I pass numbers and run the code, you can see it prints a list from 0 to 4. It means it stays in the range of 5, which is 0 to 4. It printed a list 0, 1, 2, 3, 4. So first it was a range from 0 to 5, but when we do a type conversion, range to a list, it made a list of 5 elements or 5 numbers. We can also create a range with a step. What do I mean by that? So if I write here even numbers equal, and if I call range, and here let's say I give a range 0 to 10, means look in between 0 to 10, and we give a step 2. So what it will do is it will start from 0 and show the number elements after 2 steps. So if I write the print statement and give even numbers, and then if I run the code, you can see it prints range in between 0 and 10, and the step is 2, but it printed as we wrote, exactly like that. So what we can do is we can again write here list to make this a list from range, and then if I run the code, you can see it prints 0, 2, 4, 6 and 8, means the even numbers which are lower than 10, or the range what we gave here. So unlike lists and tuples, range does not store all values in memory. It generates numbers on demand, making it memory efficient. So that's all the basic introduction of list, tuples and range. We will have dedicated videos on this topic later. So that's all for now. See you in the next one. So far we saw how we can statically store data in a variable and then output that in our terminal. But in real world applications, we generally take data from user. So how we do that in Python? So how can we take user input from the user? For that, we have the input method in Python. So let's see how to use that. For that, you have to declare a variable first. Let's say, for example, we have the variable name, then equal. We can then write the input method. Then we can call the method or the function. And after that, if we run the code, you can see here we have a cursor where we can write our name. So if I write here Adil and hit enter, you can see it does nothing, but the difference here is you can see the text is in green, means it is a user written text. So after user gives this value in the name variable, you can take that and use that in your program. For example, you can print that. So write the print function and write here name. And if you run the code, and again, if you write here Naruto, then hit enter, you can see it prints the output Naruto. User input is very important in real world applications. For example, where you need to take data from user. For example, let's say we have a web application or a GUI application where we need the first name and the password of the user. So if I define a variable called first name, then equal, if I call the input function, then let's say we need the password. Again, we need to call the input function. Now, let's say we want to print that your name is first name and password is password. Then if I run the code, you can see here user can write his name, for example, Naruto. Let's say the password is Hinata. And if I hit the enter key, you can see the output your name is Naruto and password Hinata. we can give here some spaces, run the code again. If I write here Naruto and password Hinata, hit enter, you can see your name is Naruto and password is Hinata. But here is a problem. How user will know that in the first place he has to write his name and in the second try he has to write the password? Maybe he can think that he have to write the password first then the name. So we have to make it clear to the user that he has to write his first name first, then after writing the first name he has to write the password. For that, in between the input function called parenthesis, we can write single or double quotes, and here we can write that write your first name, and in between the password input we can write your password. Again, if I run the code, you can see here write your first name, and here user can write his first name. So if user writes here Naruto and hit enter, you can see the second prompt where it asks for his password. You can see write your password. So if he gives the password, for example Boruto, then hits enter, you can see the output your name is Naruto and password is Boruto. So these are like placeholders for user to understand what type of data we have to give in the input function. It's not like that we can, like string, we can take a number like integer and floating point numbers as input from user. So in real world applications, the importance of user input is so much. So I hope you understood the importance of the input function. Let's understand typecasting in Python. Typecasting, also known as type conversion, is the process of converting one data type to another. Python provides built-in functions to help us with this. For example, let's say we have a variable called x, and there we have a string which is 10. So as you can see, 10 is in between double quotations. That means it's a string. Now we can check what is the type of this x. So if we write the print function and if we call the type function, and in between parentheses if we pass x and run the code, you can see the type of x is string. Even though it looks like a number, we need to convert it to an integer if we want to perform mathematical operations. For that, typecasting is necessary. Python provides two types of typecasting: implicit typecasting and explicit typecasting. So first, let's see what is implicit typecasting. So Python automatically converts data types when there is no risk of losing information. For example, let's say we have a variable called num_int, and here we have a number 5. Then let's say we have decimal_num, and that is 2.5. And let's say we want to calculate the sum of these two variables. So let's say we have another variable called result, and here we have numInt plus decimalInt. Now if I print result and also print type of result, so the type function, and in between parentheses I give result and run the code, you can see the result is 7.5 and the type of result is a float. So here Python converts 5 from an integer to a float before performing the addition. But then sometimes Python doesn't automatically convert types, so we have to do it manually using some functions provided by Python. For example, we have int function which converts something to integer, then we have float function which converts something to float, and then we have string function or the str function, which converts something to string. So let's see how those work. So before that, I'm gonna clean this code and declare another variable called x equal 10, then another variable y equal, then I'm gonna call the int function and I'm gonna pass x there in between parentheses. Here x is string, but when I pass x into int, then it turns string 10 to integer 10 and store that in the variable y. So now if I write the print function and if I try to print x, then again in the print function, if I try to print y, let's see what it prints. So I'm gonna run the code. You can see both prints 10. So now you can ask that if both prints similar things, why it is necessary to convert the types? Well, this is because if I want to do some mathematical calculations with x, it won't work because that is a string. For example, if I want to print x plus 5 means string 10 plus 5, and if I run the code, you can see it throws error. It says can only concatenate string to string, not integer. But after converting x into int and storing in y, we have an integer 10 in y, so we can do mathematical calculations with y. So if I write here print y plus 5, then if I run the code, you can see it prints 15. That means type conversion plays a crucial role in programming. Let's take another example. Let's say we have another variable called z equal 3.14. Then we have another variable called w, and let's say here we call the string function and we pass a z in between parentheses. So if we print w and run the code, you can see it prints 3.14, but it is a floating point number. But when I run the string function and pass z there, it turns the string into a floating number and then stores that in w. So if I write the print statement again, and if I call the type function and pass w and run the code, you can see the type is string. Again, the reason is if you want to write the z with a string or you want to do a concatenation, it will throw error. But when you turn it into a string and store that in w, you can do concatenation with string and w. But for example, if you want to turn a letter into a number, that is not allowed. So for example, if you have a variable called x and there you store a value called Twitter, and then you take another variable and for example you want to convert this string to integer or float, that is not allowed. So if you write the int function and pass x and run the code, it will throw error, because with common sense you can understand that these are letters, these are not numbers. So to convert a string to integer or float, that string must contain only numbers. So understanding that string must contain numbers or digits, it should not contain letters, then this int or float function cannot convert the types. Another use case I want to share, that is if you have a variable called x equal integer 10, then if you write the print statement and here if you write the int function and in between parentheses if you pass x and run the code, you can see it prints 10. And after the print statement, if I write the print statement again and if I call the type function and in the parentheses if I pass x and run the code, you can see still it is string. But you can say here I made it an integer, but when I try to print the type of x, it shows string. That is because when you convert a data into another type, you must need to store that in a variable. Otherwise, that won't work properly. So you must have to use another variable to store the new converted integer. Then you have to use that variable. So now if you run the code, you can see the type is int. Now we can do some typecasting with user input as well. For example, we are taking some input from user. For example, num1 means number 1, and we write the input function, and here we tell the user to input a number. Then let's say we have another input with the name num2, and the placeholder would be give another number. Then we can take a result variable, and there we can do num1 plus num2. Then if I call the print function and try to print result, let's see what it prints. If I run the code, you can see it asks for a number. So let's give 12, then hit enter. It's asked for another number. We can give 13 here. Then you can see it does not add two numbers. The result should be 25, but it is showing 1213. So what it did is it implicitly made num1 and num2 string. Instead of adding those two numbers, Python concatenate those two numbers, because those are strings if we consider as a data type. So as they are strings, Python concatenate them, but we expect Python should add them, treating them as integers, not string. So for that, what we can do is we can write here the int function and pass num1, and again here we can call the int function and pass num2. And now if I run the code, it will ask for a number, give it 12 again, then give it 13. You can see the correct input 23. Now it is working correctly, because now this is a number and this is also a number. So it did the mathematical addition operation. Before those were strings, that's why Python concatenate them instead of adding them. Let's understand operators in Python. So an operator is a symbol that tells the interpreter to perform a specific operation. Operators are used to manipulate data and perform various computations. Python provides different types of operators for different kinds of operations. The most commonly used operators are arithmetic operators, assignment operators, comparison operators, logical operators, identity operators. Then we have membership operators, then bitwise operators. If you scroll down here, you can see the arithmetic operators, then the assignment operators, then all the other operators. In this video, let's explore arithmetic operators. Arithmetic operators are used for basic mathematical operations such as addition, subtraction, multiplication, and division. Let's explore them one by one. First, we have addition, which is used to add two numbers. For example, we have a variable x which holds the value 10. And let's say we have another variable called y which holds the value 3. Now, if I write the print function and if I write x plus y and then run the code, you can see it prints 13. So it is the addition operator, which is this plus sign. Then in arithmetic operator, we have another operator, which is the subtraction operator. If I write the print statement again, and if I write x minus y and run the code, you can see it prints 7. Then we have the multiplication operator. So if I write x star y, it will do multiplication. If I run the code, you can see it prints 30. Then if I write the print statement again, and if I write x/y, this will do division. So run the code, you can see it prints 3.333. But if you want that it should not show the digits after the point, then you can do floor division. So let's see how to do that. So if I write the print function again and write x/y, this means floor division. So if I run the code, you can see it only prints 3 and does not print the digit after the point. Then we have the modulus operator. So if I write x percentage or mod in programming term, then y, and if I run the code, it prints 1. So 10 modulus 3, the mod is 1 because 9 divided by 3 outputs 3, and 10 divides 3, the division result is 3 and the modulus is 1, so the remainder. Then we have the exponentiation operator. So I'm gonna write the print statement again, and I'm gonna write x double star y. This means exponentiation. Let's see what it does. So let's run the code. You can see it prints 1000. So exponentiation means 10 raised to the power of 3. So x is 10, as you can see here, raised to the power of 3, which is y. So the meaning here is 10 multiplied by 10 multiplied by 10. That's the meaning of raised to the power of. So in arithmetic operator, we have plus, minus, then multiplication, then division, then floor division, then modulus, then exponentiation. Now let's see the importance of arithmetic operators. Arithmetic operators are fundamental in Python programming. They are widely used in calculations, data processing, machine learning, and game development. Understanding them will help you perform various numerical operations with ease. For example, you have an online store where some products are listed. One product has the price $22 and user buys that products with the quantity 3. So you have to show the total cost of his buyings. So the total would be item price multiplied by quantity. Now if you print total, then run the code, you can see it prints 66. So the user needs to pay $66. In this example, we used the multiplication operator to calculate the total price of items in a store, which are bought by the user. Similarly, you can use arithmetic operators in many real-world scenarios. As we understood arithmetic operators, now let's explore operator precedence. So operator precedence. So when multiple operators appear in an expression, Python follows a specific order to evaluate them. This is called operator precedence. Operators with higher precedence are executed first, and operators with lower precedence are executed later. Here is a precedence order from highest to lowest. So first we have parentheses. So if in our expression parenthesis is available, then Python will execute the parenthesis part at the first place. Then in the second place we got the exponentiation operator. Then in the third place we have the multiplication operator, the division operator, the floor division operator, and the modulus operator. So all the four of them has same level of precedence. If they are in the same level, they will be executed at the same time. Then lastly, we have the addition plus operator and the subtraction or the minus operator. They both have same priority in the precedence order. So what do I mean by that? Let's see an example to understand this better. For example, we have a variable called result where we have 10 plus 5 multiplied by 2. So what do you think? What would be the output? Exactly, the output would be 20. So if I write the print statement and pass result, it will print 20. So what is going on here? If I do like this, like 10 plus 5, 15, then into 2, it should make the result 30. But actually the value would be 20, because as you can see, we have multiple arithmetic operators in this expression. So here is the multiplication operator and the addition operator. So if you look closely in the operator precedence order, you can see this multiplication operator is in the third place, means it has higher priority than this addition operator, which is in the fourth place. So what it will do is it will first make 5 multiplied by 2 to 10, then it will do 10 plus 10, which will result 20. So if I run the code, you can see exactly the result is 20. However, if we use parentheses to change the order, we get a different result. If we put opening parenthesis before 10 and closing parenthesis after 5, now what will happen is it will do the addition calculation first, as these are inside the parentheses. You can see in the precedence order table or the list, parentheses in the first place. So first it will make this 15, then 15 multiplied by 2, it will be 30. So now if I run the code, you can see it prints 30. So here is a tip: when in doubt, use parentheses to make your expressions clearer and control the order of operations. So that's all for now. See you in the next one. Okay, let's understand comparison operators in Python. Comparison operators are used to compare two values, one with another, and return a truthy or a falsy value, means a Boolean value. So in the comparison operators section, first up we have the equal sign. This operator checks if two values are same or not. For example, if I have a variable called x and it holds the value 5 and another variable called y holds the value 5, and now if I try to print if x equal y, then run the code, you can see it prints true, means x and y holds the same value. If I make y to 6 and run the code, you can see it prints false, means x and y are not same. Now we can ask that why we are using double equal. We can use one equal, but that's not allowed because one equal means assignment. It's an assignment operator which we will learn in one of the upcoming video. But in short, assignment means assigning value. For example, here we are assigning value to x. We are putting 5 into x. But double equal means check if both are same. So one equal means assignment, means putting value inside the variable, and two equal means check if two values are same. So it is comparison operator, and one equal is assignment operator. It is quite simple. Next up, in comparison operators, we have the not equal operator. This is used when you want to check if two values are not equal. For example, we have a variable called a which holds the value 8 and another variable which has the value 7. Now if you want to print if A not equal B, then you should print true, otherwise false. So if you run the code, you can see it prints true. That means A not equal B, the statement is true. But if you make B to 8 and run the code, then A not equal B, the statement is false. So I hope you understood what this not equal operator does. Next up, in comparison operators, we have the greater than comparison, which compares if the first value is greater than the second value. For example, we have a variable C which holds a number 9, then we have D which holds variable 10. Now if I write the print statement, and if I write here a C, then greater than D, then we are asking Python if C greater than D. So C holds 9, here will be 9 greater than 10. What do you think? What would be the result of this statement? Exactly, it would be false. So if I run the code, you can see the output false. But if you make C 11 and run the code, you can see prints the result true. That means C, which means 11, is greater than D, which has 10. Next up, we have the less than operator, which checks if the first value is less than the second value. For example, we have another variable called E, which holds the value 4, and F, which holds the value 5. So if I write the print statement, and if I write E less than F and run the code, you can see it prints true. That means 4 is less than 5. But if you make this 6 and run the code, you can see it is false. That means 6 is not less than 5. Next up, we have the greater than or equal to operator. So it looks like this greater than the equal sign together. So it is called greater than or equal to operator. This checks if the left hand side value or the first value is greater than or equal to the right hand side value. For example, if I have two variables, one is G equal 4, then H equal, let's say, 5, and if I write the print statement, and if I check here G greater than or equal to H, let's see what it gives. So if I run the code, you can see the output false. That means G is not greater than, means 4 is not greater than 5 and not equal to 5. So that's why it is giving false. So if I make this 7, which is greater than 5, so as it is greater than or equal to the second one, so now it will print true. As you can see, it prints true. So either G has to be equal or greater than H. Means if I put here 5 and run the code, see, again the output is true. Then we have the less than or equal to operator. Less than, then the equal to sign together. For example, I have two variables called I equal 3 and J equal 4. If I write the print statement, and if I write I less than or equal J and run the code, you can see it prints true. That means I is less than or equal to J, as 3 less than 4, so one of the condition is true, it prints true. If I write here 4, so I less than or equal to J, so as I and J same, it will print true again. But if I make I 5, then run the code, you can see it prints false because neither the case is true. I and J is not same and I is not less than j. So these are the comparison operators we have. So as we have understood them, let's explore a beautiful concept, which is chaining comparison operators. So chaining comparison operator. I have a spelling mistake here. For example, we have a variable called p, which holds the value 6, then q, which holds the value 8. Now, if I write the print statement, we can do some comparison in a chaining manner. So we can write p less than 7 and 7 less than q. So it will check both the condition. So if this comparison and this comparison is true, then it will print true. Otherwise, it will print false. If I run the code, you can see it prints true, as p means 6 is less than 7 and 7 is less than q, which is 8. But if I make this 9, so p is less than 9, this part is true because 6 is less than 9, but 9 is not less than q, which is 8. So ultimately, if I run the code, it will print false. So if any of the comparison in the chaining comparison turns false, then the result of the full chaining comparison will be false. If every comparison is true, then only the result will be true. So I hope you understood the comparison operators. So that's all for now. See you in the next one. In Python, logical operators are used to combine conditional statements. These operators allow you to make complex decisions by combining multiple conditions. The three main logical operators in Python are the AND operator, the OR operator, and then the NOT operator. Let's break them down one by one. First up, we have the AND operator. The AND operator combines two conditions and returns true only both conditions are true. For example, let's say I have a variable called x equal 5, then y equal 10. Then let me write the print statement, and here what I'm gonna do is I'm gonna write x, then greater than sign, then 3. Now this is a condition which I'm checking if x is greater than 3, which means 5 is greater than 3, as x is equal to 5. Now let's say I want to combine this condition with another condition. In these cases, we use the logical AND operator. So what we can do is to combine, we can use the AND operator here like this. Then after the AND operator, we can write another condition. So for example, I can write y less than 15. So in case of AND operator, if the both condition is true, then it returns true. Otherwise, if either of them is false or both of them are false, then it returns false. So if I run the code, you can see the output true. But let's say if I make x equal 2, then this logic or this condition becomes false because 2 is not greater than 3. So if either one of them gets false, then the ultimate result will be false. So now if I run the code, you can see the result false. But now if you make the sign less than and run the code, you will see the output true, because now x is 2, which is less than 3. So this part is true and this part is also true. When both condition is true and those are using the AND logical operator, then it returns true. So in broader context, what we can say is, if there is an AND logical operator and if the left side condition is true, it is a left side condition. So if left side condition is true and the right side condition is also true, then only the result is true. If left side condition is false, right side condition is true, then ultimate result is false. If left side result is true, right one is false, then the ultimate result is false. If both conditions are false, then also the result is false. So only if left condition and right condition both are true, then only the ultimate result will be true. Otherwise, they will be false. Now you can add more condition using the AND operator. For that, after the second condition, which is this one, just write the AND operator again. Now let's say you have another variable called z, which holds the value 15. Now you can check if z is less than 20. So now it will check if all of the three conditions are true or not. If all of them are true, then only it will return the result true. If one of them is false, whether it is this one or this one or this one, the result will be false. If I run the code, you can see as all the three conditions are true, it prints true. So I hope you understood the logical AND operator. Then we have the logical OR operator. So logical OR operator. The OR operator is used when you want the overall condition to return true if either of the condition is true. Let's see the example. Let's say I have a variable called a equal 5, then let's say b equal 10. Now if I write the print statement, and if I write a greater than 3 or b less than 5 and then run the code, then you will see it prints true. As you can see here, a, which means 5, is greater than 3, and here b, which is 10, is not less than 5. But as either one of them is true, the ultimate result is true. So unlike the AND operator, the OR operator only expects one condition should be true among all the conditions. For example, if I write here a less than 3 or b greater than 5 and let me run the code, you can see the result is true. Here 5 is not less than 3, this is false, but b, which is 10, is greater than 5, that is true. So as one of them is true, the ultimate result we get is true. So let's say if both of them are false, then we will get the result false. So ultimate decision here is for OR operator, if left side condition, which is this one, is true and right side condition is also true, then the ultimate result will be true. If left side condition is true but right side condition is false, then also the result will be true. If left side result is false and right side result is true, then also the result will be true. Only if both side condition is false, then only the result will be false. Now let's talk about the logical NOT operator. So NOT operator. The NOT operator is a unary operator, meaning it only works with one condition. It's used to reverse the result of the condition. Now let's say I have a variable called p, which is equal to 5. Now if I write the print statement and check if p is greater than 3, the result will be true. As you can see, the result is true. What the logical NOT operator does is reverse the condition. So as the condition is true, you can see, but if I pass this to the logical NOT operator and run the code, you can see it returns false. So what NOT operator does is it turns a true statement into false statement, and it turns false statement to true statement. So for example, Let's say we are checking if p is less than 3, means 5 less than 3. This should return false. So let's say if I remove the not operator and run the code, you can see the condition is false. But if I write the not operator and pass this condition and run the code, you can see it made false to true. So I hope you understood what the not operator does. It converts a true statement to false statement and false statement to true statement. Logical operators really shine when you start combining them. You can combine and, or, and the not operator to create more complex conditions. For example, let's say I have a variable called x which is equal 5, then a variable called y which is equal 10, and another variable which is z, and that is equal to 20. Now let's combine the and the not operator. So what we can do is we can write the print statement and check if x is less than y, meaning 5 is less than 10, that is true, and not z greater than 30. So x, which is 5, is less than 10. The left side of the AND operator is true. The right side of the AND operator, which is z, meaning 20 greater than 30, this is false. But when you are writing the not operator, this turns this false statement into a true statement. So as now this is true and this is also true, the ultimate result will be true. If I run the code, you can see the result is true. If I don't write this not operator, you will see it will return the result false. As you can see, the result is false. That is because 20 is not greater than 30. The condition is false. But if you write the not operator, it will turn the false condition into a true condition. So as both of them are true, it will give the result true. So let's see another use case. So let me write the print statement again. And here, let's say I'm checking if x is less than y, meaning 5 is less than 10, which is true, or z is greater than 10, means 20 greater than 10. So in my case, both of them are true. If I run the code, you can see the result is true. But let's say I'll write the not operator, and if I wrap the both conditions in between parentheses, the true condition will be turned into false. As you can see, the result is false. Look here carefully. We are using parentheses here when writing more than one condition. It is really important to understand when we write more than one condition. If we want to invert both conditions or all of the conditions, then we have to wrap all of them in parentheses. But if there is only one condition, like here you can see z is greater than 30, if there is one condition like this, we can just use the not operator without parentheses. But while using more than one condition, and if you want to invert the ultimate result of those conditions, then using parentheses on those conditions is necessary. So I hope you understood the logical AND, logical OR, and the logical NOT operator. So that's all for now. See you in the next one. Let's understand identity operators and membership operators in Python. First, let's talk about the identity operators. These operators are used to compare the memory locations of two objects. In other words, they check whether two objects are actually same object in the memory, not just they have the same value. So in identity operators, we have two operators. One is operator, then another one is not operator. These two are called identity operators. Let's start with the is operator. Let's say we have a variable called a, and that is equal to a list which holds the value 1, 2, 3. Then let's say we have another variable called b, which is equal to a. Then let's say we have another variable called c, which is equal to the same list, which is 1, 2, 3. Now if I write the print statement, and if I write a is b and run the code, you can see the output is true, because here we assigned a into b, but the c holds the same list which is also in a. But if I write the print statement again, and if I write here a is c and run the code, you'll see the output false. Here a is b, this statement is true because b is assigned to a, meaning they point to the same object in memory. But a is c, this is false because although a and c have the same values, they are two different objects in memory. So remember, the is operator checks if two variables point to the same object in memory, not whether their values are identical. Now let's talk about the second identity operator, which is the is not operator. And this does exactly the opposite task which the is operator does. This operator checks if two variables do not refer to the same object in memory. For example, let's take the previous example with different variable names. For example, p equal a list which is 1, 2, 3. Then let's assign p into q. So q equal to p. Then let's say we have another variable called r, which has the identical value of p, which is 1, 2, and 3. Now let's take the print statement and let's check p is not q. If I run the code, you will see the result is false because they point to the same object in memory. So p is q. As we are writing the statement p is not q, the statement is false. But if we write the print statement again, and if we write p is not r, then this will return true. As you can see, the output is true because although they contains identical values, they are not pointing to the same memory object. That's why p is not actually r. So that statement is true. So the ultimate result here is true. Now let's switch gears and talk about membership operators. Membership operators. These are used to check if a value exists inside a sequence like a list, tuple, string, or set. And the two membership operators are the in operator and another one is the not in operator. Let's say we have a list of fruits which holds a list and the values are apple, then let's say banana, and then we have cherry. Now let's write the print statement, and here if I write apple in fruits and run the code, you will see it prints true. That means apple is in the fruits list. But let's say if I write here cake in fruits and run the code, you can see the output is false because cake is not present inside the fruits list. But again, if I write banana in fruits and run the code, you can see that prints true. So the in operator checks for if the value is a part of sequence, and that can be a list, a tuple, a string, or a set. For example, if I make this to a tuple and run the code, you can see when I write cake in fruits, that returns the result false. But when I write banana in fruits it returns the result true. Then after the in operator, we have the not in operator, and it does the opposite thing what the in operator does. So for example, let's say we have another list called games, and that list contains football, then cricket, and let's say badminton. So now if I write the print statement, and here if I write cricket not in games and run the code, you can see the output is false. That means cricket is not in games. This statement is false because cricket is present, as you can see in the games list. But let's say if I write here chess and run the code, you can see the statement now is true because chess is not in the games list. If I write the print statement again, and if I check if the football is not in games and run the code, you can see this returns the output false because football is there in the games list. So I hope you understood the identity and membership operators in Python and how to use them and why we use them. So that's all for now. See you in the next one. Before we get into the bitwise operators, let's first talk about binary representation. Computers store numbers as binary, meaning only zeros and ones. For example, the number 5 is stored as 101. So number 5 stored as 101. If we want to manipulate numbers at the bit level, we need to understand how they work in binary. Now Python gives us several operators to manipulate individual bits. These are known as bitwise operators. So first up we have bitwise AND operator. So bitwise AND operator, and it is represented by this sign. It is called bitwise AND. This operator compares two numbers bit by bit, and the result will only have 1 if both bits are 1, otherwise the result will be 0. Let's take a look at this in binary. For example, let's consider numbers 5 and 3. For example, a equal 5. So if you convert 5 into binary, that will be 1 0 1. So it is a decimal number system which we human use to express values, and this is binary number system which the machine uses. Then let's say we have another variable b equal 3, and in binary it is 0 1 1. If we take another variable called result and write a bitwise AND then b, then if we print result, let's see what it prints. When I run the code, you can see it prints 1. So let's see what is happening under the hood. So here, as you can see, we have 1 at the last position for 5 and 1 as the last position for 3 as well. So if both are 1, it will print 1. But if one is 0 and another one is 1, means they are different, then it will return 0. Again, you can see in this position 5 has 1, and in this third last position 3 has 0. That means they both are not same. So here also it will be 0. Means if both is 1, then only we get 1. Otherwise, if they both are 0 or either one of them is 0, then we get 0. So that means the ultimate result we get is 0 0 1 in binary. And if we convert this binary to decimal number system, then it is 1. So that's the concept of bitwise AND operator. It checks bit by bit. Then we have bitwise OR operator. So bitwise OR, and we express that with this sign, this one. This operator compares two bits at each position, and the result will be 1 if either bit is 1. So let's, for example, we have another variable c equal 5 and d equal 3. In binary, 5 means 101 and 3 means 011. Now if I take result 2 variable and if I write c, then bitwise OR d, and if I print here result 2, then run the code, let's see what happens. So it prints 7. So let's understand what is happening here. So in bitwise OR, if either bit is 1, then the result will be 1. So here both were 1, so it will give the result 1. And here, as you can see, in the second last position, for 5 we have 0 and for 3 we have 1, but it says either one should be 1. So as one of them has 1, then we get 1. Again, for the first position, you can see one of them got 1. So here we will get 1. So we will get a binary representation which is 111. If we convert this 111 to decimal, then we will get 7. So the conclusion here is, in bitwise AND, if both has 1 in the same position, then only it gets 1, otherwise 0. But for bitwise OR, if both has 0, then only it returns 0. Otherwise, if both of them has 1 at same place or same position, or one of them has 1 at the same position, then it returns 1. So I hope you understood the concept here. Then we have the bitwise NOT operator. So bitwise NOT operator, which we express by this sign which is called tilde or tilde. This operator inverts all the bits of a number. If a bit is 0, it becomes 1. If it's 1, then it becomes 0. It's important to note that in Python, the tilde operator works on 2's complement representation, which means it also handles negative numbers differently. Specifically, the result of tilde a is minus, and in between parentheses, a plus 1. You will understand after the example. So let's try it with the number 5. For example, we have a variable called e, and there we have the value 5. And let's say we have another variable called result 3, and there let's use tilde e. Then let's print result 3. Let's see what output we get. So if I run the code, you can see it prints -6. Here 5 is 101 in binary. When we invert the bits, we get 0, 1, 0. As you can see, it turned 1 to 0 and 0 to 1. Then again this 1 to 0. For example, if we have 5 more 0 before the 101, it would add 5 1 after the conversion. So the conclusion here is this bitwise NOT operator inverts all the bits. So if it is 0, it will make that 1. If that is 1, it will make that 0. So as you can see, we get 1 1 1 1 1 0 1 0 in 2's complement. As you can see, if I write the formula here with variable e, you can see if E is 5, then the formula here is 5 plus 1, and before that we have minus. So 5 plus 1 is 6, and before 6 we have minus. So the ultimate result is minus 6. Then we have the bitwise XOR operator. So bitwise XOR, we express this with this symbol. XOR stands for exclusive OR. It compares two bits and the result is 1 if the bits are different. If they are the same, the result is 0. For example, let's say we have variable f equal 5, which is 101 in binary, then g equal 3, which is 011 in binary. If we take another variable called result 4, and if we do a, then XOR b, then print result 4, you will see the output 6. So what is happening here is, if I show you, so in bitwise XOR, if both bit is same at the same place, then it will return 0. But as you can see, in the second place for 5 it is 0, and in the second place for 3 it is 1. So the second place is different for the values. So if they are different, then it will return 1. As you can see, here 1, here it is 0. Again it will return 1. But if the bits are same at the same place, you can see it returns 0. If we had 0 here and 0 here, then also it would return 0. So if bits at the same place are same, then it returns 0. Otherwise, if they are different, then the result becomes 1. So ultimately we get 110. And if we convert this binary to decimal, then we get 6. After that, we have bitwise left shift, which we write with this symbol, double less than sign. This operator shifts the bits of a number to the left by the specified number of positions. Every left shift operation is equivalent to multiplying the number by 2. Let's shift the number 5 one position to the left. For example, let's say we have the variable h, which holds the value 5 in binary, which represents 101. And let's take another variable called result 5 and equal, let's say h, then we want to do left shift by 1. So what it will do is, it will move each bit one position left. So for example, here, let's say we have 5 more zeros. So after the left shift, what it will do is, it will push this 1 to this place, and this 0 to this place, and this 1 to this place. So it will push every bit one position left, because we told here 1. If we write here 2, then it will push this 1 to this place, and it will push this 0 to this place, and this one to this place. So as you can see, the last element would be 0, because when we push this 1 to this place, the right side becomes 0. So here this 1 is going to this position. So here we will get 1, and this 0 will go to the position of this 1. So here it will be 0, and this 1 will be go to the position of this 0. So here we will get 1, and this 0 will go to the position of this 0. So before that, other elements would be 0. So as you can see, the final output we get is 1010. So if we print result 5, it will print this, which represents the decimal number 10. So we will get the output 10. As you can see, 10. So 1010 in binary is equivalent to 10 in decimal. Lastly, we have bitwise right shift. For example, let's say we have another variable called I equal 5 in binary, which is 101, and let's take another variable called result 6, and let's do I, then right shift one position. So we express right shift by this double angle bracket, or the closing double angle brackets, I mean. So like the left shift, right shift will push the bits one position right. So ultimately what will happen is, as you can see, we have 101. After the right shift, it will become 0 1 0, because this 1 will get right, and as you can see, this 0 gets one position right and goes to the last position, and this 1 goes one position right and goes to the second last position, and before 1 we have much more zeros, and one of the 0 comes to the third last position. So it becomes 0 1 0, which is 2 in decimal. So if I write the print statement and pass result 6 and run the file, you can see we get the output 2. One common mistake when working with bitwise operators is not understanding binary representation. You need to be comfortable with how numbers are represented in binary, especially when dealing with negative numbers and the two's complementary representation. I hope you understood bitwise operators in Python. It doesn't matter if you don't understand some concepts or some topics didn't click to. I know this topic a little bit tricky, but you will get used to it by time. So watch the video twice or thrice and continue learning other concepts of Python. By time, these concepts will be eventually get easier to you. Don't get scared or too much bothered if it feels hard. The next topics will be much easier, and some topics will be harder as usual, but keep going. If some topics are hard, watch the videos twice and practice more on those topics, and even then, if those feels hard, keep learning other concepts, and when you have free time, practice the hard concepts. Eventually, these will get easier. So that's all for now. See you in the next one. Alright, so first things first, what is an assignment operator? In Python, assignment operators are used to assign values to variables. And believe it or not, there are several types of assignment operators that give us more control over how values are assigned. So let's break them down. So first we have the equal sign. The most common one you have seen is the simple equal sign. It is the basic assignment operator. You use it to assign a value to a variable. For example, let's say we have a variable called x, then we have this assignment operator which is equal, then we can write 5. Now Python assigned this 5 value to this x variable. Pretty straightforward, right? But here's where things get interesting, because next we have the add and assign operator. So the add and assign operator, and we express that by writing plus and equal together, and this operator adds the right hand side value to the left hand side variable and then assigns the result back to the left hand side variable. For example, let's say we have a variable called y, and that is equal 5, and if I write here y plus equal 3, what it will do is it will add 3 with the previous value which was 5, and it will make 8 inside y. So now if I write the print statement and pass y, you will see the output is 8. it is basically a shorthand for this statement, which is y equal y plus 3. If I comment this line and again run the code, you will see the same result. So here we are doing an arithmetic operation, and after we get the result, we reassign the result into the y. But we can do that with shorthand notation by writing this line. So I can comment this line and uncomment this line, and you will see both gives the same output. Next up, we have the subtract and assign operator. So subtract and assign, and we express that by writing minus and equal together. This one also works just like the add and assign operator, but it subtracts instead of adding. For example, if I write a variable called z which holds the value 9, and if I write here z minus equal 2, then if I write the print statement and pass z and run the code, you will see the output 7. So it is basically the shorthand notation for z equal z minus 2. This line and this line are doing exactly the same task. After subtract and assign operator, we have the multiply and assign operator. So multiply and assign operator, and we express that by writing star equal together. So for example, we have a variable called x equal 3, and let's say if I write x multiply equal 4, and if I write the print statement and try to print x and run the code, you will see the output is 12. So here it is the shorthand notation for x equal x into 4. So behind the scene, it is doing this arithmetic operation. After this, we have the divide and assign operator, and we express that writing / equal together. For example, we have a variable called y which holds the value 12, and if I write here y / equal 4, which is a shorthand notation for y equal y / 4, then if I write the print statement, you will see the output 3.0. Where on the code, you can see it prints 3.0. But if you don't want digits after the point, then you can do floor division and assign. So next up, we have floor division and assign. We express that by writing 2 / and equal together. So let's say we have another variable called z which is equal 10, and if we do z / equal 3, and then if I try to print z, instead of 3.33, it will just print 3. So if I run the code, you can see it just prints 3 without the digits after the point. Next up, we have the modulus assignment operator. So modulus and assign operator, and we express that by writing the %sign and the equal sign together. So for example, let's say we have another variable called x which is equal 10, and if I write here x mod equal 4, and if I write the print statement and pass x, you will see the output 2. So here it is a shorthand for x equal x mod 4, and there in the floor division and assign, it was shorthand for z equal z floor division 3. After modulus and assign operator, we have the exponentiation and assign operator. So exponentiation and assign operator, and we express that by writing 2 * and equal together. This one raises the variable to the power of the value on the right hand side. Let's say we have a variable called y which is equal to, and let's say if I do y then star star equal 3, and if I write the print statement and pass y and run the code, you can see the output is 8. So it is the shorthand notation for y equal y exponentiation 3. And finally, there are bitwise assignment operators. So bitwise assignment operators. In the previous video, we saw some bitwise operators and how they works. So there we learned about bitwise AND operator, bitwise OR operator, bitwise XOR operator, bitwise left shift operator, and bitwise right shift operator. So these are the bitwise operators which we learned in the previous video. Now here comes the topic, which is bitwise assignment operators. So if we add a equal sign with the bitwise operators, for example, if I add this equal sign with the bitwise AND operator, then it becomes bitwise AND assign operator. If I add the equal sign with the bitwise OR operator, then it becomes bitwise OR assign operator. If I add the equal sign with the bitwise XOR operator, then it becomes bitwise XOR assign operator. If I add equal sign with the bitwise left shift operator, then it becomes bitwise left shift assign operator. If I add the equal sign with the bitwise right shift operator, then it becomes bitwise right shift assign operator. So these are just shorthanded notation for the bitwise operators. They exactly do the same things which we learned in the previous videos. These are just shorthanded notations. So I'll suggest to watch the previous video. These are less common but still super useful when working with binary numbers or low-level operations. These operators are useful for manipulating bits. So let's see an example. Let's say we have a variable called a which is equal 5, and then we have b equal 3. So in binary 5 means 0 1 0 1 and 3 means 0 0 1 1. So while learning bitwise operators, what we used to do was we declare another variable called result, then there we did our bitwise operation. For example, a bitwise AND b. Then we used to print the result. So if I run the code, you'll see 1. So here what is happening is it is comparing the values bit by bit. So if the last bit of both value is same and both are 1, then only it returns 1. If both of them are 0 or either one of them 0, then it returns 0. So ultimate binary result is 0001, which is 1 in decimal. But we can make this code shorter by using bitwise AND assign operator. So instead of writing another variable, what we can do is we can write a, then bitwise AND, then equal b. So what it will do is it will do bitwise AND operation between a and b, then it will put the result inside a. So now inside a we are having the result 1, which is 0001 in binary. So we don't have to write another extra variable. We can just use a. But keep in mind that when you do this, you'll lose the actual value which was inside a. In this case, we lose the value 5 because it did a bitwise AND operation between a and b, then it stored the result inside a, removing the previous value of a. So now a holds the value 1. So when you run the code, you can see the output is 1. So like this bitwise AND assign operator, these bitwise assignment operators do bitwise operation with shorthand codes what we learned in the previous video. So again, I will suggest to watch the previous video. So that's all for now. See you in the next one. Swapping means exchanging values. It's a simple operation, but there are many different ways to achieve it in Python. Some methods are more Pythonic than others, and some might even surprise you. So let's say we have a variable called a, which is equal 5, and another variable called b, which is equal 10. Now I want that this 10 should go inside a and this 5 should go inside b. So how will you do that? Now you can say we can do like this. So a equal b, then b equal a. But the problem is when you print a and again if you print b and run the code, you will see both prints 10. But b should hold 5, as we want that this 5 should go inside b and this 10 should go inside a. But now a and b both are holding the value 10. So why is that? That is because previously a has the value 5, but when we say a equal b, then we are assigning 10, which was inside b, into a. So now a is equal 10 and b is equal 10 as well. So as we made a 10 in this line, so when we say b equal a in this line, b remains 10 as well. So to swap them properly, we have plenty of ways. Among them, the classic and the most straightforward method is using a temporary variable. You assign the first number to the temporary variable, then assign the second number to the first variable, and finally assign the temporary variable's value to the second variable. What do I mean? You will understand after I give you the example. So instead of writing like this, what we can do is we can write another variable called temp or temporary. You can name this anything, and here what we can do is we can store the value of a, means the original value of a, which is 5, as you can see here. So temp variable now holds the value 5. A also holds the value 5 in this line. After this line, in the line number 5, what we can do is we can write a equal b. So now a becomes 10, because as a is equal to b and 10 is inside b, so the ultimate value in this line for a is 10. But we lost the original value of a, which was previously 5, and that doesn't matter now because we stored that here in the temporary variable. Now what we can do is we can write b equal temp. So temp equal was 5. Now as we are telling that b equal temp, so b is becoming 5. So now if I run the code, you can see a prints 10 and b prints 5. That means the swapping is complete. So the swapping we did by using the temporary variable. But let's say you don't want to use temporary variables. Then how can we do that? We can do that using arithmetic operations. For that, let's say we have a variable called x, which is equal 5, then another variable called y, which is equal 10. And what we can do is we can write here x equal x plus y. So here what is happening behind the scene is it is becoming x equal x means 5, then plus y, which holds the value 10. So here 10. Then the ultimate value we get is 15. So after this line, x becomes 15. But we lost the original value of x, which was 5. So let's see how we can do the further task. So after this line, we can write y then equal and x minus y. So here what is happening is we are telling y equal x, which is now 15 after this line. So x means 15 minus y, which is still 10. So it becomes 5. So in this line, y becomes 5. So one process is done. We put 5 inside y. Now to put 10 inside x, what we can do is, again we can write x equal x minus y. And here what is happening is, we are telling that x equal x, which is 15, as you can see here, minus this y, and here you can see y is equal 5. So 15 minus 5, and that is equal 10. So ultimately x becomes 10. So now if I write the print statement and pass x, and if I write the print statement again and pass y, you will see the output 10 and 5. Let me take another values so you can understand properly. Let's say x equals 6 and y equal 8. So we want to put 6 into y and 8 into x. So this statement should print 8 first, then in the last statement when you print y, it should print 6. Let's run the code. You can see it does exactly the same thing. Here we are doing a little math magic. This works because we are manipulating numbers directly, but it's important to remember that it can sometimes lead to overflow issues if the numbers are very large. Then we can do the swap using tuple assignment. So we can do swapping using tuple or tuple assignment. It is the most Pythonic way to swap two numbers. Python allows us to assign multiple variables in a single line, and this feature makes swapping two numbers super simple and clean. For example, let's say we have two variables called p equal 2 and q equal 3. And to do the swap using tuple assignment, what we can do is we can write p comma q equal q comma p. Now here we are telling Python to put the value of q inside p and to put the value of p inside q. As we are reassigning the values in the same line, the previous value are not getting lost while reassigning. So now if I write the print statement, and first if I pass p, and again if I write the print statement and pass q, and then if I run the code, you can see the swapping works exactly how we wanted. P prints 3 and this q prints 2. So the swapping is successful. There are more ways to swap two values using XOR operator, which is a bit more low level than using a list or using a stack, but let's not see those examples because these three examples are more used than those ones, and these are usually enough to work with swapping, especially while considering your learning stage. So we got a brief idea about lists in our sequence type data type in a previous video, but let's understand lists in depth in this video. So what exactly is a list in Python? Simply put, a list is an ordered collection of items that can store multiple values in a single variable. Lists are incredibly flexible because they can hold different data types like numbers, strings, even other lists. For example, let's say I have a list, so I'm gonna name this variable called mylist. Then here what I can do is in square brackets I can write 10, which is an integer. Then I can have a string called hello. Then let's say I can have a floating number like 3.14 and a boolean as well like true. And now if I write the print statement and provide the mylist list and run the code, you will see it prints my list. Here my list contains an integer which is 10, a string which is hello, a floating point number which is 3.14, and a boolean which is true. Python doesn't restrict us to one data type per list, unlike the other programming languages like C or others. That's the beauty of it. These lists have some characteristics, like lists are ordered. The order in which we define elements is preserved. Lists are mutable, so we can change, add, or remove items anytime. Lists allow duplicates. Unlike sets, lists can have repetitive values. So let's understand what do I mean by that. So for example, let's say I have another list called fruits, and there I can have a list of some fruits. For example, I have apple, then let's say banana, then cherry, and then apple again. Now if I print fruits and run the code, you will see it prints the fruits, and it printed as we defined. So as I told before, that lists are ordered. So in which order we define, it prints in that order. So the order is preserved, and there is a set data type in Python where we can't use duplicate values. But as you can see, in lists we can use duplicate values. Like you can see, we have apple 2 times in the fruits list, and creating a list is always super simple. You just have to write a variable name and then you give square brackets and put some values like this. For example, we have a numbers list, then we can have words list which may contain some strings like Python, then JS, then C. We can have mixed list like the previous one. As you can see, we can write mixed list. Now here we can put values of different data type like 1, then Python, then 3.14. You can even create an empty list like this. For example, let's name this variable called sum underscore list. And if you just put the square bracket and don't give any value, then it will called an empty list. So if I write the print statement and pass this sum list, and if I run the code, you will see it prints just the square brackets. That means it's an empty list. Now let's understand how to access list elements. For example, we have another list called colors, which holds some values like red, then green, then let's say blue, and yellow. Now lists have some property called as index, and that is expressed via the position -1. So for example, this red is in the first position, so it will have the index 0. This green is in the second position, so it will have the index 1. This blue is in the third position, so it will have the index 2. So ultimately, index is equal position -1. So for example, if I write the print statement and if I write colors, then if in the square brackets, if I put 0 and run the code, you can see it prints red. Again, if I write the print statement and if I write the colors list and in between square brackets, if I put 2, then it will print blue, as blue has the index 2 because it is in the third position, and we know index equal position -1. But what is the interesting thing here is we can access values using the negative index as well. So for example, if I write the print statement and again if I write the colors list and in between square brackets, if I write -1 and run the code, you can see it prints yellow. So negative indexing starts from the end. So it is the first element at the end. For example, this one holds the index -1, this one holds -2, and this one holds -3, and this one holds -4. So for example, if I write the print statement again, and if I write the colors list, and if in between square brackets I pass -3 and run the code, you will see it prints green. Now let's understand list slicing in Python. So we have a list slicing. So slicing allows us to extract parts of a list. It's done using start, colon, and indices. For example, let's say we have a list called numbers 2, and let's say there we have values 10, 20, 30, 40, 50, and 60. So now if I write the print statement, and here if I write numbers 2 list, then in between square brackets if I pass 1, colon, 4, then what it will do is it will take 20, then it will take 30, and this will take 40 as well, because this has the index 3. Keep in mind that if you put here 4, it will take the values to index 3. So if you take here 6, then it will take values to index 5. So always keep in mind that which value you need, you put an index ahead. So what do I mean by that? Let's see the output now. If I give here 4 and run the code, you will see it prints 20, 30, and 40. Now here this means take the value of index 1 and the next values until the value of index 4. So in index 4 we have 50, but we don't want that. We want the values before index 4. So if I write here 5, now fifth index value is 60, but we don't want 60, we want the value before the fifth index value. That means we want 20, 30, 40, and 50. If I run the code, you will see it prints 20, 30, 40, and 50. Now here you will see another magic. If I write here print, and let's say I pass the numbers to list again, and in between square brackets if I write the colon and write 3 here, so it will put 0 here automatically. We don't have to write that. Python will consider that he has to start from 0th index. So if I run the code, you will see it starts from 0th index value, then it goes to 1th index value, and it goes to 2nd index value. So as we have 3 here, Python only get the values which are before of that index value. And if I write the print statement again and pass the numbers to list again, and in between square brackets if I pass 3 colon empty, what it will do is it will start from the 3rd index and it will print all the values from that index to the end. So if I run the code, you can see it started from the 3rd index, which is this 40, then it printed 50 as well as 60 till the end. Though we had looked the difference between list and tuples in our sequence type data type video, let's recall that again. So keep in mind that lists are mutable, tuples are not. So for example, I have a list with the variable name mylist2, which holds values like 1, 2, 3, and then let's say I have a tuple which is my tuple2, and that also holds a value 1, 2, and 3. But the key difference here is we can change the list by the index. So what I can do is I can write my list2, then in between square brackets I can pass 0 to target the 0th index value, and then I can assign 10 here. So now if I write the print statement and pass my list2 and run the code, you will see it becomes 10, 2, and 3 instead of 1, 2, 3. But we can do that with tuples. So for example, if I write here my tuple2 and try to target the 0th index value, which is 1, by the index 0, and try to assign 10, then you can see it already indicates warning here with the yellow underline. So if I write the print statement and if I pass my tuple2 and run the code, you will face an error. As you can see, Python throws this error, and the error is tuple object does not support item assignment. So I hope you understood how lists work in Python. So let me clear this example to remove the error. So that's all for now. See you in the next one. Lists in Python are mutable, meaning we can change their contents. Whether you want to update a product price, edit a name, or modify game settings, lists make it super easy. To change an item in a list, simply use indexing and assign a new value. For example, we have a list called fruits, and there we have some values. For example, apple, then banana, and then cherry. We can change the values using indexing. So we can write here fruits, then in square brackets, if I pass 1, then equal, and if I put the value mango and then print the fruits list and run the code, you will see it prints apple, mango, and cherry instead of apple, banana, and cherry. So the important thing here to remember is indexing in Python starts at 0, so fruits 1 refers to the second item. And now let's see how we can change multiple items at the same time using slicing. So let's put a comment changing multiple items, and let's start with a new example. Let's say we have another list called numbers, and there we have some values called 10, 20, 30, 40, and 50. So to change multiple items, what we can do is we can write the numbers list here, and in between square brackets what we can say to Python is start from index 1, which is 20, and then in colon what we can say is 3, means to the second index element. So if you write here 4, then it will target to the third index element. So the value which you want to target, instead of that value's index, put here the position of that element, means index plus 1. So now if I write the equal sign and in between square brackets if I write 99, 88, and if I write the print statement and pass numbers and run the code, you can see it prints 10, 99, then 88, 40, and 50. So here, as you can see, it replaced the 1th index value and the 2nd index value with 99 and 88. So it replaced 20 with 99 and it replaced 30 with 88. So keep in mind that you have to use the index before the colon, and you have to use the position, which is index plus 1 after the colon. Now let's see replacing with more or fewer items. That is a cool part. We can replace multiple items with different number of values. So what do I mean by that? To understand that, let's have another list called letters, and there let's say we have a list which have some letters called A, then B, then C, and the letter D. So what we can do is here we can target two values by slicing. So for example, if I write here letters, then in between square brackets if I put 1, means start from 1th index to 3rd position, means we are targeting B and C, and by replacing them put there X, then Y, and then Z. So what Python will do is Python will put these 3 letters instead of these 2 letters. So it is not necessary that we have to put 2 values for replacing 2 values. We can replace 2 values with 1 value or 3 value or even as many as values we want. So now if I write the print statement and pass the letters list and run the code, you will see it prints A, and instead of B and C it prints X, Y, Z, then it prints the D, which is this one. So here we replaced B and C with more elements means 3 elements, but we can do that using fewer elements. So for example, if we want to replace B and C with only just X, we can do that as well. So now if I run the code, you will see it prints A, and instead of B and C, it prints X, then it prints D. Now we can change items with a loop as well, but we haven't learned the loops as of now. So when we will learn the loops, we'll see how to work with lists. For now, let's see how we can reset a list. So after we print all the letters, what we can do is we can reset this list by writing letters again and then equal, and just write the empty square brackets. Then if you write the print statement and pass letters, what it will do is it will remove all the list's elements. So if you run the code, it prints empty list. These statements prints the actual list from this list, and in this line when we say letters equal empty square brackets, then it resets the list. So as you can see, it prints just the empty square brackets. Alternatively, we have a .clear method to clear all the values in a list. So what do I mean by that? So here, as you can see, we have this numbers list which prints this one. But after printing the numbers, let's say we want to reset the numbers list. So what we can do is we can write numbers dot clear method, and if you call that, then if I write the print statement again and pass numbers and run the code, you will see it prints empty list. That means numbers list is now empty. Now let's understand how to add items to lists in Python. So the simplest way to add an item to a list is by using the .append method. It adds the new item to the end of the list. So what do I mean by that? We can understand that properly after I give you an example. So let's say we have a list called fruits, and there we have apple, then banana, and cherry. Now to add a new item to this list, what we can do is we can write fruits, then after fruits we can write a dot, and we can call a method which is append. So every list has this .append method, and in between parentheses what we can do is we can pass a value. So for example, we want to append mango. After appending that, if I write the print statement and pass fruits and run the code, you'll see it prints apple, banana, cherry, then it appends mango and prints mango after them. So the key point here is .append method adds the item at the very last of the list, and it adds items one at a time. So we can't add multiple values at a time using .append method. But let's say you want to add a value in the middle of the list. You don't want that always it should add the item to the end of the list. You want to add an item here or here after banana. So how will you do that? So for that, what we can do is we can use the insert method. So for example, let's say we have another list called numbers, and there we hold values like 10, 20, 30, 40, and 50. Now let's say we want to insert 15 in between 10 and 20. So for that we can use the insert method provided by Python. So for that, first we have to write the numbers list, then write the dot to call the method, and the method is insert. And in this method we have to first pass the index where we want to insert. So as we want that 15 should be after 10, which holds the index 0, so we want 15 should be at 1th or the first index. So here let's give 1, and then after the comma we have to give the actual value which should be inserted. So the value would be 15. So here you can see it says __ index : 1. So this is just some instruction by PyCharm that is solely for development purpose. You don't have to worry about that. And you can see it says __ object and instruct us which value will be inserted, and that is 15. Now if I write the print statement here and pass numbers and run the code, you will see after 10 it printed 15, then it printed other elements. So the key point here is the first number inside insert is the index and the second is the new value. Now as of now we are adding values one by one, but let's say you want to add multiple values at the same time. So how will you do that? So for that we can use the .extend method. So for example, let's say we have another list called colors, and there we have a list of items which are red, then blue, and now let's say we want to add 3 more colors to this colors list. So how will we do that? So for that we can write the colors list and then call the extend method, and there we pass another list. So write the square brackets, and there let's say I'll pass green, then yellow, and then let's say pink. And now if I print the colors list and run the code, you will see it prints red, blue, green, yellow, and pink. So that's how you add multiple items to a list. Now here is a warning: if you use .append instead of .extend, you will get a nested list. So what do I mean by that is I can write the colors list, and if I call the append method, and here if I pass another list with the values like cyan and then magenta, then let's say if I write the print statement again and pass colors and run the code, you will see first it prints those 5 colors and then it prints another list inside the main list with the values cyan and magenta. So this is called nested list, means a list inside another list. So here we have another way to add items to a list using the plus operator. This is called joining lists. So for example, we have a list called list 1, and there we have 1, 2, 3, and we have another list called list 2, and there we have 4, 5, and 6. And to add these values in the first list, what we can do is we can define another list called combined, or you can name this anything, and then write the list 1, then use the plus operator and write the list 2. So now if you write the print statement and pass combined and run the code, you will see it prints the values from these 2 lists. That means we combined the values of both lists. So this can be a way while working with adding items to a list. So this is actually not adding, but this can be a way because we are joining. At the end of the day, both are kind of same, you can say. So you can add items to a list using list comprehension or loop. So those methods need the knowledge of list comprehension or loop. So we are not gonna see those now. We will see those methods later. Hey everyone, welcome back to the channel. In the last video, we learned how to add items to a Python list, but what if you want to remove something? Whether you need to delete a specific item, clear the entire list, or remove items based on a condition. Python gives us many options. First, we can use the remove method. So before we start, let's define a list called fruits. And there we have apple, then banana, cherry, and again banana. And let's say we want to remove cherry from the list. So what we can do is we can write fruits dot and we call the remove method, and here we pass cherry. Then let's say if I write the print statement and pass fruits, and if I run the code, you will see there is no cherry in the list. It prints apple, then banana, and then again banana. And now for example, let's say if here I write fruits.remove, then if I pass banana, and then let's see what it does, because we have banana twice in the list. So if I run the code, you can see it prints apple, then cherry, and then banana. So it removed this banana. So here what is happening is it is removing the first occurrence of banana. So when we pass something in the remove method, it will try to find and remove that. So when it goes to this element, it sees that this is not a banana, so it leaves that. But when the remove method comes here and see this matches, then it just removes that and discontinue the process. So the thing is, it removes the first matching element. So even if I have banana 1000 times later in the list, it will just remove first matching value. So the key point here is .remove method only deletes the first matching item. If an item appears multiple times, the others remain. Warning: what if you want to remove something that is not available in the list? For example, let's say you want to remove mango, but mango is not available in the fruits list. So what will happen is it will throw an error. So if I run the code, you can see it throws a value error, which is list.remove x. X is not in the list. So that means mango, which we are trying to remove, that is not present in the list. Now, what if you want to remove an item based on its position? I mean the index. In that case, we can use the pop method. So the pop method, for example, we have another list called numbers, which holds these values, then 40. Okay, so now if I write here numbers, then if I call the pop method, and let's say I want to remove this 30 from this list. So this 30 has the index 2. So what I can do is I can write here 2. Now if I write the print statement and pass numbers and run the code, okay, it is throwing the previous error, which is mango is not available. So what I can do is I can write here cherry. So now if I run the code, you can see it removed 30 from the list. As you can see, in the numbers list, previously we had 10, 20, 30 and 40. But now when I say numbers pop and I pass the index 2, it removes the second index value, which is 30, and prints the other elements. Now what if you want to access the removed element? So what you can do is you can write another variable called removed item. You can name this anything, that doesn't matter. And now if you write the print statement and give removed item and run the code, you will see it prints 30. That means it removed 30 from the numbers list. So the key point here is .pop method returns the removed item, so you can store it in a variable. Now what if you want to remove the value at index 10, but we don't have a value at index 10 because the maximum index here is 0, 1, 2 and 3. So if you call numbers.pop and you want to remove the 5th index or the 10th index value, which is definitely not available in the list, and try to run the code, you will see an error. So it is an index error saying pop index out of range. So let me remove this line to clear the error. And the code, see, we don't have any error. Let's say we have another list called letters, and there we have A, B, C and D. Now let's say you want to remove the last item from the list and you don't know the index of the last item. So what you can do is you can just write letters and just call the pop method and don't pass any index here. Now if you write the print statement and pass letters list, it will print the list without D. So you can see it prints the list with the values A, B and C. You can store the last or removed element by using another variable. So let's say the variable name is ri2, means removed item 2, and if you print ri2 and run the code, you can see prints D, means it removed the last element, which is D. Now we can remove elements by index using the del keyword. So now we have the del keyword, means the delete keyword, you can say. So for example, let's say we have another list and that holds red, blue, green and yellow. And let's say now I want to remove this blue element. So what I can do is I can write the del keyword and just write colors list, and in the square brackets I can pass 1 because this blue has the index 1. And then if I write the print statement and pass colors and run the code, you'll see it does not print blue, it prints red, green and yellow. The key point here is del does not return removed item, unlike pop. So you can just write here a variable called removed item 2 and get blue here, because del keyword does not return the removed item like the pop. As you can see, it throws error. And another warning here is using del on invalid index will cause an error. So for example, let's say I want to remove the value at 10th index, but there is no value of 10th index because this has index 0, 1, 2 and 3. So we are trying to remove the 10th index value which is not available. So now if I run the code, you will see that throws an error which says index error, list assignment, index out of range. So let me make it 1 so the error goes away. Now what if you want to remove multiple items or a range of items from a list? How will you do that? So for that, what you can do is you can use slicing. So for example, let's say I have another list called numbers 2 and that holds some values, for example 1 to 8, and let's say I want to remove the items from index 2 to 4. For that, what we can do is we can write the del keyword and write the numbers to list, and in between square brackets we can use the slicing. So we want it should remove from the second index to the fourth index. So first we have to write 2, then colon, then here we have to write the index plus 1, means the position, which is 5. So now it will remove the elements at index 2, 3 and 4. So if I write the print statement, pass numbers 2 and run the code, you'll see it removes 3, 4 and 5 and prints 1, 2, 6, 7, 8. So the key point here is using del keyword and the slicing removes all items in the given range. And as we saw earlier, we can clear the entire list as well. For example, if I write here numbers 2, then call the clear method and then try to print numbers to list, what it will do is it will remove every element and print an empty list. But the key point here is .clear method doesn't delete the list itself but just its contents. So you can see the list remains, but it removes the elements only. But if you want to delete the list itself, what you can do is you can use the del keyword. So here if I remove this line and write the del keyword, then let's say I want to delete the numbers to list entirely. So I have to write the numbers to list here. But keep in mind that when you delete a list, you can't use that list anymore. So as you can see, it is showing warning with yellow squiggly lines. So if you run the code, it will throw an error that name error, name numbers 2 is not defined. Did you mean numbers? Because we have deleted the entire list itself. In this line, that list isn't available at all in the memory. That's why when you will try to do something with that list, it will throw error. So I hope you understood the key aspects of how to work with lists and how to remove items from list in multiple ways. So let's understand how to sort a list in Python. For example, we have a list called numbers which has some numbers in the list. For example, 5, 2, 8, 1, and 3. Now if you print this numbers list and run the code, you'll see it prints the list, but the elements are not organized. If you want to organize them, or in a simple way, if you want to sort them, then you can use the sort method offered by Python. So what you have to do is you have to write numbers, then dot, then call the sort method. Now if you run the code, you will see it prints in an organized way. But what if you want to organize this in a way so it prints values from higher to lower? For now, it is printing the values from lower to higher. As you can see, first it prints the lowest value, which is 1, then 2, then 3. But what if you want to print first 8, then 5, then 3, then 2, then 1? So to organize them from higher value to lower, what you can do is you can write reverse equal true in the sort method. Then if you run the code, you'll see this list is sorted in reversed order. But let's say we have another list which includes some strings. For example, we have a list called fruits, and there you have banana, apple, and lastly cherry. If you write the print statement and pass fruits and run the code, you will see it prints banana, apple, and then cherry. But when you will write fruits dot sort and run the code, then you will see it organizes the list alphabetically. This word starts with A, which is lower, then B, which is the first letter of banana, and B is lower than C, which is the first letter of cherry. The key point here is it sorts based on the ASCII values. So uppercase letters come before lowercase ones. So if I make this cherry with capital C and run the code, you will see cherry comes first, then apple and banana comes. Because if you go to Google and search for ASCII values, then go to images, and if I zoom this image, you will see in the ASCII table A is in the top and its decimal value is 65, and for small a the decimal value is 97. So as the capital A holds lower value, it will come before the small a. Even this capital B will come before the small a. Like this, you can see capital C comes before A and B. That's why cherry gets printed before apple and banana. But as you can see, when we sort a list, what it does is it organizes the original list. But what if you want the organized list as well as the unorganized list? So you want to keep this list as it is and create another list with the organized values. For that, instead of this sort method, what we have to do is we have to use the sorted method. So let me remove this line, and here what I'm gonna do is I'm gonna write sorted numbers equal, then I'm gonna call the sorted method, and here I'm gonna pass numbers. So if I print numbers here, it will print numbers unorganized way. So let's run the code. You will see the numbers are unorganized, but in this line we organized the numbers and stored them in this variable. So what we can do is we can write the print statement and pass sorted numbers. And now if I run the code, you will see first it prints the unorganized list, then it prints the organized list. Now let's say I have another list called colors, where I have values like red, then green, then blue. Now let's say you want to sort this list but not according to the alphabets but the length of their words. So as you can see, red has 3 letters, so it should be in the first. Then blue has 4 letters, it should be in the second position, and green has 5 letters, it should go to the third position. So to organize them in this way, what you can do is you can write colors dot sort, and in between parentheses just write key equal len. So instead of organizing them alphabetically, it will organize them using their length. After that, if you write the print statement and pass colors and run the code, you will see it prints red, blue, and then green. You can combine key and reverse for more control. So what if you want that the word which has more length should go first and the word which has least word, it should go to last. In that case, you can write key equal length and then give a comma, and here write reverse equal true. So it will sort based on length but in reverse order. So now if you run the code, you will see first it prints green, then blue, then red. Now let's say we have another list called mixed numbers, and there we have positive as well as negative integers like -5, then -10, 3, -1, 4. Now if I write mixed numbers dot sort and print mixed numbers, run the code, you will see it prints the lowest value first, which is -10, then -5, -1, 3, and 4. But let's say you don't want to count the minus. You want to organize them by counting them as positive integers. So for that, what you can do is you can write key equal ABS. So it will be sorted based on their absolute values. So if you run the code, you will see it does not respect the sign and puts lowest value, which is 1 at the beginning, then 3, then 4, then 5, and then 10. It does not respect negative or positive value. It just counts that which absolute values has higher value. Let's see how to copy a list in Python without affecting the original. Many beginners make this common mistake when copying a list. For example, we have a list called original list, and there we have these values. Now let's say we want to make a copy of this list. Now you can say what we can do is we can write just copied list. By the way, you can name this anything and just write equal and then assign original list. Sure, you can do that, but it arises a problem. So let me show you. If I write the print statement and pass original list, then again if I write the print statement and pass the copied list and run the code, you will see both printed same list. But what if you want to add an item to the copied list? So what you will do is you will write copied list dot append. Let's say you want to add value 6 to the copied list, which is this one. So if you run the code, as you can see, 6 got appended by the copied list as well as the original list. But that's a problem because you just want to append 6 into the copied list, not in the original list. So it's not the right way to copy a list, because both lists gets changed when we do some operations in the copied list. Because in this process we do not create a new list, it just creates another reference to the same list in memory. So to correctly copy a list, what we can do is, let me remove this first, then let me write the copied list again, and now what we can do is we can write original list, then we can call the copy method. And now if I run the code, we'll see both prints the same list. But now if I try to append something to the copied list, for example copied list.append, then let's say we want to append 6, and again if I run the code, you will see the copied list appends 6, but the original list does not append 6, and that is what we actually want. Instead of this copy method, we can achieve the same result using the list function. So what we can do is we can call the list function and pass original list. So this will create a copy the list inside this variable. This is also a correct way. So if I run the code, you will see it gives the same behavior what we wanted, and we can achieve this by using list slicing. So for example, if I remove this portion and here if I say copied list equal original list, then if we do slicing, so if I write square brackets, then just give colon. So as we are not giving some index here and some index here, what it will do is it will slice the whole list and put inside the copied list. So this will work as well. So if I run the code, you can see this also works perfectly fine. Now let's see how we can join two lists in Python in an easy and efficient manner. So the easiest way to join two lists in Python is using the plus operator. For example, if I have a list called a list1 which holds the value 1, 2, 3, 4, and let's say we have another list called list2 and there we have 5, 6 and 7, we can join them by the plus operator. So I can write here combined list then equal list1 plus list2. Then I can write the print statement and pass combined list. So now if I run the code, you will see both lists got merged. Let me comment this line and we can achieve this same thing using the extend method. So what I can do is I can write list1 dot extend and I'm gonna call the method and pass list2. Then if I write the print statement and pass list1 and run the code, you'll see the same result. But the key point here is extend method modifies the first list instead of creating a new one. So in this example, we created a new list by merging them. But in this example, we are recreating list1 with the previous values and the values of list2. So that's why you will lose the original list which was inside this variable. Now list1 will contain all the elements of list1 and 2. We can achieve the same thing using the append method as well. So what I can do is I can write list1 dot append, then in between parentheses I can pass list2. So that if you run the code, you will see it appends the second list inside list1. But here is a slight difference. Instead of merging the lists, dot append method adds the entire second list as a single element. So it becomes a nested list inside the list1. Let me comment this line and tell you another modern way to join a list by using the star operator or unpacking. So what I can do is I can write the combined list variable and there what I can do is I can write square brackets and there I can write star list1 comma star list2. So this will unpack the value of list1 and this will unpack the value of list2, and by putting those values here it will create a new list. So if I write the print statement and pass combined list and run the code, you'll see the same output. If you have some large lists, you can use itertools.chain, which is an inbuilt module offered by Python. So to import an inbuilt module, what you can do is you can write from itertools import chain. So it will import chain from itertools module, and there are some pre-written code which is written by the Python developers, and while you installed Python, those got installed on your machine. So now what you can do is instead of this portion, you can write combined list equal, then call the list function and there write the chain method and pass list1 comma list2. So this iterables text, this is just instruction from PyCharm. You don't have to worry about that. It is solely for development purpose. So now if you run the code, you will see the same output. Use this method when you have some large lists that holds many data to improve the performance of your program. We learned many list method of Python in our previous videos. In this video, let's learn some more useful list methods offered by Python. Let's say we have a list called anime and there we have Naruto then bleach, and then one page. Now assume that this list is so large that you don't know the index of the items. So how will you know the index of a particular item like bleach or one page? So for that you can use the index method. For example, you can write here the print statement, then write anime dot and call the index method, and in between parentheses and quotations write the value whose index you want to find. In my case, I want to find the index of bleach. So now if I run the code, you will see it prints 1. As you can see, bleach has the index 1 in the list. But the key point here is it returns the first occurrence of the item. For example, if I have bleach again in the list and run the code, still it prints 1, because what the index method is doing is it is going to the list, then it is checking if it is matching this element. When it does not matches, it leaves that and moves to the next item and checks if that matches. So when it finds true that this one and this one matches, it returns the index of this item and discontinue the process and does not check other items in the list. So that's why prints the first occurrence of the list and other occurrences stays untouched. Okay, let's say then we have another list called numbers, and there we have 2, 1, 4, 6, 3, then again 4. Now let's say you want to check an item how many times it is appearing in the list. For example, this 4 is available in the numbers list twice, and other elements are available only for just once. So to check of total occurrences of an item, what you can do is you can use the count method. So write the print statement, then let's say I'm gonna write numbers dot count, and let's pass here 4. So now it will check that how many times 4 is available in this list. So if I run the code, you will see it prints 2. That means 4 is there in the list 2 times. As you can see, 1, 2. This is useful for analyzing data. Now you can do this with strings as well. For example, in the first list, which is the anime list, if I write the print statement here and then write anime dot count and pass here bleach and run the code, you'll see it prints 2. That means bleach is available in the anime list for 2 times. But if you make this Naruto and run the code, you can see it prints 1. That means Naruto is present in the list for only once. Now let's say we have another list called numbers 2, and there we have 2, 1, 5, 3, then 9. Now let's say you want to reverse this list. So how will you do that? For that you can use the reverse method. So to reverse the list, what you can do is you can write numbers2 dot reverse and call the method, then write the print statement, and if you pass here numbers2 and run the code, you'll see it reversed the list. So here 9 was at the very last, which is at the first position in the output. Then 3 was in the second last, but now 3 is in the second position in the output. So the full list got reversed. We saw reverse functionality with sort in one of our previous video, but this reverse method is used when you want to reverse a list without sorting. Hey everyone, welcome back to the channel. In today's video we're gonna talk about 2D lists in Python, and they're also known as nested lists. These are lists inside lists, and they allow us to store tabular or grid-like data easily. So let's dive in. So first of all, a 2D list is simply a list where each element is another list. Think of it like a table or a spreadsheet where you can have rows and columns. So let's say the variable name is numbers, which holds a list, and inside that list elements which will be list as well. For example, I can write 1, to 3. So this numbers list contains another list, and that list contains some numbers, and this is a independent item of this list. Then let's say we have another item which is also a list, and the values are 4, 5, 6. Then let's say we have another list with the values 7, 8 and 9. Now this is called a 2D list or two-dimensional list, and you can call this as a nested list or matrix as well. Now if you write the print statement and pass numbers and run the code, you'll see it prints this list where every item is also a list. Now we can make this looking beautiful by some nesting like this. So now this is more readable for us. If you run the code, still the same output. Now here it is a row, it is a row, and it is also a row. And if we count that vertically, then 3, 6, 9 is in a column, and this 2, 5, 8 in a column, and 1, 4, 7 in a column. So this is a row, which is first row, then this is second row, and this is third row. Now that we have a 2D list, how do we access individual elements? We do this using two indices, one for the row and one for the column. So let me make you understand this step by step. So before 2D list, when we learned the one-dimensional list, where a list contains only the data without nesting lists, we saw that we can access each elements by their index. For example, this has the index of 0, this has the index of 1, and this has the index of 2. So to access this element which has index 1, we can write here 1. Now if I run the code, you will see it prints 4, 5, 6, which is this list. Now let's say you want to access this 5. So how will you do that? So by writing numbers and 1 in square brackets, we access this list. And to access items inside from this list, what we can do is we can write the square brackets again and write here the index of 5. If I write here 1, because in this list again the items has some index, so the 4 has the index of 0, the 5 has the index of 1, and the 6 has the index of 2. So as we are trying to access 5, so the index is 1. So from numbers list, first we are accessing this item with this index 1, and after getting that list, we are accessing 5 by using index 1 here. So now if I run the code, you will see it prints 5. I hope you understood that. So if I write here 2, then it will print 6, because first it will access the 1th index value, which is this list, and then it will find the 2 index value in that list, which is 6. So run the code, see the output is 6. Now if you make this to 0, then in the numbers list, the 0th index element is this list, and there 2 index values 3. So if you run the code, it will print 3. Now it's not like that, but every element should be list. Inside the parent list, you can give other data types as well. For example, for the third item, we don't want a list, we just want a number. For example, 9. Now if you run the code, everything will work perfectly fine, but if you give here 2, then it will access 9, but now it is not a list and you can't access the second index element. So if you run the code, you will face an error. So make sure when you are trying to access values from the item which is a list, then you can pass index. Otherwise, if the item is not a list, you can't pass index and access that. If you make that 1, the error will go away. Okay, so we understood how we can access values. Now, what if we want to modify some value? For example, we want to replace this 3 with 99. So how we are gonna do that? So for that, what we can do is we can write the numbers list, and in square brackets, first we have to access this whole list using the 0 index, because this list has the index of 0. Now we have that list Now we can access that list element by using another square brackets, and there we want to target 3, which has index of 2. So now if I write here 2, then equal, if I write 99, then if I write the print statement and pass numbers and run the code, you will see it prints 1, 2 and 99 instead of 3. So that's how we modify a 2D list element. Now I can give you another example for better understanding. For example, let's say we have another list called fruits, and there we have a list which contains 2 more lists. So in the first list we have apple and banana, and in the second list we have cherry and mango. Now if you write the print statement and pass fruits and run the code, you'll see it prints the list. But what if you want to print cherry, so the second child list first element? So for that you have to write square brackets, and as we are trying to access the second element which has the index 1, we have to write here 1, and inside another pair of square brackets we have to give the index of cherry in the second list, which is 0. So now if I write here 0 and run the code, you'll see it prints cherry. Now let's say you want to change banana to orange, or let's say you want to change mango to orange. How will you do that? To change mango to orange, what you can do is you can write fruits, then let's target the second list by using the index 1, and inside another pair of square brackets we want to target mango that has also index 1 in this second child list, and then we can assign orange there, so orange. Then if you write the print statement and pass fruits and run the code, you will see it prints apple, banana, cherry and orange. So that's all for now. See you in the next one. Now let's talk about one of the most fundamental concepts in Python, which is conditional statements using if, else and elif. These allow your program to make decisions just like we do in real life. So let's get started. So first of all, think about how we make decisions every day. So if it's raining, we take an umbrella, otherwise we don't. This logic is what we apply in Python using if statements. So for example, let's say we have a variable called a temperature, and let's say the temperature is 25 degrees Celsius, and we want to notify the user who will be using our program that if the temperature is greater than 30, then it's hot outside, otherwise the weather is nice. So how we are gonna do that? In that case, we use conditions, means if else statements. So here I can write if temperature, then I want to check if that is greater than 30. Then after writing this condition, which is temperature greater than 30, you have to give the colon sign. After that you have to hit enter for a new line. Then you can write the print statement, and here just write it is hot outside. Now if you run the code, you will see this prints nothing. That is because you are defining temperature as 25 degrees Celsius, but you are checking if temperature is greater than 30. But 25 is not greater than 30. That's why it does not print this statement. But if you give here 35 degrees Celsius, and now if you run the code, you will see it prints it is hot outside. So as you can see, now your program can make decisions based on some logic. Now again, if I make this 25 and run the code, it prints nothing. But this is a not good use case, because if we are telling something based on some logic to user, what if the logic is false? Then we also have to tell him something. For that we can use the else statement. After if, you have to write else, then again write the colon sign and hit enter and write the print statement, and there write the weather is nice. Now if you run the code, you'll see it prints the weather is nice because the temperature is not greater than 30 because it is 25. So as this is false, it does not print the if part. It goes to the else part and prints that. So whenever this logic becomes true, it prints this one, and if this logic becomes false, it goes to the else part and prints this one. If you make this 35 again, then it will print this one and not print this one. So if you run the code, you will see it prints it is hot outside. Now what if we have multiple conditions? That's where elif comes in. Elif stands for else if. So we have elif, which stands for else if. And this allows us to check multiple conditions in order. So let's make this temperature variable having the value 15. Now if the temperature is greater than 30, then we want to print it is hot outside. But what if the temperature is greater than 20? Then we want to print something else. So in that case, we can write the elif statement, and we can write here another logic like temperature greater than 20, and after give a colon and write the print statement again. And if the temperature is greater than 20, we want to print it is warm, and we can add as many as elif in between if block and else block. So we can write here elif and then check if temperature is greater than 10, then we want to print it is a bit chilly. I missed the colon here, so it is yelling at me. So now if I run the code, you can see it prints it is a bit chilly. So what is happening here is, as you can see, the temperature variable holds the value 15, and when it comes to the if block logic, it sees that temperature, which is 15, is not greater than 30, so it leaves this statement, does not print that, then moves to the next elif part and checks if 15 is greater than 20. That is also false, so it does not print this line also. Then it goes to the third block and checks if 15 is greater than 10, so this becomes true and it prints it is a bit chilly. But if you make this 25 and run the code, you will see it prints it is warm. So this is what actually we wanted. So the key point here is Python checks conditions one by one. That means as soon as one condition becomes true, it executes that block and skips the rest. So when this statement becomes false, it leaves that and goes to the next one. When it becomes true, it executes this block and does not look these logics after that block, which is this one. Now we use conditional statements or if else with comparison operators many times. So in one of our previous videos, we learned the comparison operators. For example, greater than less than, then greater equal, less equal, equal, and not equal. So let's see a few more examples. So for example, we have two variables called num1, which holds the value 10, and then num2, which holds the value 20. Now we can use these operators in the if statement condition. So I can write here if num1 equal num2, then we want to print the numbers are equal. But what if they are not equal? Then we want to write another else block, and there we want to write the numbers are not equal. So now if I run the code, you can see it prints the number are not equal because 10 and 20 are not equal. But if I make num2 to 10 and run the code, you'll see it prints the numbers are equal because now both are equal. Now we can use the other comparison operators as well. For example, we can check if num1 is greater than num2. If that is true, we can write number 1 is greater. After that, we can write the elif statement and check if num2 is greater than num1. Then we want to print number 2 is greater. Else we want to print the numbers are equal. Now if you run the code, you'll see the numbers are equal. But if you make this 20 and run the code, you'll see number 1 is greater because here in this condition, number 1 is greater than number 2. But if you make this 30, Now this statement is false and this gets true, which is 30 greater than 20. So now it will print number 2 is greater. Now you can say that why we need the elif statement. We can just check if number 1 is greater than number 2, and if that is true we can print number 1 is greater, else we just can write number 2 is greater. But here we will have a problem, because if number 1 is greater and run the code, you'll see it prints number 1 is greater. If number 2 is greater, it prints number 2 is greater from the else block. But what if both are same? What if both are 40 and 40? In that case, when this condition fails, which means 40 is not greater than 40, it leaves that and just prints the else part. Here it does not check for any condition. It gets printed when this condition becomes false. So this is not the exact behavior we want. For that we use the elif statement. So let's write here the elif statement. So this is the right way to handle the thing. So now if you run the code, you can see number 2 is greater, else both are equal. Now let's understand nested if else. So nested if else. So what does it mean? I mean, nested if statements are used to check conditions inside other conditions. For example, let's say we have a variable called age which is equal 18 and another variable called has id which holds a boolean, means true. Then what we can do is we can write a logic. For example, if age is greater than and equal to 18, then if that is true, we want to go inside this if block, and there we want another if block, so we can have if conditions inside another if condition, or elif condition, or else condition. So here we can write if has id, then we want to print you can vote, else we want to print you need an id to vote. So if a person's age is 18 but not have id, means this one is true but inside the nested condition this one is false, then print this one, means execute this block. And if age is not greater than or equal 18, means the person's age is less than 18, then to handle that we can write the else block outside the nested if else block, and here we can print that you are too young to vote. Now if I run the code, you'll see it prints you can vote, because as you can see the age variable contains 18, means this logic is true. So Python goes inside this block, and after going to this block it checks this statement where if has id is true, and as you can see the has id variable contains the value true, so it prints you can vote. But what if his age is 18 but he does not have an id, so it is false. Now if you run the code, you will see it prints you need an id to vote. That means this one is true, that's why it is in this block. But when it sees that this one is false, then it leaves that and prints the else part. And what if both conditions are false, means the age is 16 and has not an id, so in that case it will not go inside this if block, because the first condition itself is false, so it won't go inside this block and directly it will print you are too young to vote. So if you run the code, you'll see it will print you are too young to vote. Even if you make this true, that does not matters, because when this condition becomes false, it does not go inside this block, so it does not check this if statement anymore. When this becomes false, it leaves this part and directly goes to this else part and run this print statement. So I hope you understood how the nested if else statements happen to work. Now you can add some elif statements here as well. So you can write here elif, and you can check whether he has property in that area. So has property true, so then you can write here has property. You can write here you can vote. So if his age is greater than 18, if he has ID, he can vote. If he has property, then also he can vote. Otherwise, we're gonna print that he needs an ID to vote. You can add elif statement to the outer condition as well. So here you can say elif age is greater than 15, then you want to print that wait for your ID. So as you can see, the age is 16, that means this condition is false, so it won't go inside this block, but this statement, which is 16 greater than 15, is true, so it will print this one, which is wait for your ID. As you can see, wait for your ID. But if you make that 14 and run the code, it will print you are too young to vote. Now before proceeding further, let's look at some common mistakes you should avoid when using if statements. So first of all, you have to avoid the indentation mistake. So what do I mean by that? So to make Python understand that this part is inside this if block, you have to push this part with some spaces here. As you can see, some spaces. So if you move the spaces, you will see Python indicates warning that we have an error. You have to push this code to make Python understand that this part belongs to this if block. If you remove this space, as you can see, Python complains. So make sure to indent properly. So where you write the condition, your block code should be one tab ahead of your condition. For example, inside this if block, we have this part. If you remove this indentation, Python will complain that we have a problem in our code. So to make Python understand that this whole part is nested inside this if block, we have to push this one tab ahead. As you can see, one tab space here. Here as well, as you can see, if I remove the space, it complains. So make sure to always indent the Python file properly, especially when working with if, elif, and else. And another common mistake is while comparing values, don't use single equal. This is an assignment operator. If you want to check that if age is equal to 18, make sure to use double equal. This is the comparison operator. So let's make this greater equal. Now let's take another example with logical operators. So in one of our previous videos, we learned about Python logical operators, which are AND, OR, and NOT. Now let's take another variable called age 2, and there let's assign the value 20, and let's take another variable called has ticket equal true. Now let's write an if statement, and there we can merge two logics and check if age 2, which is this variable, is greater or equal than 18, and the person has ticket. If both are true, means his age is greater than 18 and he has ticket. If both are true, then only we want to print that you can enter the concert. Else we want to print you cannot enter. So by using these logical operators, you can merge as many as conditions of your wish. For example, you can add some OR operators, you can use the AND operators again and use the NOT operator. So you can merge as many as conditions using these logical operators. If you make this 16 and run the code, you'll see it prints you cannot enter because he is underaged. Means age 2 is not greater than or equal 18. Now let's see shorthand if statement. So next we have shorthand if statements. So for example, you have another variable called score, and there you have value 45. Now instead of writing in a broader way, you can simplify this code by writing in this way. For example, you can write here result equal passed if score is greater or equal to 50, else student has failed. Then you can write the print statement and pass result. If you run the code, you will see it prints passed. But if you write here 40, which is not greater than or equal to 50, and run the code, you'll see it prints failed. So you can make your code shorter and simpler by using this shorthand notation. So the video was quite long. So that's all for now. See you in the next one. In our last video, we learned about if-else statements, but what if we want to repeat an action multiple times? That's where loops come in. Today, we are starting with the while loop in Python. So let's dive in. Imagine you have to write the count from 1 to 5. So you could write this, for example, print 1, then again print 2, 3, 4, then 5. Now if you run the code, it prints 1 to 5. But what if we need to count to 100? Writing 100 print statements would take forever. That's where loops come in. With loops, we can do a task in a repetitive manner. A while loop allows us to repeat an action until a condition is false. So instead of these 5 print statements, what we can do is we can write a while loop. So to write a while loop, you just have to write while. Then similar to if-else statements, we can give here a condition. So a condition, then write colon, then you'll get a block, means the while loop block. There you can write some code to be executed. As long as this condition is true, the loop keeps running. Once the condition becomes false, the loop stops. So let me give you an example. Let's say we have a variable called count equal 1. Then I'm gonna write the while keyword, and in the condition part, I'll check if count is less than or equal 5. So if this condition is true, go inside the while block and print the count. And after printing, we want to increment that. So I'm gonna write count plus equal 1. So now if you run the code, you'll see it prints exactly the same thing. 1, 2, 3, 4, 5. If you write here 6 and run the code, you can see it prints to 6. So what is happening here is we have a variable which is count, which holds the value 1. So when Python comes to this condition, it checks if count, which is 1, is less than or equal to 6. So as this is true, it goes inside this block and prints count. At this moment, count is 1. So it prints 1. After printing 1, it goes to the next line, and what it does is it adds 1 to previous value. Previously, count equal was 1, but when it comes to this line, count becomes 2. So when it becomes 2, it again goes to the condition. Now the count holds the value 2. So 2 is also less than 6. That means count less than equal 6. This condition is true. So again, it enters to this block and prints the count. Now count is 2. After printing 2, it goes to the next line, and what it does is it adds 1 to the previous value. So the previous value was 2. After adding 1, this becomes 3. So after count becomes 3, it goes to the condition again. 3 is also less than 6. That means this condition is again true. So it enters the while block and prints 3. After printing 3, it adds 1 to count variable and it becomes 4. Then it again goes to this condition, and 4 is less than 6. That means again it is true. So it prints 4 in this line, and after printing 4, it adds 1 to 4, which is stored in count now. Then it becomes 5. After it becomes 5, it again goes to the condition. 5 is also less than 6. That means the condition is true again. So again it enters the while block and prints 5 here. After that, we increment count with 1 and this becomes 6. Again it goes. So count equals 6. Again this statement is true. So now it prints 6, and in this line, after adding 1 to 6, it becomes 7. And now when it goes to the condition again, it sees that count now holds the value 7, and 7 is neither less nor equal to 6. So that's when it discontinues the process. So it does not print 7, it only prints 6. As you can see, it prints 6. But after the while loop, count variable holds the value 7. So after Python exits the loop, if you print count and run the code, you will see it prints 7, because while the value of count was 6, it entered in the block and printed 6 and made count 7, but it did not printed 7. But the variable holds the value 7. So after the while block, if you print the variable, it will print this value. Otherwise, it won't. Now let's take an interesting example by using while loops with user input to make interactive programs. For example, let's say we have a variable called password. There we have an empty string. Then we can write the while loop, and for the condition, we want to check if password is not equal to Python 123, then we want to ask user for input. So we're gonna write password equal and call the input function, and for placeholder we're gonna write enter the password. So if user gives password which does not matches this one, the program will repeatedly ask for the password. But if user gives this value as password, then we want to exit the while loop and print that access granted. So now if I run the code, you can see Python is asking for a password. So if I write here Adil, then hit enter, you can see again it asks for a new password. So if I write here Naruto, hit enter, it does not give us access. If I write here Hinata, hit enter, it again asks for the password. Now if you write Python 123, then hit enter, you can see it prints access granted and exits the program. So how cool is that? So the key point here is the loop keeps asking for the password until the user enters Python 123. Now let's talk about some common mistakes while working with loops. So always be careful and cautious when you work with loops. If you forget to change the loop condition, your loop may run forever, freezing your program. So what do I mean by that? So let me clear this code and have another variable called num equal 1, and let me write the while part, the while keyword actually, and let me check if num less than 5. If this condition is true, we want to print num. Now if you don't write here num plus equal 1 or num equal num plus 1, if you don't write this line, this loop will become an infinite loop. That is because you are not changing the value of num. So num always stays 1, and whenever the while loop runs, 1 is always gonna be less than 5. So this will lead to an infinite loop and freeze your program. So let me run the code to show you. As you can see, it continuously printing 1 1 1 1 1. So there is no stops for this process until you click on this icon manually. So here what is happening is the num variable holds the value 1. So first time when while loop sees this condition 1 is less than 5, it goes to the print statement and print num, which is 1, and after executing the block, as we didn't write this part, after executing the print statement, it goes to the condition again, and as we haven't updated the num is still 1. So 1 is again less than 5. So again while loop enters this block and prints 1. Then again from this line again goes to the condition 1 is again less than 5, enters the block and prints 1. We haven't updated num, still it holds 1. Again it goes to the condition less than 5. Again it enters the block and prints 1. So this is a never-ending process. So to fix that, make sure to always update the dependency variable. In this case it is num. So you have to write num plus equal 1. Now if you run the code, you'll see it prints 1 to 4 because we are saying as long as num is less than 5, we want to print num. When num becomes 5, we don't want to print that. But if you write here num less equal 5, means if num is less or equal to 5, then it will print 1 to 5. Now let me remove this code and let's see the use case of the break statement. So the break statement. So break is used when we want to stop the loop manually. When a certain condition is met, we can use the break statement. So let's take a new example. Let's say we have a variable called count where it holds the value 1 and we want to write a while loop and check if count is less than or equal 10, then we want to print count. And after printing, we have to increment the count. So count plus equal 1. So if you run the code, it will print 1 to 10. As you can see, it prints 1 to 10. But let's say you want when the count becomes 5, you want to stop the loop manually. In real world applications, you will face this kind of scenarios where you want to stop the loop manually. So let's say in our case, we want to stop the loop when the value becomes 5. So what we can do is we can write here if count equal 5. We want to check if count is 5, and if this becomes true, then we want to print that stopping loop at 5. Then we can just write the break statement. So even though we have written here that if count is less than 10, print count, but if you run the code, you will see it prints 1, 2, 3, 4 and then prints stopping loop at 5. So here what is happening is count is having the value 1. So in the while condition, initially when Python checks and found count which is 1 is less than 10, this becomes true. Then it goes inside the while block and there it sees another condition which is if count is equal 5. So as now initially count has the value 1, this becomes false. So Python does not goes inside this block. Instead of that, prints 1. After printing 1, it increments 1 in the count. So here it becomes 2. In the previous line, it was 1. After that, after incrementing the count value, it goes to the condition again. So now count has the value 2 and 2 is also less than 10. So it goes inside this logic and found this condition. So count is 2 which is not equal 5. So it does not go inside this block, comes to this one and prints 2. And in this line, it increments the value and makes 3. After making this 3, again it goes to the condition. Founds this is true, means 3 less than 10, goes inside the while loop block, but 3 is not equal 5. That's why it does not go inside the if block, but it comes to this statement and prints 3. Then for that line, count becomes 4 after incrementing with 1. Again it goes to the while condition. Again 4 is less than 10. This is true. It goes to the while block. There 4 is not equal 5, so it does not goes inside this block, prints 4, increments and makes count 5, and again it goes to the while condition and checks if 5 is less than or equal 10. So as 5 is less than 10, it becomes true. So this one is true. So it goes to the while block and checks this logic. If count is equal 5, means now count holds 5. So count is equal 5. This is true. So it enters the if block and prints stopping loop at 5. And after printing this line, it goes to the next line and it founds that we are telling Python to break the loop. So after seeing the break statement, it exits the while loop. So it does not check the while condition further. It just breaks that, means exits the loop. So as you can see, it prints 1, 2, 3, 4. Then it prints stopping loop at 5. Now, sometimes we don't want to stop the loop but skip a certain iteration. That's where the continue comes in. So let me remove this portion. Or let me remove this part and make the comment to continue statement, or let me remove the whole code actually and write the count variable again with the value 0, and then I will write the while keyword and check if count is less than 5. If the condition is true, then we want to do count plus equal 1. So while working with continue, it is always a good idea to write the increment before our execution code. Then you can write if count is equal 3, then we want to continue. And then let's write the print statement and just write count. Now if you run the code, you'll see it prints 1, 2, then it does not print 3. Instead of that, it prints 4 and 5. So here what is happening is we have a variable called count equals 0. So this condition is true because it is less than 5. So it will go inside this while loop, and there it will increment that with 1. So now count holds the value 1, and that is not equal 3. So it won't execute this part, and it will go to the outer if block and print the count, which is 1 now. After printing 1, it will go to the condition again, and 1 is less than 5. It will go inside and make that 2. So 2 is not equal to 3, so it won't execute this part, but it will print 2. After that, it will go back to the condition and check if 2 is less than 5. Again, it will find that 2 is less than 5. That statement is true, and it will go inside the while block and it will increment the count and will make that 3. So now this if statement is true because count holds the value 3, which matches this value. So what it will do is it will enter to the if block and it will see that we are saying continue. Continue means stop the while loop for current iteration. Means after continue in while loop, if there is any code, skip that and go to the condition again. Okay, so now count is 3. It goes there and finds we have continue, so it does not go to the other part of code in the while block. It goes to the condition and finds that 3 is less than 5. It is true. Again it goes inside the while block and makes the count 4 in this line. Then 4 is not equal 3, so it skips this part and prints 4. As you can see, 4. Then it does this process again and prints 5. So we are skipping the iteration where count becomes 3. So I hope you understood the use case of continue. Whenever we want to stop a certain iteration of a loop instead of the full loop, then we use the continue statement instead of the break statement. And if we talk about the common mistakes in while loops, those are if you do not use the indentation properly, this will yell at us. So make sure to always indent your code, and while checking, make sure to use double equal because it is the comparison operator. If you use single equal, this becomes the assignment operator and it will throw error. And make sure to increment the dependency variable, otherwise it will become an infinite loop and your program will just freeze. So I hope you understood the while loop and its use cases. So that's all for now. See you in the next one. In our last video, we learned about while loops and how they help us repeat actions. But Python has another type of loop that makes things even easier, and which is the for loop. So let's dive in and see how that works. Unlike the while loops, which runs until a condition becomes false, for loops are used when we already know how many times we want to repeat something. So let's see a simple example where we want to print numbers from 1 to 5 using for loop. So for that, we have to write the for keyword. Then we're gonna have a variable, for example num. You can name this anything. And then you have to write another keyword because we will be working with range and the keyword is in. Then you can write range, and what range we want? We want from 1 to 5. So we have to write 1, 6, because if you write here 5, it will take values from 1 to 4. So make sure to write here 6 if you want a value to 5. After that, you have to write the colon. Then you can write the for block, and there write the print statement and just print num. So in while loops, we had to manually increment num, but in the for loops, it will be handled by Python. So if you run the code, you will see it prints 1, 2, 3, 4, 5. So the key point here is range 1, 6 generates numbers from 1 to 5 because not including 6, and num takes each value from the range one at a time. So first num holds the value 1 and it goes inside the for loop and prints 1, then again it goes there and it becomes 2 and prints num again, and this process goes on until num becomes 5. By the way, range is super useful while working with for loops. You can write it like this. For example, for I in range 5, and if you print I and run the code, you will see prints 0, 1, 2, 3, 4. So it starts from 0 by default and goes all the way to 5 minus 1 means 4. So in range, if we only provide one number, it starts from 0 and goes up to 1 less than the number. And in range, what we can do is we can use steps as well. So we're going to tell Python that start from 1, then print until it becomes 9, and we want step or gap of 2. So now if I run the code, let me make the terminal a little bit bigger. You will see it prints 1, 3, 5, 7 and 9. So the third number, which is 2, tells Python to skip numbers in steps of 2. As you can see, it prints 1, then it goes ahead of 2 step and prints 3. Again it goes ahead of 2 step and prints 5. If you write here 3 and run the code, you'll see it prints 1, then it goes ahead of 3 step and prints 4, and again it goes ahead of 3 step and prints 7. For loops don't just work with numbers, we can use them with loop through lists, strings and more. For example, we have a variable called fruits, and there we have some values like apple, then banana and then cherry. Now instead of writing print statement and then passing fruits and 0 in square brackets to print apple, then again write the print statement and fruits and square brackets giving 1. So if the list is a little bit long, then it would take forever to print all the elements. So instead of doing that, what we can do is we can write the for loop. So for fruit, you can name this anything in fruits, but this has to match this one. Then you can give the colon sign and print fruit. So now if you run the code, you will see it prints apple, banana, then cherry. So in the first iteration, it goes to this list and assigns apple to this variable fruit and prints apple in this line. After that, it again goes to the for loop, and here the for loop goes inside the list, and after apple it puts banana into the fruit variable, then comes to the for block and prints banana. And again the for loops goes inside the list, and after banana it puts cherry inside this variable, and then in the third line it prints cherry. Make sure to match these two variable names, but you can name this anything. For example, you can name this I, but if you make that I, make sure use I here, and if you run the code, you will see the expected output again. So the key points here, the loop picks each item from the fruits list and prints it. This makes working with lists super easy. Now let's see how we can work with strings with the for loop. So let me remove this code and we can write the for keyword, then define a variable. You can name this anything. I'm gonna name this letter. So for letter in, then the in keyword, then just give a string, for example Python. So for every letter in Python, print the letter. So if you run the code, you'll see it prints P, then Y, then T, H, O, N. So what it does is the for loop first assigns P inside letter, then it goes to the second line and prints P, and again the for loop assigns Y inside the letter variable and prints Y. After that the for loop assigns T in the letter variable and then it prints T, and the process goes on until N. Let me remove this code, and just like while loops we can use break and continue statement in for loops too. So break and continue statement. For example, we have a for loop. So for num in range 1, 10 means 1 to 9. We want to print num. If I run the code, you will see it prints 1 to 9. But what if you want that if num becomes 5, then it should not proceed and exit the loop. In that case, you can use the break statement. So what you can do is you can write if num equal 5, and if that is true, then just break the loop. So now if you run the code, you will see it prints 1, 2, 3 and 4. So here when num is 1, it goes to the for block. Then in this condition, it finds that 1 is not equal 5, so it does not break and go to the outer part of if block and prints 1. Then again it goes to the loop, and now num is 2. So this condition is false. Again it prints 2. And again it goes to the for loop. Now num is 3, and this condition is false, so it does not breaks. Instead of that, it prints 3. After that, it again goes to the loop. Now num is 4. This condition is false again, so it does not breaks. That means Python skips this part and runs print 4. And again it goes to the loop. Now num is 5, so this statement is true. So this if block code gets executed and it founds a break, so it stops the entire loop. So as here we stop the entire loop, it does not go further, so it does not print 5. So we see the output 1, 2, 3, 4. Now let's take the example of the continue statement. So let's not take too much range, so I'm gonna take the range from 1 to 5, and here if num becomes 3, then we want to continue. So what continue does is it does not stop the entire loop, but it stops one iteration of the loop. So initially num will have the value 1, so it will print 1, because when num is 1, it will go inside this for block, and there it will found this condition, and 1 is not equal 3, so it will not go inside the if block and will print 1. Then it will go to the loop again. Now num is 2, so 2 is not equal to 3, so Python will skip this part and print 2. Then again it will go to the for loop. Now num is 3, so this condition is true, so it will continue. This means for only this time, do not print below code. Means do not print num, which holds the value 3, and go to the for loop again. As you can see, Python did not print at 3. Now in the for loop, num is 4, which is not equal to 3, so this part is skipped and Python prints 4. And again it goes to the logic. Now num is 5, so num not equal 3, so Python skips this part and prints 5. So that's how continue statement works in for loop. Now let's see some example of nested loops. So if there is a loop inside another loop, then that is called a nested loop. For example, we have a loop for I in range 1, 4 means 1 to 3. Then inside this for loop, we're gonna have another for loop, and there we're gonna tell for j in range 1, 4 means we want the values from 1 to 3, and inside that for loop we want to print, and here we are gonna use the string formatting. So I'm gonna write the F key, then I'm gonna give the quotations, and here in curly braces I'm gonna give I, then comma, then j. Okay, and for the outer for loop I'm gonna print nothing. I'll just write the print statement so it moves to the next line. So now if I run the code, you will see some pair of values. As you can see, 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3, and so on. Let me write here comma, then and equal empty string. And now if I run the code, you will see it prints in a nicer manner. And let's use some parentheses here. Now if I run the code, you can see this looks nice. Okay, so here what is happening is, in this for loop, which is the parent for loop, I becomes 1 in the initial render. So it goes inside this block, and here j is also 1. So what it does is it prints the value of I, which was 1, as you can see 1, and it prints the value of j, which is 1 here, and it prints 1, 1. Okay, after it prints that, it goes to this loop again, not in the parent loop but inside the nested loop till I is 1. But in the second iteration, j becomes 2, so it prints 1, 2. Okay, so after printing 1, 2, it goes to the nested loop again, not in the parent loop, in the nested loop. And here I is still 1, but j now becomes 3, so it prints 1, 3. Understanding? After it finished the range 1 to 3, as you can see, we have the range of 1 to 3. So after it finished the range for j, now it goes to the outer for loop print statement, and there it founds. We are telling that move next part to a new line. So as you can see, these values are pushed to a new line, and after printing a new line, it goes to the outer for loop. Now I becomes 2. After that, it again goes inside the nested loop. Now j again becomes 1, so I is 2 and j is reinitialized to 1, so it prints 2, 1. Understanding? After that, after printing 2, 1, it goes to the nested loop again. Still I is equal to 2, so I is equal to 2, and inside the nested second iteration, now j is also 2, so it is printing 2, 2. After printing 2, 2, it again goes to the nested loop. I is still 2, but now j becomes 3, so it prints 2, 3. As you can see, it prints 2, 3. Then as we finished our range, it ends the nested loop and go to the parent loop, and there we tell Python to move to a next line. So as you can see, other values are pushed to next line. So after that, it goes to the parent loop again. Now I becomes 3, so I becomes 3, and after that it goes inside the nested loop, and again j gets reinitialized to 1, so it prints 3, which is the value of I, and 1, which is the value of j. After printing 3, 1, it goes to the nested loop again. In the second nested iteration, j becomes 2, so it prints 3, 2. Then again it goes to the for loop, and I is still 3 and j also becomes 3, so it prints 3, 3. As you can see, 3, 3. Then we completed our range, so it goes to the parent loop or the outer loop, and founds. We told him to move further content to our next line, so it prints a new line. Then it goes to the for loop and finds that we do not have further range, so it exits the loop. So the work is done here. So I hope you understood the for loops and the use cases of it. So before we wrap up, let me tell about some common mistakes in for loop. So the first one is, if you do not use proper indentation, make sure to use proper indentation to make Python understand this part of code belongs to which block. As this part of code belongs to this block, so this should have a tab space before itself. Another thing to keep in mind, that if you write here 4, it will take range 1, 2, 3. Let's make this comment. So if you want to take range up to 4, you have to write here 5. So I hope you understood the common mistakes of for loops and how to use for loops and the use cases of it. So that's all for now. See you in the next one. Hey everyone, welcome back to the channel. Today we are diving into one of the most important combos in Python, and that is loop and lists. By the end of this video, you will understand how to use for loops, while loops, list comprehension, enumerate, zip, and much more. So let's get into it. So first of all, let's consider we have a list called fruits, and there we hold values like apple, then banana, and cherry. Now the basic for loop is, if I write here for fruit in fruits, then colon, and we can print each fruit in our loop. Now if I save and run the code, you will see it prints apple, banana, and cherry. This is the most basic way to loop through a list, one item at a time. Now let me modify this for loop and show you how we use enumerate in our loops. So now we'll cover enumerate. So here, as you can see, we are putting one value of the list inside this variable, but we can take two variables here like index. So here it will add a counter to this for loop. So what do I mean by that? You will understand after the full example. So if you want to work with the index, you have to use the enumerate method. So for example, here I'm gonna write enumerate, and I'm gonna write the parenthesis and pass fruits into that. So now what this will do is it will add a counter to this for loop. So whenever it will put one element to this variable, it will add the index of that element in this variable. If you can remember, in our previous last videos we talked about the index, which is position minus 1. Means apple has the position of 1, so the index will be 1 minus 1, and that is 0. And this banana has position 2, so the index will be 2 minus 1 means 1. Now you will understand this if I show you the output. So let's use string formatting here. So I'm gonna write f, then double quotes, and inside curly braces I'm gonna write index, then colon, and let's also print the fruit as well. Now if I save and run the code, you will see it prints the first element index and the first element value, and then the second element index and the second element of value, and so on. So I hope you understood what enumerate does. It adds a counter, so behind the scenes it returns both the index and the value from the list. Now let me comment this for loop, and let's see an example with the while loop as well. Let's take a variable called I, which is equal to 0, and let's write the while loop, and the condition would be I less than, and we can use the len method and pass the fruits list. Then what we can do is we can just print fruits, and in square brackets we can give the index. Here we are expressing index by I. As you can see, the initial value of the index is 0. So in the next line, what we have to do is we have to increment the index. So I'm going to write I plus equal 1. So now if I save and run the code, you'll see it prints apple, banana, and cherry. So the key point here is a while loop runs as long as the condition is true. So as you can see, the condition, which is we are checking if I is less than the length of the fruits list, and then we are incrementing here. So after printing cherry, which has the index of 2, in this line the index becomes 3, and when it goes to the while condition, it observes that I is not less than and it discontinues the loop. So if you forgot to add this line, it will become an infinite loop. Again, let me comment this and move to a new example. So if I run, you'll see the output is empty. Now let's take another example with the for loop, and this time we're gonna add the break statement and the continue statement. Okay, so I'm gonna write for fruit in fruits list, and we're gonna tell if fruit equal banana, then just continue, else we're gonna print the fruit. Okay, now if I run the code, you will see it prints apple and cherry. But as you can see in the list, let me cut this from here and paste that here. Okay, so you can see we have 3 fruits in the list, but it prints 2 of them because in the first iteration the fruits variable holds the value apple. So this condition becomes false, so it does not go inside this if block and go to the else block and prints the fruit which holds the value apple. But in the second iteration, it checks if fruit is equal banana, and it finds that it is true. So it goes inside the if block, and see there we are telling to continue the process, means do not go further and go to the top of the loop. Okay, and in the third iteration, the fruit variable holds the value cherry. Now cherry is not equal banana, so it goes to the print statement and prints cherry. Now if you write here break, instead of continuing further, it will break the whole loop, means it will just print apple. If I run the code, you will see it prints apple, because as soon as it finds this fruit variable holds the value banana, it breaks the whole loop, means it tells the interpreter to do not do any iteration for the loop. Okay, let's have another example. Now this time, let's say we have a list called colors, and there we have values like red and green. Okay, then let's say we have another list called shapes, and there we have circle, and the second one is square. So as it will be a nested list, first I'm gonna write for each color in colors we want to run a nested loop. For example, for shape in shapes, and I'm gonna write the print statement and string formatting. So let's print the color and then the shape. Now if I run the code, you will see it prints red circle, red square, then green circle and green square. So as you can see, the colors list has a two color. So in the first outer loop, when it is in the first iteration, means the color variable hold red, it goes inside the inner loop, and for the red value it prints to shape, means this inner loop also gets iterated two times for circle and square, and we get the output red circle and red square. After finishing this portion, it goes to the outer loop again. Now color holds the value green, and for green it also goes to the inner loop and prints circle and square. Now we will have a broader understanding of list comprehension in our next video, but let's take a quick example in this video as well. So what I'm gonna do is I'm gonna comment this code, and let's take an example of list comprehension. So what I'm gonna do is I'm gonna write a variable called squares, and there I'm gonna write x star star 2, means exponentiation, and then I'm gonna write for x in range 5. Okay, and then I'm gonna print squares. Now if I run the code, you'll see it prints 0, 1, 4, 9 and 16. So what is happening here? So as you can see, list comprehension is a short form of our loops. As you can see, in normal loops we used to write the command statements inside the loop body, but we are doing that here, and after writing the body we are writing the loop part. So this is shorter and sweeter, but as you can see it is kind of normal loop, but the loop body is just before the loop. As you can see, for x in range 5. So when you say range method and pass one number, what it does is it takes 5 values starting from 0, 1, then 2, 3 and 4. Now for each of the 5 values, so this will iterate for 5 times, and we are telling the Python interpreter to do exponentiation. So if we do 0 square, this becomes 0. Then for 1, if we do 1 square, that becomes 1. This is just normal mathematics. I hope you are understanding. And for 2, when we say 2 square, it becomes 4. As you can see, the output is 4. And for 3, it becomes 9. And for 4, it becomes 16. Okay. Now we will have a broader understanding of list comprehension in our next video. So let me comment this and move forward with the zip function or method, you can say. So we have the zip method. Okay. Now let's say we have another list called names, and there we have a list and that holds some names like Alice and Bob. Okay. Then we have scores, and that is another list, and score is 90, and then let's say 85. Okay. Now with the zip we can work with the two lists at the same time. So what do I mean by that is, here I can write for name and comma and score in, and let me write the zip method, and here I'm gonna pass names and then scores. And make sure if you write name here, you have to pass the names list in the first parameter of a zip, or in the first place, you can say, because otherwise the name variable won't have these values correctly. And if you are writing score, means you are trying to access this list. So if you write score in the second place in the zip method as well, you have to give the scores list in the second place. So keep in mind that. Okay, so now I can write the print statement and string formatting, and inside quotation I can write the name and I can write scored and just the score. Okay, now if I run the code, you will see it prints Alice scored 90 and Bob scored 85. So here zip joins two lists element by element, means in the first place it puts the first value of the first list, then the first value of the second list, and then next for the second place it takes the second element of the first list as well as the second list. Okay, I hope you understood the use case of the zip method. Now before I wrap up, I want to share a tip with you. So here let's say we have a list called numbers, and that holds values like 1, 2, 3 and 4. Now the tip is, don't modify lists while looping. And what do I mean by that? So if I write here for num in numbers, and let's say in the loop we are checking if num mod 2 equal 0, then we're going to write numbers dot remove and let's pass num. So if you try to run this, as you can see, it misbehaves. Modifying a list while looping over it is risky. It changes the list size mid-loop and can skip items or behave unpredictably. So the possible fix would be, instead of modifying inside a loop, what we can do is we can write new list, and then let's say num, we want to print num. If you can remember, we write the loop body first in list comprehension. So here after that I'm gonna write the actual loop. So for num in numbers, if num mod 2 is not equal 0, then just write the print statement and pass the new list. Now if you run the code, you will see it prints the list. So here we are putting every num which has not the mod result to 0 and putting each value inside this new list, and then we are printing that new list. And that wraps up everything about loops and lists in Python. If you enjoyed this, leave a like and subscribe so you don't miss the next one, where we'll break down list comprehension in detail. Today we are unlocking one of the most powerful features in Python, and that is list comprehension. It lets you write shorter, cleaner and faster code. Let's break down how it works behind the scenes and why it's so useful. So let's take an example. First we are gonna have a list called numbers, and there we are gonna have 1, 2, 3, 4 and 5. Okay, and now let's say we want to get the squares of each number. So for that, instead of bigger loops, we can write a sweeter and shorter list comprehension. So in list comprehension, what it would be x exponentiation 2. So we want to do mathematical square, and then we write the for loop. So I'm going to write for x in numbers. So here we have 5 numbers in this numbers list. As you can see, this for loop, it will run 5 times, and in each iteration it will put the value from this list one by one. So in the first iteration, x will hold the value 1, then 2, then 3, then 4, and then 5. And in each iteration, when x will hold, for example, 2 or 1, it will do 1 square, 2 square, 3 square, like this. And it will store each iteration's value as a list inside this square variable. Okay, so if I write the print statement and pass squares and save and run the code, you'll see it prints 1 square, which is 1, then 2 square, which is 4, then 3 square, which is 9, and 4 square 16, 5 square 25. Now this code is equivalent to a loop, and let's see what is that. So instead of these 2 lines, what you could do is, if you want to avoid list comprehension and just use normal list and a loop, then you can write squares equal empty list, then you can write for x in numbers, and then write squares dot append x exponentiation 2. Then after the loop, you can write the print statement and pass squares to print that. Now if you run the code, you'll see the same output. But as you can see, we are writing 4 lines of code and some methods, but as you can see, we can just do that in a simpler way with list comprehension in just 2 lines. Now let me remove this loop example and uncomment the list comprehension example, and now we can do some filtering with if else as well. So here, after this list comprehension, we can add a logic like this. We can say if x mod 2 equal 0 means every time in every iteration x will have value from this list. In the first iteration it will have the value 1, and in the second iteration it will have value 2, then 3, 4, 5, and so on. So we are telling if x means in the respective iteration, and if we mod that value with 2, and if we get 0 means if that is an even number like 2, 4, 6, then we want to perform this task. Otherwise we don't want to perform this task. So if it is 1, don't perform this. If it is 2, that means it is even and it fulfills this if logic. So 2 square, that will be 4, where on the code you'll see it prints 4 and 16. When in the first iteration x holds the value 1, this logic gets false, so it does not do 1 square, so it does not add some value to the squares list. But in the second iteration, when 2 is in the x variable, then 2 mod 2 equals 0, so this is true. So we are doing 2 square and storing 4 inside the squares list. Then for 3, this gets false, we do nothing. For 4 mod 2 equals 0, this is true, that means we do 4 square, means 16. So we are storing 16 after 4 in the squares list. For 5, this gets false, and again we do nothing. I hope you understood how we use the if statement. Now we can use if else both in list comprehension. Let's take the numbers list again, then let's have a variable called result, and there I'm gonna say that this result list should include the x, and we can write the if part before the for loop part as well. So here I can write if x mod 2 equal 0. So if this condition is true, means it is an even number, then we want to put that even number inside the result list. And else, if that is an odd number, we want to put minus x there, means before the odd numbers we want a minus sign. And then we can write the for loop part. So for x in numbers. Okay, so here I missed the x, so we want to store the x if that is an even number, and we want to store that normally. But if that is not the case, means the x is an odd number, then before that number we want a minus sign. Okay, so if I write the print statement and pass result and run the code, you'll see when it is an odd number it puts a minus before that number, but when it is an even number it just puts the even number, does not includes a minus sign. So this was a pretty good example to understand the if else. Now let me remove these and see how nested list comprehension works. So I'm gonna take a variable called matrix, and there we'll have a nested list. In the first nested list we're gonna have 1 2, and in the second nested list we're gonna have 3 4. Now we want to print the flattened data of this list. So for that we can write flattened num for row in matrix for num in row. Now if I write the print statement and pass flattened and run the code, you'll see it flattens the list. So it converted a 2D list into 1D list. So here we have two loops actually. If you look closely, we are having num stored inside the flattened list, and for outer loop we are checking for row in matrix. So in first iteration this row contains this list, and on this list we perform the nested loop, means for num in this row. Okay, so it prints 1 and 2. Then it again goes to the outer loop, as you can see, for row in matrix. So in the second iteration this list gets inside this row and it goes to the inner loop here, and it takes num from this row and prints 3 and 4. Now let's have our numbers list again, 1 2 3 4 5. Now let's discuss about some common mistakes. So here if I write x for x in numbers, and if x mod 2 equal 0, and let's store this inside the result. Okay, now if you just write the if statement, then you should write this after the for block. Okay, but if you include the else statement as well here, else minus x, this will throw error. So if you intend to use both if and else, you have to cut the for block and put that at the last. You have to write the if else block before the for block. Now if you run the code, okay, I have to print this, print result, run the code, it will work perfectly. Okay, so keep in mind that if you use only if statement, then for block will be before the if block, but if you intend to use the if else both, then the for block would be after them. Let me delete this and let's see how we can work with range as well. For example, we can write a variable called multiples of 3, and let's write x for x in range. Then let's put 1 comma 20 and add a if block x mod 3 equal 0. So basically everything is the same, but instead of the numbers list or any kind of list, we are just passing a range here. As you can see, the for block, the if block, everything is same what you have learned so far in the list comprehension section. So if I write the print statement and pass multiples of 3, Run the code, you'll see it prints multiples of 3, like 3, 6, 9, 12, 15, and 18. Now let's have the last example of this video, and that is with strings. So for example, we have words list, and there we have apple and then banana. Now we can have a variable called reversed words, and here what we can do is we can write words, then in square brackets we can do some splitting with -1, and then for word in words, and if I write the print statement and pass reversed words and run the code, instead of apple it prints alpha, means it reversed the string. E was at the last, it put E at the first. L was in the second last, it put in the second position. So it reversed every letter in each word. For banana as well, as you can see. So here this is the loop body, as you can see, the loop, and by this syntax we are doing slicing. This is a shortcut method of slicing that reverses a string. And that was a full deep dive into list comprehension, how it works, when to use it, and how to avoid common mistakes. If this helped you, please like, subscribe, and drop a comment below. See you in the next one, and until then, happy coding. Now so far we have learned many things about Python lists. So if you want to do some exercises and check the gathered knowledge of yours, then what you can do is you can go to Google and just search for gigs Python list exercises, and open this first link, and here as you can see you have many tasks or examples. You can try them and check your learning stage. First of all, as you can see, we have access list item. If you click here, you'll see some exercises with example of accessing list elements. You can read them, and after completing this, you can always go back and click on the second one, which is change list item, and you can read that. And you can copy paste these codes in PyCharm and try this on your own. But for a more effective learning, you can search in Google by writing W3 Schools Python list exercises, and hit enter and click on this. So as you can see here, we have some topics. First of all, lists, then access lists, change lists, add lists, remove list. For example, you can click on this, and as you can see, it asks some questions. So here the question is, what will be the result of the following syntax? So here as you can see, we have a list called mylist, and there we have 3 fruits, and we are printing mylist element with the index 1. That means the second element. Okay, you can select this and submit your answer. As you can see, it shows correct answer. Then after that, you can go to the next question. As you can see, we have another list, then it is asking my list, and it is trying to print my list item at the index of 2. So 0, which is apple, then 1 banana, 2 banana. So again it will print banana. Click on the next question, and here as you can see, it is asking true or false. Now list items cannot be removed after a list has been created, so the statement is false. We saw in our previous videos that we can remove items from list after the creation, so it is false. Submit answer. Again it is correct answer. Now here the question is, select the correct function for returning the number of items in a list. So here we have 3 items in the list. So in our previous videos we used the len method to know the length of a list. Let's submit. As you can see, it is also correct. So after completing this, again you can go to this page and open the second item, and here as you can see we have more questions, and this time the topic is Python access lists. Now here we are accessing with negative indexing. So -1, it will print cherry, submit. So I'm not gonna answer all of them in this video. So I'm trying to say is go to these websites and explore them and try to answer the questions, and go to Geeks for Geeks, copy these codes, modify them, and try those on yourself. This will make you more confident in coding. So that's all for this video. See you in the next one. Now we have learned about lists before. Tuples may look similar at first, but they behave quite differently. Let's learn exactly what tuples are, how they work, and why Python has them in the first place. So to define a tuple, I'm gonna write a variable called myTuple, and to write a tuple instead of square brackets like lists, we use parentheses, and then we write the elements like apple, then banana, and then cherry. Now if I write the print statement and pass my tuple and run the code, you'll see it prints the tuple. Now a tuple is a collection of items just like a list, but instead of using square brackets like list, a tuple uses parentheses, as I said before. The items inside a tuple are ordered, which means the position of each item is fixed, and that follows the list behavior. Like this apple has the index of 0, this banana has the index of 1, and cherry has the index of 2. So the indexing starts from 0. In other way, you can say index equal position minus 1. So you can see apple is in the first position, so 1 minus 1, so the index is 0. Another thing is that tuples are immutable. I said that in one of my previous video as well. That means we can't change a tuple after it is created. So if we try to modify by using the index, if I try to change banana to blueberry, as you can see, Python tells that this is not allowed by the yellow squiggly lines. Again, if I write the print statement and pass my tuple and run the code, you can see it throws error and it says tuple object does not support item assignment. Now there can be a question, why we use tuples if we can't change them? It is a great question. Let me remove this code and comment them. Let's take another example, like you are trying to sort a user date of birth. So date of birth, this is a variable, and there we have a tuple. At first we have the birth year, and let's say the month and the day date. So as you can see, if I print this date of birth, run the code, it prints that. Now what I am trying to say is this data will never be changed, so you don't want it to be modified accidentally. So when you want a data should not be changed, that's when a tuple makes more sense than a list. It keeps your data safe. Let's think you are working on a program where more programmers are working. You have defined this date of birth, another programmer mistakenly changes this, so that you don't want. So to overcome that, we use tuples. So whenever another programmer tries to change this, Python throws error. So tuples are used when you need fixed data that want to change, or you want to protect the data and you want faster performance than lists, because tuples are lighter than lists, which offers more performance. Now let me comment them and let's talk about some common mistake beginners make. And the first one is, for example, we want to take a tuple with a single element. we can do that with a list as well. With a single element we can create a list, but in case of tuple, here we have a gotcha. So if I write a variable called a single underscore tuple equal, then parenthesis, and in between double quotes if I write apple, okay, then if I write the print statement and pass that single tuple, as you can see we have a yellow squiggly line. If I print this code, let's see what happens. As you can see, it prints just apple, but it does not have parenthesis. That means it is not a tuple in the output. So let's see what is the type of our single tuple variable. Okay, so now if I run the code, you can see it says the type of single tuple is a string, but this should be a tuple. If you add more items in the tuple banana and run the code, you can see the type is tuple, but when you take one element, it says string. It behaves correctly when there is more items than one, but if you have only one item, then it says the data type is a string. Now, how to overcome this? Because you might need a tuple with one element. For that, you just have to add a comma after the element. So now, if you run the code, you'll see it prints the type is tuple. If you remove the type method and run the code, you can see it prints saying that it is a tuple. Now let me comment this code as well, and let's see another topic, and that is tuple packing. So if we take a variable, you can name this anything. Here let's say I have colors like red, then green, and then blue. As you can see, we are not using square brackets or parentheses here. Now if I write the print statement and pass packed and run the code, you can see Python made these strings into a tuple. So this is called tuple packing. If you don't put parentheses, Python automatically turn the elements into a tuple. You can check by using the type method. So if you write the type method and pass packed and run the code, you'll see the type is tuple. So this tuple packing is often used along with a concept called unpacking. Okay, here we can take another tuple called new tuple, and let's have different types of data. For example, Naruto, which is a string, then 1, which is an integer, then a price, which is a floating point number, then again a string called Hinata, and then a boolean called true. Now we have discussed that we can access the values of a tuple with the index. For example, I can write here the print statement, then new tuple, and then square brackets. Make sure to use square brackets. So while accessing, you don't use parentheses, but you use square brackets just like lists. So here, if I pass the index and run the code, you'll see it prints 9.99. Okay, we can work with negative indexing as well. So if I write here -1, it will start counting from the last. So -1 will print true, means this element. If I run the code, as you can see, it prints true. If I write here -2 or 3 and run the code, you can see it prints 9.99, because this has the index of -1, this has -2, and this has -3. Now we saw in our list videos that there is a concept called list slicing, and similarly that in tuple we have a range of indexes. So range of indexes. So for example, if you want to access the elements from 1 to Hinata, how will you do that? So for that, you can write the index of 1, which is 1, because Naruto has the index 0 and 1 has the index 1. In the first position, you write the index of an element and then the position of another element. For example, Hinata. Now to access Hinata, you don't give the index of Hinata but the position, which is index plus 1. So Hinata has index of 3, so the position is 4. Now if you run the code, you can see it prints 1, then 9.99, and then Hinata. So I guess that's all for tuple, and in the next video we're gonna talk about how to update a tuple. Are you confused? Because I told that tuples are immutable, but now I am saying that in the next video we are gonna cover updating a tuple. So to clear your confusions, I'll say to watch the next video. So that's all for now. See you in the next one. Today we'll explore something many beginners ask, and that is how we can update a tuple if tuples are immutable. It may sound like a trick question, but the answer is simple once you understand how Python handles data under the hood. So let's break it all down. Now let's take a tuple called my tuple equal, and there we're gonna have some elements like Naruto, then Bleach, and then One Piece. Now if you try to update this tuple by using the index, for example, we want to change Bleach to Jujutsu Kaisen. So if you try to do this, you will see that PyCharm shows a warning. So this will cause an error. So let me make you clear that you can't modify a tuple's content directly once it is created. But then how we will update a tuple? So the answer is we need a little trick. And the trick is, let me remove this line and write some comments. So the first process is convert the tuple into a list. Okay, then the second step is modify the list, like you can add, remove, or change elements of that list. Then finally you can make that new list a tuple again. So convert it back into a tuple. So let's see it in action. You can see we have this tuple here. Let me cut this from here and paste that here. Okay, and now to modify this, first we're gonna create a list from this tuple data. So for that we're gonna create a temporary list. So temp list, you can call this anything, and we have this list method which creates a list if you pass some data. So we're gonna pass the tuple here. So this list method will make the tuple into a list. So here if I write the print statement and pass my tuple, and after that here if I write print statement and pass temp list and run the code, you'll see that first it was a tuple, then it became a list. Let me comment this. Now as we got a list, we can modify this list because lists are not immutable like tuples. So what I can do is I can make changes in that list. So temp list, and we want to change Bleach to Jujutsu Kaisen. So I can write here 1, then equal, and in between quotations I can write Jujutsu Kaisen. You can write here anything. You can write here banana as well. Okay, so the first process is done. As you can see, we created a list from the tuple. The second step is also done. We modified that list. Now the third step is convert it back into a tuple. So for that, what we can do is we can write the my tuple variable again, and instead of directly modifying, we can reassign the tuple. So we can call the tuple method provided by Python, and in between parentheses we can pass the temporary list. Okay, you can see I have commented out these print statements. But now if I write the print statement and pass my tuple and run the code, you'll see it prints Naruto banana and one piece. It changed bleach to banana. So what is happening here is we have this tuple and the second element is bleach. We are converting the tuple into a list in this line and we are making changes to that list in this line, and then we are converting it back into a tuple in this line. So I hope that makes sense. So before you convert it back to tuple, you can do any modifications you learned in list section of this series. For example, you can work with the methods as well. For example, if you write temp list then dot, you can copy, pop, sort, count, then you can append another element, for example solo leveling. Now if you run the code, you can see it prints Naruto, banana, one piece, then solo leveling. So the temporary list appended solo leveling as a new element, and then we are converting it back into a tuple in this line. You can remove some elements as well. For example, you can write temp list dot remove, and let's say you want to remove Naruto. If you run the code, as you can see, it removed Naruto from the list, I mean the tuple at the end of the day. So you can do any modifications that you learned in the list section of this series. You can add, remove, change, call some methods. For example, this lists method, as you can see, there are endless list methods: insert, then append, then extend, reverse, many more. Okay, now the final question is, can we just modify a tuple without converting? The short answer is no. There are no methods like .append, .remove, or even direct assignment for tuples. You'll always need to convert, modify, then convert back. This is intentional. Python is protecting your data when you use tuples. Now let me copy all of the codes from here and discuss a common mistake which many beginners make. For example, we have a tuple called myTuple, and there we have these elements like A, then B, then C, and then D. Now let's take 3 elements. Now we can make this a list by using the list method and passing the myTuple. That's okay. Now we can do some changes in the list. So we can write temp, the 0th index, and we want to change A to Z. Okay, then the mistake beginners do is they call the tuple method, pass that temporary list, but they do not reassign the tuple into myTuple. They just write this part and moves to next part and write print, then just write myTuple. Now if he runs the code, he sees that there is no changes because still myTuple holds this tuple. We made a temporary list, made changes there, but we have to reassign that new converted tuple into the old tuple variable. So always reassign. You have to write myTuple equal, then call the tuple method and pass the temporary list. Now this will work properly. As you can see, A became Z here. So I hope you understood how updating tuple work in Python. So that's all for now. See you in the next one. In the last video, we learned how to update a tuple using a little trick with lists. Today, we'll explore something very useful and clean in Python called tuple unpacking. It allows you to assign values from a tuple directly into variables, all in one simple line. Let's break it down together. Let's start with tuple packing. It means creating a tuple like this. Colors equal, then parentheses, then let's have some elements like red, then green, and then blue. Now if you want to assign these 3 values to 3 separate variables, here's where tuple unpacking comes in. So what you can do is you can write some short forms like R, G, B, then equal colors. Okay, now this first variable will have the first element from the tuple. The second variable will have the second element from the tuple, and the third variable will have the third element from the tuple. So to prove you that, if I write the print statement and pass R, then again print G, and again print B. Now if I run the code, you'll see it prints red, then green, and then blue. So Python goes left to right and it assigns red to R, green to G, and blue to B. You can name them anything. For example, you can name this D, but here you have to use D as well. If you run the code, you'll see the same output. But keep in mind though, the number of variables must match the number of items in the tuple. For example, here we have 3 elements in the tuple. If you take 2 variables, let me remove this line, and try to run the code, it will throw an error. So as the tuple has 3 elements, we have to take exactly 3 variables. For example, you can take another variable age. If you run that, it will also throw that error. You have to take the number of variables same to the tuple length. Let me remove this, run the code, you can see empty output. Now what if the number of variables doesn't match? So what we can do? For example, we have a tuple called info, and there we have, let's say, Naruto, then age 25. Now the normal approach was we can write name equal info, we can write, then in square brackets we can write 0, then age equal info, and inside square brackets we can write 1. This is how we used to do in older programming styles. This will work. So if you write the print statement and pass name, run the code, you can see it prints Naruto, and then if you write age and run the code, it prints 25. But if you want to do this with tuple unpacking, what you can do is you can write name, age equal info, and this will work as well. But let's say you add address, for example Germany. Now as you can see, it throws error. If you run the code, you'll see too many values to unpack. So let's learn how to handle that. For example, we have another element called ninja. So these 2 variables will take care of these first 2 elements. But what about the rest of the elements? So to take care of them, what we can do is we can write the comma and then the star sign to indicate all of the others. Then we can write here rest. So now if I write the print statement and pass name, then again print age, then if I write the print statement and pass rest and run the code, you'll see the first 2 variable gets first 2 elements, but other elements gets into the rest variable as a list. As you can see, it is a list. Now it doesn't matter how many variable you add. If you add more elements, it won't throw any error. It will just add them in that list. Now you can name this anything, for example others, and just write here others. But keep in mind that you have to put the asterisk or the star sign before that. And the code, as you can see, the same output. Now let me comment this and take another example, and that is about tuple unpacking in loops. So for example, we have a variable called pairs, and there we have a list, and the first element holds a, 1, then another tuple that holds b, 2, then another tuple that holds c, 3. Now let's write a loop. So I can write here for letter, number in pairs, and the colon sign, and we want to write the print statement and string formatting. And what we can do is we can write letter in curly braces, then give a hyphen and then number. Okay, now if I run the code, you'll see it prints A-1, then B-2 and C-3. So from this pairs list, in the first iteration, it gets this tuple as the first iteration value, and there we do unpacking and we take the letter and put that inside this variable, and we take that number and put that inside this variable, and we print that. After that, in the second iteration, we get this element in the loop index, and from there we take this letter and put that in this variable, and we take that number and put that in this variable, and same goes with the third one as well. Now this is often used when working with the dictionaries. So yes, tuple unpacking is happening even here, but we haven't covered dictionaries yet. So after covering dictionaries, we're gonna see these examples. So yes, tuple unpacking is happening in dictionaries as well. Now if you can remember, we had a lecture 1 on swapping numbers. So in that video, we used this tuple unpacking, if you can remember. For example, we have a variable called a, which holds the value 5, then another variable b, which holds the value 10, and we can swap them with the help of unpacking. So the typical way was taking a temporary variable, then assigning the value of a inside there, then inside a assign the value of b, and inside b we assign the value of temp. Then if you write the print statement, pass a, again write the print statement, pass b, and run the code, you'll see it prints 10 and 5. But you can make this shorter with unpacking. You can just write a comma b, then equal b comma a. Now if you run the code, you'll see the swapping works as expected. This is more cleaner and cooler. So that's all for this video. This is how tuple unpacking works. It is one of those features that makes Python really fun to work with. In this video, we are going to learn how to loop through a tuple and understand exactly how it works behind the scenes. So let's get started. So let's say we have a tuple called fruits, and there we have these elements: apple, then banana, and then mango. Okay, now we have covered loops in details. I'll request you to watch them before proceeding further. That will help you understanding these concepts more. So you can write for keyword, then the variable name, which will hold each element in each iteration. You can name this anything. So for fruit, in fruits, then just write the colon sign, and we can write the print statement and try to print each fruit in each iteration. If I run the code, you can see it prints apple, banana, and mango. We can comment this out and have another tuple called colors, and there let's say we have elements like red, then green, and then blue. Then you can write the for keyword for another loop, and then any variable name. I'm gonna call this I, then in, and we can use the range method here, and inside range we're gonna call the len method and pass colors there. So if we pass colors to the len method, it will return 3 because the size of the colors tuple is 3, and then that 3 will be passed to this range method. So it will take a range from 0 to 2, means 0, 1, 2. Now we can write the print statement, and we can use a string formatting here, and let's print the index by the I variable, and then we can write has value, then inside curly braces we can write colors, and inside square brackets we can pass the index again to access each element. So if I run the code, you can see Index 0 has the value red, index 1 has the value green, and index 2 has the value blue. So this length gets the length of this tuple, which is 3, and if you pass just 3 in the range method, it just takes a range from 0 to that number, in this case 2, 1 less than that number, in this case 3, so 1 less than is 2. We are passing here 3, so it will go to 2 from 0. Okay, if I run the code, you can see the output. Now let me make this comment as well and see how tuple works with while loops. Let's take another tuple called names, and there we're gonna have some names, for example Alice, then Bob, and then Charlie. Okay, now for indexing in while loops, we have to take variable explicitly, unlike for loop which handles indexing automatically. In case of while loops, we have to take a variable by ourselves. So here I'm going to write I equals 0, then I'm going to write the while keyword here, and the condition would be I less than len of names, means if the index is less than the length of the names tuple, which in this case 3. So if index is less than 3, then we want to proceed. So we want to print names and just pass the index. Then make sure to write I plus equal 1. If you don't write this, it will become an infinite loop and your program will crash. If you run the code, as you can see, it prints Alice, Bob, and Charlie. Now let's comment this out, this while loop, and let's cut this names tuple from here and paste that here. Okay, now we can write the for loop again for index comma name in enumerate. So we can use the enumerate method here as well, just pass names. So this enumerate method gives the index as well as the value of an element. So let me write the print statement and string formatting, and in between double quotes I'm gonna first write the index to print that. After that I'm gonna print the name. Now if I run the code, as you can see, it prints the index and the name. As you can see, the 0th index value is Alice, 1st index value is Bob, and the 2nd index value is Charlie. So Python here unpacks the index and the value to these two variables in each iteration. Now let me comment this again, and let's take another example with some numbers. So let's have another tuple called numbers, and there we have these values like 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and now what we can do is we can write the for loop. So for keyword, the num in numbers, and in the for loop we can do some if else as well. So I can write if num mod 2 equal 0. If that is the case, then we want to print with some string formatting, and there we want to print the num is even. So if the modulus result is 0, if that matches, then the number is an even number, otherwise it is an odd number. So if I run the code, you can see it prints 2 is even, 4 is even, 6 is even, and 8 is even. Okay, so I hope you are understanding the loops. I covered this in our previous videos, so I'm not going that much in details, but let me tell you that the length of this tuple is 8. So this loop means this code will be executed 8 times. So first the for loop will go to this tuple and will find that the first element is 1, and it will assign n inside num variable, because a variable is a container which holds some values. So in the first iteration it will hold 1, and then it will go inside that for block. So num holds 1. If you mod that by 2, the result is not 0, so it does not goes inside the if block and does not print anything. and goes to the for loop statement again. Now it is the time for the second iteration, and in the second iteration num has the value 2. Now in the if block 2 mod 2 is equal 0, so it is true, so it prints 2 is even. And after printing this, it goes to the for loop statement again. Now it is a third iteration and num holds the value 3, and 3 mod 2 is not 0, so it does not go inside the if block. Again it goes to the for block. In the fourth iteration, the num holds the value 4, and 4 mod 2 is 0, so it goes inside the if block and prints 4 is even. So other processes are done in the same way. Now let's take some examples with break and continue. For example, we have a tuple called animals, and there we have cat, then dog, and then rabbit. Okay, now let's write the for loop again. So for animal in animals, inside that for block we can write if animal is equal dog. If that is the case, then just break the loop. Otherwise, if that is not the case, print the animal name. So animal. Okay, so if I run the code, you can see it just prints cat. So what is happening here is, as the animal tuple length is 3, this loop will run 3 times. So in the first iteration, the for loop goes to this tuple and sees that the first element is cat. Okay, it assigns cat inside this animal variable, and then it goes inside the for block, and here it checks if cat is equal dog. So that is false, so it does not go inside the if block, does not runs the break statement, but it goes to the next line and prints the animal name, which is cat. And after doing that, it goes to the for condition again, and here in the second iteration it assigns dog inside this animal variable and goes to the for block, and now dog is equal dog, that is true, so it goes to the if block and sees there is a break statement. So what break does is, it tells Python interpreter that we do not need any iteration if the condition matches, so break the loop, we don't need any further iteration. Okay, now another keyword in Python, and that is continue statement. So if I write here continue and run the code, you can see it prints cat and rabbit. So in this example, what is happening is, in the first iteration, cat is being assigned to animal, which is not equal dog, so it does not go inside the if block, it goes to the next line, which is the print statement, and prints cat. Okay, after doing that, it goes to the for logic or the for condition and assigns a dog inside this animal variable in the second iteration. Okay, so now animal holds the value dog, so dog is equal dog, so this is true, so it goes inside this if block and founds we said that to continue. So if you write the continue statement, that means break only the current iteration and go to the next iteration, means stop the current iteration and move forward to next iteration. Break statement just tells Python interpreter that to break all the iterations in the loop, but the continue statement tells the Python interpreter to stop only the current iteration. So when it is dog, it tells Python interpreter to stop or ignore the current iteration and move to the next iteration. So it goes to the third iteration. Now rabbit is assigned to the animal variable, so rabbit is not equal dog, so it does not go inside this block, and it goes to this line and prints rabbit. I hope you understood how this is working. Let me comment this code as well and take another example to understand nested loops with tuple. For example, we have a variable called pairs, and there we have a tuple, and inside the tuple we have some more tuples. For example, here in the first child tuple we have a, then 1, then we have another child tuple, there we have b, 2, another child tuple, there we have C and 3. And now we can write the for loop and write variable called letter, then number in pairs. For that we can write the print statement, that's string formatting, double quotes, and we want to print letter and then just number. Okay, if I run the code, we'll see it prints A1, B2 and C3. Okay, so what is happening here is the outer tuple length is 3, so this loop will be running 3 times. So in the first iteration we get this tuple, and from there we are unpacking letter and a number. So in the first iteration we have this as the first element, and from there we are taking A and putting inside letter variable, and taking 1 and putting inside this number variable, and then we are printing that. Then in the second iteration we get this tuple, and from there we assign B to letter and we assign 2 to this number, and then just print again, as you can see, B2. Then in the third iteration we get this third child tuple, means the third element, and from there we unpack the letter C and assign that to this letter variable, then assign 3 inside this number variable, then we just print 3 and then we just print them, as you can see, C3. If I run the code, as you can see, A1, B2, C3. So the summary recap here is tuples are iterable. You can use for and while loops with them. You can use range to loop by index, or enumerate to get index plus value together. You can use break to stop early and continue to skip values. Nested tuples can be unpacked inside loops for clean data handling. And that's how we loop through tuples in Python. So that's all for now. See you in the next one. Now it's time to learn how to join tuples together. And trust me, this is one of the easiest and most useful tricks in Python. We'll also understand what's happening behind the scenes when you join or multiply tuples. So let's get started. So joining simply means combining 2 or more tuples into one. Since tuples are immutable, we cannot change an existing tuple, but we can create a new one by joining 2 or more. And in Python, the operator to join tuples is the plus sign. Okay, so let's see some example. Let's say we have a tuple called tuple 1 and that holds some values. For example, A, then B, and then C. And we have another tuple called tuple 2. Let's say there we have values like 1, then 2, and 3. So we have some indentation here. So Python is complaining. So unexpected indentation should not be there in Python files. Keep that in mind. Okay, so make sure there is no space before this if that is not necessary. So now after having these two tuples, we can join them. So as we can't modify tuples as they are immutable, what we can do is we can take another variable called a joined underscore tuple, and we can write equal then tuple 1 plus tuple 2. Okay, now if I write the print statement and pass joined tuple and run the code, you can see it joined the two tuple and made a new tuple. So here it doesn't modify tuple 1 or 2, instead it creates a new tuple with all the values from tuple 1 followed by all the values from tuple 2. Plus here works like concatenation, same as string joining. This also work with more tuples. For example, if you write another tuple called tuple 3 equal x then y, and here just write plus tuple 3, and now if you run the code, as you can see, it combined the 3 tuples into one. Okay, let me make these codes comment and I remove this line, and let's have another tuple called tuple anime equal, then let's say we have Naruto, and then death note. Now what we can do is we can take another variable called repeated. You can name this anything, and what you can do is you can write tuple anime, that existing tuple, then you can write the asterisk or the star sign, and if you write here 3, it will create a new tuple with these values 3 times. What do I mean by that? If I write the print statement and pass repeated and run the code, as you can see, it printed Naruto death note 1 time, then it printed for the 2nd time, and again it printed for the 3rd time. So here we're telling that take the values from the tuple anime and multiply them 3 times and create a new tuple and put that inside this variable. Okay, so I hope you understood the concept. Now let me comment this and let's discuss about a mistake, and that is, let's say you have a tuple called tuple 1, and there you have this tuple with the value 1 and 2. Then let's say you have a list called a list 1, and there you have this list which contains value like 3 and 4. Now the question is, can you join a tuple with a list or a string? The answer is no. So if you try that, if I write here combined equal tuple 1 plus list 1 and try to print combined, and if I run the code, you'll see it says type error, can only concatenate tuple to tuple, not list. So you can concatenate a tuple with a tuple only. You can make this work by using the tuple method. So if you write the tuple method and pass the list 1, so this will make this list into a tuple. So now this was a tuple already, and this tuple method makes the list a tuple as well. So now we can concatenate them. So if I run the code, as you can see, it works fine. Now before we wrap up, let's see a real world use case. So for example, we have a variable called user basic info. Let's call this user basic, and there this tuple holds the first name of the user, which is John, and the last name, which is Doe. And let's say we have another variable called user underscore details, and there we have his age and his country, for example USA. Now what you can do is you can write a variable called full user to show full user details, and you can just write user basic plus user details, and then just write the print statement and pass full user. Now here it is showing some warnings, but I think that is a bug of PyCharm, I don't know. But as you can see, this code is working. So let's say you are storing user basic data in somewhere in your application and the detailed data in another part of your application. Now while showing the user the data, you want to show them both data at the same time. So what you can do is you can combine them and then just use them. As you can see, we are printing full user and it is printing John Doe 25 and then USA. And that's how you join and multiply tuples in Python. It's simple but really useful when working with structured data. In this video, we are gonna explore tuple methods in Python. Even though tuples are immutable, meaning we can't add, remove, or change their elements once they are created, there are still a couple of useful built-in methods that work with tuples. Let's break them down one by one with examples and see what's going on under the hood. So Python tuples have only 2 built-in methods. First one is the count method and the second one is the index method, and both are incredibly useful when analyzing data inside a tuple. Let's see how the count method works. So first we write the tuple name, then we write a dot and call the count method and pass a value, and this checks how many times the value appears inside the tuple. So for example, we have a tuple called anime, and there, let's say we have Naruto, then One Piece, and again Naruto, then let's say Death Note, then let's say we have Bleach. Okay, now we want to check how many times Naruto is there inside the anime tuple. So for that, what we can do is we can write another variable to store that count. So I'm gonna write count anime equal, and after that we can write the anime tuple, then dot, we can write the count method, and we want to check how many times Naruto is there inside the tuple. So I'm gonna write here Naruto. Okay, after that I'm gonna write the print statement and pass count anime. So if I run the code, you can see it prints 2. That means Naruto is there inside the anime tuple 2 times. As you can see, 1 then 2. Okay, now if I write here a Bleach and run the code, as you can see it prints 1. That means Bleach is there inside the anime tuple for only once. We can do that with numbers as well. If I comment this out and take another tuple called numbers, and there let's say we have these elements like 1, 2, 3, then again 2, 4, 5, 4, 6. Then what we can do is we can write the print statement, and there we can write numbers dot count, and we want to count how many times 2 appears in that numbers tuple. So if I run the code, you can see it prints 2. That means 2 is there in the numbers tuple for 2 times. If I give here 5 and run the code, it prints 1. That means 5 is there in the numbers tuple for only once. If I give here 4 and run the code, as you can see it prints 2, because 4 is there 2 times in the numbers tuple. Now let me comment this code and uncomment this code. By the way, to comment and uncomment, you can use the shortcut which is command and / in Mac and control and / in Windows. So after this, we can use the index method as well. So let's say we want to know the index of the element Bleach, and let's rename this variable to index anime. Index anime. Now if I run the code, as you can see it prints 4, because Bleach has the index 4 in this tuple. Because this Naruto has index 0, this One Piece has index 1, this Naruto has index 2, this Death Note has index 3, and this Bleach has the index 4. So it is printing 4. But Bleach is there for only once in the tuple, but Naruto is there for 2 times. So if I try to get the index of Naruto, let's see what happens. If I run the code, it prints 0. So what is happening here is it just prints the index of first occurrence. So when we tell Python to check the index of Naruto, it goes to the anime tuple and it finds that it matched the first element. So it returned that element's index, which is 0, and discontinue the checking process. So it returns 0. Okay, if you cut this Naruto from the start and add this at the end and run the code, you can see it prints 1. So what is happening now is when we are telling Python to find the index of Naruto, it is going to the anime tuple. It is checking if this first element matches this one. It finds that this 2 doesn't matches, so it continues to the next one. So it sees that this one and this one matches, so it returns the index of this one, which is 1, and just discontinue checking other elements. So it returns the first occurrence index and does not check other occurrences. I can comment this code and uncomment this one. So we can work with numbers as well. If I write here index method and pass 4 and run the code, it prints 4, because as you can see the first occurrence of 4 is here. So 1 has 0 index, then 2 has 1 index, 3 has 2 index, 2 has index 3, and this 4 has index 4. Okay, if I give here 6 and run the code, you can see it prints 7 because it has the index 7. And always keep in mind that it will match only the first occurrence. So as you can see, it returns the index of this element. Now let me comment this and take another tuple called fruits, and there we have apple, then banana, and then cherry. But if we try to print the index of orange, which is missing in the tuple, then let's see what happens. So I'm going to write fruits dot index and let's pass orange. And now if I run the code, you can see it throws error, x not in tuple, means it is not there inside the tuple, so there is no meaning that it will have any index there. So to handle this kind of scenarios, what we can do is we can delete that print statement and write a if block, and we can check if orange is there in fruits. Then we want to print fruits dot index, then pass orange, meaning if orange is there in the tuple, then only find the index of orange. If that is not there, we want to print not found. So if the element is not there, that will not have any index for sure. So if I run the code, now as you can see, it does not throws that squiggly errors but shows not found. And that wraps up everything about tuple methods in Python. These two methods may be simple, but they are very useful when analyzing tuple data. So far we have learned many things about tuples. So if you want to try some exercises and check your gathered knowledge, what you can do is you can go to Google and search for gigs Python tuple exercises and visit this link. As you can see, there is many basic programs. You can open this and read the codes. You can copy them and go to your PyCharm and paste them and play with these codes to practice more. So it is a great resource here to find some basic problems and to play with them. By the way, if you want to do some question answers practice, then what you can do is you can search for W3 schools Python tuple exercises. Then open this link, and as you can see, there is many topics like tuples, access tuples, update tuples, unpack tuples. Then visit one of them. Now it will ask some questions. For example, which one of these is a tuple? So we know this is the one. Then submit answer. As you can see, it is the correct answer. Now the next question is use the correct syntax to print the number of items in the fruits tuple. So you can write here len, then just pass fruits. If you submit answer, as you can see, it shows that it is correct answer. Then you can go back to the next answer, and that is true false question answer. And the question is tuples items cannot be removed after the tuples has been created, and the statement is true. So if you submit answer, you can see every answer was correct. You can close this, okay, and go to the next topic. So by this way you can practice more and more. So I suggest you to visit these sites and practice to enhance your coding skills. So that's all for now. See you in the next one. Hey everyone, welcome back to the Python playlist. Today we are starting a brand new topic, and that is sets in Python. Sets are very different from lists and tuples, and they have some cool and unique features that you will love once you understand them. In this video we'll cover what is a set, how to create one, what makes it different from lists or tuples, and how sets work behind the scenes. So let's get started. So first of all, what is a set? A set is a built-in data type in Python that stores multiple items, and that is unordered, and it does not allow duplicates values and is mutable. Means you can add or remove items in set. Now let's see the syntax to create a set. So first of all, you take a variable. Let's say I'm gonna call this my set, and then you just write the equal sign, then curly braces. Yes, in lists we use square brackets, and in tuples we use parentheses, but in case of set we use the curly braces, and then inside those curly braces we just give values, as we did for lists and tuples. For example, we can give values like apple, then banana, and then let's say cherry. Now let's discuss what happens behind the scenes. When you create a set, Python stores the items in no particular order. It uses a hashing system to keep everything first, and it automatically removes duplicates if you try to add any. Now let's rename this my set to fruits, and let's print that. If I write the print statement and pass fruits and run the code, you'll see it prints the set. If I write the type method and pass fruits there and run the code, you'll see it says the type is set. Let me remove the type method and run the code again. But as you can see, it prints first apple, then it does not carries the order, and instead of banana it prints cherry, and at the very last it prints banana. So it is unordered. So we do not have any kind of indexing here, you can say. Now let me comment this, and our second point is sets does not allows us having duplicate values. So for example, if I have another set called numbers, and there let's say I have some numbers like 1, 2, 3, then again 1, then again 2, and if I write the print statement and pass numbers and run the code, you will see it just prints 1, 2 and 3. As 1 is duplicate for this value, so it avoids that, and it's avoid this 2 as well, because a set does not allows us having duplicate values. So even though we try to add more values that are twice or thrice, the set automatically remove duplicates. Now here is an important note, and let's see how we create an empty set. Now if you think about lists, if we want to declare an empty list, we just use the square brackets and do not provide any value there. But if we do that for sets, let's see what happens. If I try to print the type of anime and run the code, you'll see it says the type is dict or dictionary. So it is not the right way to declare an empty set, because it makes a dictionary at the end of the day. So to create an empty set, what we can do is we can remove this curly braces and just write set method and just call that. Now if I run the code, you'll see the type is set. Now the question is, when should you use a set? So the answers are when you want to store unique items only and you don't care about the order, and you want to check membership. For example, is something inside the set? For these cases, set is really fast. So sets are implemented using hash tables. So checking if an item exists is faster than lists or tuples in large data sets. So the recap here is, sets are unordered. It does not allow duplicates. It is mutable. We can change data here, and we don't have indexing. Indexing are not allowed as they are unordered. Before I wrap up, I want to tell you that in sets, Python considers 0 and false as same. Python also considers 1 and true as same as well. So as I told before that sets cannot have duplicate values. So if you try to put 0 and false together, 1 will be removed or ignored. If you try to put 1 and true at the same time, 1 will be removed or ignored. So let's see an example. Let's take a variable called sum_var, and there we have a set. Let me comment the previous code. Okay, Now inside here, let's say I have some values like 1, 2, 3, then true. Now if I write the print statement and pass some var and run the code, you'll see true gets removed or ignored from the set. But if you remove 1 from the set and run the code, you can see true is now available in the set, as sets cannot have duplicate values and 1 and true are same. That's why one of them getting removed or ignored. As you can see, true is not there. If I write 1 after true and run the code, as you can see, 1 got ignored or removed from the set. If you try to write 0 here, run the code, it can have a 0, but it can't have a 0 and false at the same time. If I run the code, you'll see it has 0, but it ignored the false. But if you remove 0 and run the code, you can see now it has false. So keep in mind that as sets ignore duplicate values and 1 and true is same in sets, that's why we can't take both of them together, and it is same for false and 0 as well. In the previous video, we learned about what sets are and how they're different from lists and tuples. Today we are going to learn how do you access items in a set. Now here's the catch: unlike lists or tuples, sets are unordered and unindexed, which means you can't use index numbers like set, then square brackets and pass an index like 0. But you can still access the items in useful ways. So let's break it all down. For example, if I take a set called anime, and let's say there I have values like One Piece, then Bleach, and then Naruto. Now to access, let's try how we used to access list items. Let's see if that works. So if I write here anime, then pass the index 0 here and run the code, you'll see it prints an error saying set object is not subscriptable. So as I told before, sets do not support indexing because the order is not guaranteed. So we can't say give me the first element because Python doesn't know what first is in a set. So how do we access set items? We use a for loop to go through each item one by one. So let me remove this print statement and I can write a for loop. So the for keyword, then let's take a variable called any in anime, then the colon, and let's try to print any. Now if I run the code, you'll see it prints One Piece, Bleach, and then Naruto. But if I rerun the code, you can see the Naruto is at the first place, then Bleach, then One Piece. If I rerun the code again, you can see again One Piece at the first place, then Naruto, and then Bleach. So in each run, the set data is getting ordered in different ways, differently. So there is no particular order. They are just get executed in a way so the process becomes fast. Behind the scenes, Python takes each element from the set one by one. It assigns the element to the variable any and executes the code inside the loop for each item. This is the standard way to access items in a set. Now we can do membership test. We can check if item exists or not by using the in keyword. So let me remove this code, and what I can do is I can write if Naruto in then the set which is anime, and if that case is true, we can print yes Naruto present in the set. Okay, now if I run the code, you'll see it prints Naruto present in the set. But here if I write Jujutsu Kaisen and run the code, you can see it prints nothing. You can write the else part here, and there you can tell that not available. So if you run the code now, you'll see it prints not available. That means Jujutsu Kaisen is not present in the anime set. Now the question is, if they are not indexed and properly organized, why we use them? Because sets are fast and efficient. This is one of the biggest strengths of sets. Why is it fast? Because sets are hashing internally. Checking for membership in it is much faster than a list or tuple, especially with large data sets. Now you can write like this as well. You can write the print statement and then check if bleach in anime. So it will print true. As you can see, it prints true. That means bleach is there in the anime set. Now let's learn how to add new items to a set in Python. So for example, we have a set called anime. There we have some animes like Naruto, then One Piece, and then Bleach. Now we can add items to a set using two main ways. So the first one is to use the add method to add a single item, and another one is to use the update method to add multiple items. So first let's see the add method. Before that, let me print the anime set. As you can see, it printed the anime set. Now we can write anime.add, and we want to add Jujutsu Kaisen. After adding, if I write the print statement again and pass anime set and run the code, as you can see, Jujutsu Kaisen got added to the set. Now keep in mind that add takes only one argument. If the item already exists, nothing happens, no error, just ignored. For example, Naruto is there. If I try to add Naruto again, for example, if I write anime.add, and if I try to add Naruto again, which is present in the set, then if I write the print statement again and pass the anime set and run the code, you'll see it does not add Naruto again. It only prints Naruto for once. So this got ignored by the interpreter. And that is because sets don't allow duplicates. Behind the scenes, when you call add method, Python hashes the item and checks if it is already exists. If not, if it stores it and it doesn't keep any particular order. That's why you may see items in random order when printed. Now let's see how we add multiple items with the update method. So update method. Okay, so here what I can do is I can write anime.update, and there I can write square brackets, and here I can pass some values. So for example, I want to add Death Note, then avatar. So keep in mind that we can give as much as values here by separating comma inside these square brackets. And after updating the set, we can write the print statement and pass the anime set again. Now if I try to print this, as you can see, it added Death Note and avatar to the set. And now here we are passing a list of some strings, but instead of lists you can pass here a tuple. If you run the code, you'll see it does work perfectly fine. And you can pass that as set as well, so you can use curly braces, and if you run the code, you can see it works as expected. So what's happening internally is update loops over each item in the iterable. It adds each one using the same hashing logic as the add method. Now here, if you make this a list and pass that, and with the update method, if you try to add Naruto again, or let's say you want to add Bleach again, if you run the code, you'll see Bleach is there for once in the set, because again, like the add method also ignores the duplicate values in case of sets. Now what if you want to add multiple items using the add method? What will happen? So let's see. If you try to add multiple items with the add method, if you give here a list or tuple or set which contains values like Demon Slayer, then solo leveling, as you can see, it already throwing error with the yellow squiggly lines. Then if you write the print statement and pass anime set and run the code, you will see instead of adding them as values, add method added the whole tuple as a single value in the set. So you should not use the add method here. You should use the update method if you want to add these values as a string in the anime set. To run the code, as you can see, now it is working fine. In the last video, we saw how we add some items in the set. Now let's see how we can remove some items from a set. So here, as you can see, I have a set called anime, and there I have some famous animes. Now let's see how we can remove some items from this set. So to remove, we have to write the set name, then dot, and we just call the remove method. And there, let's say we want to remove avatar. Then if I write the print statement and pass the anime set and run the code, you will see the avatar item is not available in that set. So behind the scenes, Python searches for avatar in the set using its hash. If found, it deletes it. If not found, it raises an error. So for example, I'm gonna write anime dot remove, and if I try to remove monster anime, which is not available in the anime set, and then write the print statement and pass the anime set and run the code, you will see it throws an error because we are trying to remove monster which is already unavailable in that set. Let me comment these lines and run the code. As you can see, there is no output. Now instead of remove method, let's use the discard method. So here, if I write anime dot discard and I want to discard bleach from the set, after that, if I write the print statement and pass anime and run the code, as you can see, bleach got removed from the set. Now let's say I want to remove an item which is not available in that set. So I'm gonna write the discard method, and if I try to remove monster again, which is unavailable in the set, let's see if it throws error or not. Print anime set and run the code. As you can see, it does not throws error. Basically, it does nothing here because monster is not available in the set. So I'll suggest use the discard method when you are not sure if the item exists. In that case, discard method becomes a safer option. So the tip here is use the remove method if you are sure the item exists. Use the discard if you are not sure or you want to avoid errors. Okay, now let's define another set called fruits, and there let's say we have values like apple, then banana, and then cherry. Now let's say I want to remove banana from this set. So instead of the remove or the discard method, we can use the pop method, and if we use the pop method, we can store the removed item as well. So what I can do is I can write removed underscore item equal, then I can write fruits dot pop. Now I can write the print statement, and here I can pass removed item, and I can write the print statement again and pass fruits. Now this pop method actually removes the last item of a list or a set, but as in every run a set gets ordered in different ways, so this pop method can remove any of the values. So what do I mean by that? So if I run the code, as you can see, it removed apple from the set, and the updated set contains cherry and banana. Now if I run the code again, you can see it removed cherry, and now the set contains apple and banana. So in every run, these values gets rearranged in the set, and the pop method removes the last item from that rearranged set. So behind the scenes, pop removes an arbitrary item because sets are unordered. You don't know which one will be removed. This method is mostly used when you just want to empty the set gradually. But what if you have an empty set and you call the pop method? Let's see what happens. So let's define an empty set called empty set, super original, and let's call the set method here. Then I'm gonna write empty set dot pop. Now if I call the method and run the file, you'll see it throws an error, says pop from an empty set, so it is not allowed. Now if you want to clear the whole set, what you can do is you can write the set name, in this case fruits, then dot, and you just call the clear method. Then if you write the print statement and pass fruits and run the code, as you can see in this line it removed apple. So the fruits set contains banana and cherry in this line, but when in this line you cleared the set, it made the set empty, so it just printed set and parentheses, so it's just an empty set. And that's everything you need to know about removing items from a set in Python. So let's see you in the next one. Now let's talk about how to loop through items in a set, and that is step by step like a beginner. So let's go. So the first question is, why loop through a set? So sets are collections just like lists or tuples. You might want to loop through all the items, maybe to print them, filter them, or perform some action on each. So yes, you can loop through a set using a for loop, but remember, sets are unordered, so the loop won't follow the order you added items in. For example, I have a set called fruits, and there, let's say I have apple, then banana, and then cherry. So to print using a loop, we can write the for keyword, then take a variable called for, and then the in keyword, and then the set name. Then write the colon, and there write the print statement and pass the fruit variable. If you run the code, you'll see it prints cherry, banana, apple. If you run the code again, you can see now it has a different order. Now banana is at the top, then cherry, then apple. So the output is in random order. So behind the scenes, Python takes the set and iterates over it using the internal hash structure. That's why the order is not guaranteed. Each item is fetched one by one and assigned to the loop variable fruit. This loop works exactly like list or tuple loops, but with no guaranteed sequence. But keep in mind, if you try to access some item with index, that will throw error. For example, if you write the print statement and write the fruit set, then pass an index inside the square brackets and try to run the code, you'll see it says set object is not subscriptable. That's because sets don't store items in index positions like lists do. Looping is the only way to access all items one by one. Now let's take another example with the if condition. Let me remove this so the error should disappear. Now inside the loop, what we can do is we can write if statements as well. So we can write if fruit, means in each iterate when the fruit will contain each value, we can check if that fruit name starts with the letter A. If that is true, then we want to print the fruit, otherwise not. Let me have another fruit called avocado. So now apple starts with A, avocado starts with A as well. So this loop will just print apple and avocado. If I run the code, as you can see, it prints apple, then avocado. Now you can use the len method here as well, in the for loop as well, or in the other places like here in the print statement. You can call the len method and pass the fruits a set, and if you run the code, you'll see it prints the length of the set, which is 4. Now you can count them as well. For example, you can take a variable called count and assign 0 there, and if you write for fruit in fruits, you just write count plus equal. Now you can print the count in each iteration here, as you can see. But if you print that outside the for loop, it will just print the length. Okay, so you can get the total items number by using this method or the length method. Now let's take another interesting example. So what I can do is I can work with the enumerate method in the loop as well. So I can try to take the index, though you should not take indexes from set, but let's see what happens. This will be interesting. So I can write here the in keyword, then I can write the enumerate and pass the fruits as set. So it will take each value and will put the value in the fruit variable, and that's index in this index variable. Now if I try to print the index and the value, let's see what happens. So I'm going to use string formatting here, and then let's print index, then a colon sign, and then the value means the name of the fruit. Now if I run the code, you will see an interesting thing. In the 0th index there is apple, the 1st index there is banana, in the 2nd index cherry, and in the 3rd index it is avocado. But sets do not have indexing. So what is happening here? So if I run the code again, you will see instead of apple, cherry is in the 0th index. So you should not work with enumerate or index while working with sets, because as you can see, as they get rearranged in each run, they get a different index in each run as well. So that you should keep in mind. So that's all for this video. See you in the next one. Now let's talk about how to join or combine sets in Python. There are multiple ways to do this depending on what kind of combination you want. For example, just merge everything, find common items, or even remove duplicates between them. So let's explore all of these options. So what does join sets mean? Joining sets usually means combining the items from 2 or more sets. Since sets are unordered and don't allow duplicates, Python handles merging in a special way. You'll learn 4 major operations. So the union method, then update method, then intersection method, and the difference method. So let's first take example of the union method. So union method. Let's say I have a set called set1, and there I have Spider-Man, then Superman, then Iron Man. Let's say I have another set called set2. There I have Superman, then Thor, and let's take Ant-Man as well. Why not? Now look closely. The first set contains a Superman. The second set also contains a Superman. Now if I write here the result variable, which will be a combined set, and after writing the equal sign, I can write set1 dot union, and inside parentheses I can pass set2. Now if I write the print statement and pass result and run the code, you'll see it prints Spider-Man, Thor, Ant-Man, Iron Man, then Superman. So instead of keeping Superman twice, it removed one of them. So in those 2 sets we had 6 values, but after joining them, as you can see, we have 5 values in the result set. Now we can achieve this using the update method as well. So it was the union method. Let me delete this comment. Now let me comment this union method, and if I run the code, you will see there is no output. Now let's achieve the same output using the update method. So what I can do is I can write set1 dot update, and inside parentheses I can pass set2. Now if I write the print statement and pass set1 and run the code, you will see it prints Ant-Man, Superman, Thor, Spider-Man, and Iron Man. But keep in mind that if you follow this way, you will lose the original set1, because after joining the set1 and set2, update method is putting the values of a previous set1 and set2 inside that set1. so we lose the original set1. So it was our update method. So it modifies set1 directly, adding all unique items from set2. Now again, let me comment these lines and see the use case of the intersection method. So intersection method, I will cut these sets from the top and paste them here so you can see properly. I'm gonna take another variable called result, then equal, gonna write set1 dot intersection, and in between parentheses I'm gonna pass set2. Now if I write the print statement and give result there and run the code, you'll see it just prints Superman. So the concept here is we just print the values which are available in the both set. Means that value is common in set 1 and as well as in set 2. This gives you only the common items between the sets. It is great when you are comparing data from two sources and want to know what they have in common. So let me comment these lines as well and see what the difference method does. So I'm gonna write difference method. Okay, so again I'm gonna take the variable result and I'm gonna write set1 dot difference and I'm gonna pass set2. Then I'm gonna write the print statement and pass result there. Now if I run the code, you can see it prints Iron Man then Spider-Man. So it just prints the value of set 1 which are not available in set 2. As you can see, Superman is available in set 1, but it is available in set 2 as well. That's why it is not printing Superman. If I remove Superman from set 2, then run the code, you'll see it prints Superman as well. So the key here is it will print the elements of set 1 if the particular value is not available in set 2. And that's how you join and combine sets in Python. You have learned how to merge them safely, find what's common, even subtract one set from another. So that's all for now. See you in the next one. Now so far we have learned many things about Python sets. So now you should practice on your own. So what you can do is you can go to Google and search for Python set exercises and then you can write gigs for gigs. Then hit enter, get this website, go there and you will find some basic set programs. You can view them, copy them, edit them as you can see and try on your own. You can write on your own by clicking on this edit code button. You can copy them and go to your PyCharm and paste and change the values or code and try on yourself. This will help you to think like a programmer and will make you a better programmer. And if you want to have a question answer session, then you can go to your Google again and search for Python set exercises, and instead of gigs for gigs you can go to W3 schools. Visit this site. As you can see, there are many topics. You can go to each topic and you can answer the questions. For example, here is a question which is which one of these is a set. So we know this one is the set which has the curly braces. You can submit the answer. As you can see, it is a correct answer. Then we can go to the next question and it is a true false question. So it is asking set items cannot be removed after the set has been created. So it's a false statement. Submit answer. Okay, as you can see, the answer was correct. We can go to our next question. It is also a true false question. The question is a set cannot have two items with the same value. This statement is true. You can select that and submit your answer. Again, it was correct. Now select the correct function for returning the number of items in a set. So we can get the number of items in a set using the len method. Submit answer. It was correct. Okay, so after completing one chapter, you can go to another chapter and answer those questions. So I'll suggest go to gigs for gigs and W3 schools and practice these codes and question answers as well. This will help you to become a better programmer. So far, we have learned about lists, tuples, and sets. Now it's time to start with one of the most powerful and useful data types in Python, and that is dictionaries. If you have used real-world data like user info, student records, product details, dictionaries are built for that. Let's learn what they are, how they work, and why they are awesome, especially for beginners. Now the first question is, what is a dictionary in Python? A dictionary is a collection of key-value pairs. It's written inside curly brackets. Each item has two parts. One is key and another one is value. So key is like a label or name, and the value is the actual data connected to that label. Think of it like a real dictionary. For example, let's say we have apple and we can write that it is a fruit. Okay, then we can have, for example, book, and let's say it is a source of knowledge. So it is a key and it is a value. So if you think like it is a real dictionary, this becomes the real concept. Now in Python, how we are gonna work with that? So what we can do is we can take a variable, for example student, then the equal sign, and we write the curly brackets or braces, and there we define the keys. For example, a student can have a name, so this is a key, and for that key we have to give a value, for example Naruto. Okay, then a student will have age, and there let's say the age is 20. Then we can have another key like is student, and that contains the value true. Now this is a dictionary. Okay, so here name is key and Naruto is the value for that key, and here age is key and 20 is the value. Here as well is student is key and true is the value. Internally, Python stores these pairs using hash tables for fast access. Now it was our first example where we created this dictionary, and we can print that. So I can write the print statement and pass student, which is a dictionary. If I run the code, you can see it prints the dictionary. If I write the type method here and pass student and run the code, you can see it says dict means dictionary. Let me remove the type method. Now you can also print a specific value from the dictionary. So you can write the dictionary name, then give square brackets, and inside that just write the key name. So in this case the key name is name, and now if I run the code, as you can see it prints Naruto, the value for this key. Now again I can write the print statement and write the student dictionary, and between square brackets and quotations I can say that I want the value of the age key, and if I run the code, you can see it prints 20. That's how you access the values by using keys. Now there are a set of rules for dictionaries. Now this is important for beginners, so let's have some notes. So first of all, keys must be unique. Let me make this comment. Okay, so you can't have two keys with the same name. So you have a key called a name. Now if you make this name again, it will throw error. Or for example, you have a key called age. Now you can't name this age. So these should be unique, otherwise it will throw error. Okay, now the second rule is a key can be a string. As you can see, name it is a string, age it is a string, a student is a string. So it can be a string, a number, or tuple. So keys must be immutable. These are immutable, but keys cannot be lists, not lists. Okay, and the third one is values can be anything. So in values you can put strings, numbers, booleans, lists, tuples, whatever you wish. Now let's take another example. For example, let's create a dictionary called person. curly braces. Then here we have a key called a name. There the name is Hinata. Okay, let's have age, and that is 18. And then let's have hobbies, and this can be a list because a person can have multiple hobbies. For example, Hinata has hobby like reading and then gardening. And then let's have another key. For example, is married. Let's say it is false, he is not married. As you can see, you can even store lists or booleans as values. Now let's see how you can create an empty dictionary. Let's say I have a variable called empty dict. You can name this anything, and you can just write the empty curly braces. The spelling mistake, let me fix this. Okay, empty dict, and you can just write the curly braces, and this will create an empty dictionary. So if I write the print statement and pass empty dict and run the code, you'll see it prints just the curly braces. It is useful when you are planning to add values later. Now internally, when you write student, then in between square brackets and quotations, the key, Python quickly looks up the memory spot for the key name using the hashing mechanism. This is why dictionaries are super fast when it comes to accessing or updating values. Now the recap here is a dictionary holds key value pairs. It is written with the curly braces, as you can see, curly braces, and colons here, as you can see, colons. You can access values using the key, like here, as you can see, the dictionary name, then the key. These must be unique. As you can see, these keys should be unique, can't be duplicate, and those have to be immutable. It can't be lists, and the values can be anything, means any data type. And that's your introduction to dictionaries in Python. We have learned what they are, how to use them, and why they are so powerful. In the next video, we'll go deeper and learn how to access values from dictionary properly, including how to avoid errors when keys are missing. So make sure to subscribe, and I'll see you in the next video. In the last video, we learned what dictionaries are and how they hold key value pairs. Today's topic is how to access those values in a right way. We'll learn how to get values using keys and what happens if the key doesn't exist, and we'll learn a safer way using the .get method, and even how to access all the keys or values at once. So let's go. Take a reminder from the previous video. So we created a dictionary called student, and there we have a key called name, and we can have a value like Gojo, for example. Then his age is, let's say, 25, and let's say the country is, and let's say the city is Tokyo. Now we saw how to access values using key. So we can write the print statement, and inside there we can write student, and in between square brackets and quotations we can write the key name. I run the code, you'll see it prints Gojo. Behind the scenes, Python looks up name in its internal hash table and gives you the value. This is super fast, but only if the key exists. Now what if key doesn't exist? For example, we want to access grade, but there is no key called grade in this student dictionary. So what will happen if I run the code? It will throw error. So it says key error grade. This is a common beginner mistake, so let's fix that. So instead of just writing student, then in square brackets and quotation grade key, what we can do is we can write the dictionary name, in this case that is student, then we can write a dot, and we can write the get method, and inside parentheses and quotations we can write the key name. Now even if this does not available in the dictionary, it won't throw any error. If I run the code, as you can see, it prints none. Now if you add grade, for example CGPA 4, let me give comma here and run the code, it will print 4.0, the grade actually. But if you remove this, now grade is not available, so it will by default print none, means it is not available. Now you can customize this message. In the second parameter of get method, you can give a comma after the key name, and here you can write another string. For example, you can write not available. Okay, now if you run the code, as grade key is not there, and that's why it printed not available. But if you add a grade here, for example CGPA 4.00, again let me give here comma and run the code, it prints 4.00 and ignores not available message. So this is a better approach. And now the question is why this is better. So the answer is easy. No error if the key doesn't exist. You can also provide a default value. As you can see, you can give a default value like NA, not available, not found, etc. This is super useful when working with user input or external data. Let me comment this line. Now if you want to get all the keys, how will you do that? For that you can do student, means you can write the dictionary name, then dot, then there is a method called keys. We can just call that. It will return all the keys. Then you can just print them. So if you wrap this inside the print statement and run the code, you'll see it prints dictionary keys, name, age, city, and grade. This is exactly what we have in the keys. So you get a view of all the keys. You can look through it or convert it into a list. Now you can get the values like this as well. So if I copy this line and paste, you just have to write here student.values. You run the code, you'll see it provides the values from the dictionary. Now you can have all the key value pairs at a time. So for that, what you can do is you can write the print statement and just write student, means the dictionary name, and dot, and just write items and call the method. Now if you run the code, as you can see, it prints the key value pairs all together. This is perfect when you want to look through the whole dictionary. So the recap here is we can access value using the dictionary name and giving square brackets and key in the quotations. To save access, we can use the get method with some default message as well. We can get all keys, all values, and their pairs as well. And that's how you access values in a Python dictionary. Always remember, use square brackets when you are sure the key exists. Otherwise, use the .get method when it might be missing. In the next video, we'll learn how to change existing values in a dictionary, which is super common in real-world apps. So if you are enjoying this playlist, don't forget to like and subscribe. See you in the next one. In the last video, we learned how to access items in a dictionary safely. Now it's time to learn how to change or update values inside a dictionary, which is super useful when you are working with data that needs to be edited, like user info, settings, or scores in a game. So let's dive in. Now the question arises, what does it mean to change a dictionary item? So dictionaries work with key value pairs. If the key already exists and you assign a new value to it, the old value is replaced. For example, let's have a dictionary called student, and there, let's say I have a key called name, the value is Gojo, and then age, let's say 20, and the city is Tokyo. Okay, now if I write the print statement and pass student and run the code, you'll see it prints the dictionary. Now if you observe, the age is now 20. Now if you want to change the value for the key age, what you can do is you can just write the dictionary name, in this case that is student, then in square brackets and quotations you can write the key name, for example age, then you can write the equal sign and write a new value, for example 21. So now after updating the age, what you can do is you can write the print statement again and pass student. And if you run the code, you'll see in the first print statement printed age as 20, but after this line age became 21. As you can see, it updated the age to 21. Behind the scenes, Python finds the age key and replaces 20 with 21. This was a basic example. Now let's see some example with add and update. This is important. Keep in mind that if the key already exists, in this case age key was there inside the student dictionary, then it updates. But if the key doesn't exist, it adds a new item. For example, so already exists, then it updates. Otherwise, adds new item. So here, as you can see, there is no grade key here. So if you write student, then square brackets, quotes, you write grade here, equal, and let's say the grade is A. Now if you print student dictionary and run the code, you will see it added grade A to the dictionary. So as the key was missing, it just added that key with this value. So student grade equal A acts like both add if missing and update if it's already there. Now let's have another example with the dot update method. So update method. Now currently the student age is 21. And what we can do is we can write student dot update, and we can write curly braces here inside update method. Then we can write a key name, for example age. Then we can give a colon, and here we can write a value, for example 22. Before the age was 21, we are making it 22. Now if I write the print statement and pass student again and run the code, you'll see it prints the age as 22. Now we can even update multiple keys at once. So here we are updating only age, but if you give here a comma and you wish to change the grade as well, I have to give here quotes. Inside there I have to write a grade, and you can change the grade here as well. So you can write here A+. Okay, so now if you run the code, you'll see previously the grade was A. As you can see, now after this line, grade became A+, and the age 22. So we are updating two keys at the same time. We can update as many as keys we want. Now when we want to update one value, we can use this approach, and if we want to update multiple values, we can use this approach. And for adding new key value pairs, either of them works. Okay, it doesn't matter. Now let's discuss about some common mistakes. So the first one would be if you write the student dictionary and then call the update method and just give the grade, means the key. If you do this, it will throw error. Keep in mind that you have to give the key as well as the value. For example, B. If you just write the key, it will throw error. Simple as that. Okay, and that's how you can change items in a dictionary. You now know how to update values, add new keys while updating, use .update method for multiple updates at once, and in the next video we'll explore how to add new items in more detail, especially with user input or dynamic data. Oh, before finishing, I want to tell you that now as we have gave both key and a new value, now if I run the code, you'll see that error goes away. You can write the print statement, pass student, run the code, you'll see now the grade is B. Now it's time to focus on adding new items to a dictionary in depth. This is especially useful when you are collecting user input, building a record system, or dynamically updating data during a program. So let's get into it. Let's say we have a dictionary called student. There we have a key called a name, and that has a value called Gojo. Then we have a key called age. The age is, let's say, 25. Now to add a new key value pair, we can use brackets. We saw that in the last video as well. For example, we can write the dictionary name student, then we can give square brackets, and in between quotes we can give a key name, for example grade, then equal, and a value. For example, we can give here A, means his grade is A. Now here it is showing some squiggly lines, you can ignore them. It says this dictionary creation could be rewritten as a dictionary literal. So at this point of time we don't have to worry about that. It works perfectly fine, just ignore those lines. Now here in this example, behind the scenes, Python checks if grade exists in the dictionary. Since it doesn't, it creates it and assigns A there. Now we also saw that we can add multiple items using the .update method. So what I can do is I can write student.update, and here I can give curly braces, and there I can write some key value pairs as well. For example, I can write here city, and let's say that would be Tokyo, and then I have another key called passed, and that holds the value true. Okay, now let's get rid of these squiggly lines. What you can do is, before modifying the student dictionary, just write the print statement and print the default student, and that just will remove the squiggly lines. That was happening because we did have some initial data. We were not printing those and was just modifying, so that's why the squiggly lines were there. So now as we are printing, so the squiggly lines has gone away. So as you can see, using the update method, we can add multiple key value pairs in the dictionary. So now the question is, why use .update method? Because it is cleaner when adding many items, and it works like merging dictionaries. Okay, now these examples we saw before in our previous videos. Now let's push ourselves a little bit further. We can take key as well as values from the user input. So what I can do is I can take a variable called new key, then equal, I'm gonna write the input method, and here I'm gonna give a placeholder, and the placeholder would be enter key. Okay, then I'm gonna have another variable called a new value equal, and I'm gonna write the input method again. Here the placeholder would be enter value. Now after getting the data from the user, what we can do is we can write the student dictionary, means the dictionary name, then inside square brackets we can give this new key which user provided. So I'm gonna write new key and equal new value, which is also given by the user. And after assigning that key and the value, what we can do is we can write the print statement and pass the student here. Now if I run the code, you'll see it prints name Gojo, age 25. Then it asks for a key. So let's say the key name is ID, and if I hit enter, it will ask for the value, and let's say the ID is 32. If I hit enter, you'll see it prints name Gojo, age 25. Then it added grade. It did not add grade in this statement, and even before asking the input. As you can see, these lines are before the inputs, but we are not seeing this because before these inputs and after these modifications we don't have any print statement here. It is getting updated here, student dictionary getting updated in these two lines, but as we are not printing, that's why we did not see the city and past value here before asking the new key and a new value, but it got modified here. The student dictionary got updated. Then it asks for a new key and new value, and when I give new key is ID and value is 32, it assigned that key value pair inside the student dictionary. And now after adding this data, it prints the student dictionary which has all of this. Okay, so even if I remove these two lines, as you can see, we have this student dictionary. We are printing that, and then we are asking for a new key and new value from the user, and then we are assigning that inside that dictionary and then printing that dictionary. If I run the code again, as you can see, the print statement prints Gojo, then age, and then we want the city as key, then we want the value would be Tokyo. If I hit enter, as you can see, it prints name, age, city. Okay, I hope you understood how we work with user input and the dictionaries. This is how real world applications grow a dictionary dynamically. Now what happens if the user input key already exists? As you can see, there is a key called age. Now if the user gives a key called age, what will happen? Let's see. If I run the code again, as you can see, it prints name is Gojo, age is 25, and let's say we have this age key. Now if user gives the key age again and then gives the value 20 and submits As you can see, it didn't add a new key value pair but just updated the age key value. As you can see, previously it was 25. After this line, this age became 20. So it simply updates the value, no error. So if key doesn't exist, it adds it, and if key exists, it updates it. This is one of the best things about Python dictionaries. Now let me comment these 3 lines and give you a bonus example, and that is we can have dictionaries inside another dictionary. For example, as you can see, we have this student dictionary. Now we can write this dictionary name student, then we can say that add another key which is address, and that key will have a value, and that value would be a dictionary as well, and that will contain the city, for example Tokyo, and then we can have a zip as well. Let's say that is 1200. Now why these squiggly lines? Okay, let me run the code actually. As you can see, it works fine. I think there is some issue in the PyCharm, or what is the error here? Means not error, it is a warning actually. Now here is some squiggly lines. This doesn't matter, you don't have to worry about that. I hope you just understood this is how you can create complex real world data structures like JSON style data. As you can see, the update, it is similar to JSON type data. When you will become a developer, you will understand more about JSON type data. So that's all about how you add items to a dictionary in Python. We have now covered adding a single item, multiple item through user input, even nested dictionaries. So that's all for this video. See you in the next one. Now it's time to learn how to loop through a dictionary, which is super important when you want to read or process all your data. Whether you are displaying user info, calculating values, or exporting data, looping is your go-to tool. So let's see how it works. So first, create a dictionary called student. There we have name, then Gojo, another key age, 25, grade A, and city is Tokyo. Now let's see first how to loop through the dictionary keys. For that, we can write the for keyword, then key, then the in keyword, and the dictionary name, which is student in this case. Then just write the colon sign and write the print statement and just pass the key. If you run the code, you will see it will print name, age, grade, and city. These are the keys. Now you can name this anything. This variable should not be key in name. You can write here ik, doesn't matter. If you run the code, you'll see the same output. But let's call this key. Now behind the scenes, when we write for key in student, Python automatically loops through the keys of the dictionary. Now you can ask, then how we will work with the values? So for that, in the loop, we will take the key, then let's print the key as well. After the key, we'll give a comma, then let's do a string concatenation, and here I will give a equal sign, then a greater than sign, then again concatenation, then I can write the student dictionary, and here I can just pass the key. So as you have learned before, if we write the dictionary name and pass the key in square brackets, it returns the value of the key. So now if I run the code, as you can see, it prints name Gojo, then age 25, grade is A, and city is Tokyo. This is the most common beginner pattern. Key is from the loop and student key fetches the values. Now if you want to access values without writing this, what you can do is, let me comment this, you can just write the for loop. So for value, again you can name this variable anything, then the in keyword, then just write the dictionary name and call the values method. Now if you write the print statement and pass the variable value and run the code, you'll see it just prints the values. For example, Gojo 25A, then Tokyo. Now you can ask, what if I want both, means the key value pairs?
So for that, let me comment this, run this. As you can see, the output is now empty. And for getting key value pairs all together, what you can do is you can write the for keyword, means the for loop, then you want the key and the value, okay, then the in keyword, and just write the student dictionary or the dictionary you created, then write the dot and call the values method, then write a colon sign, then again you can write the print statement, and let's do a string formatting, and here we want to print the key, then after that equal and greater than sign, and then we want to print the value. Okay, now if I run the code, it says for key two menu values to unpack. So what happened here? So why is that? Let me see. So it is showing error which is two menu values to unpack, and that is because we are trying to access key and value, but here as you can see I am calling the values method, but I have to call here the items method. Now it will return the key and the value as well. So now if I run the code, as you can see, it prints name Gojo, age 25, grade A, and city Tokyo. So behind the scenes, this items method returns a list of tuples like name Gojo, then age 21. So if I show you in a comment, it returns a list and that contains tuples like data. So it contains name like this, then there is Gojo, and after this tuple there is another tuple, there is a key called age, and the value is 25, and for these two there is more tuples like data, so I'm not writing them. Okay, now you can get a length of a dictionary as well. So you can write the print statement, then you can call the len method and pass the dictionary name. Now if you run the code, you'll see it prints 4 because we have 4 key value pairs in the dictionary. So this is how you would do it step by step. This is great for building logic from scratch. So that's how you loop through a dictionary in Python. So that's all for now. See you in the next one. Today's topic is copying dictionaries, which means making a duplicate of your dictionary so that you can safely modify the copy without affecting the original. This is super important when you are using a dictionary to a function, or when you want to work with different versions of the same data. Let's understand all the ways to copy a dictionary and how they work behind the scenes. So first of all, we can copy a dictionary with the copy method. Let's define a dictionary called student, and he has a name key with the value Gojo, and then the age key with the value 25. Now we can copy this. So let's take another variable called copy student. You can name this anything, and after the equal sign I'm going to write student dot, and I'm going to call the copy method. Now if I write copy student, and in between square brackets and quotations if I write grade, then just the equal sign, and in between quotations I can write A. So now let's print the original dictionary. So here I'm gonna write original, then I'm gonna write here student, and we also want to print the copied dictionary as well. So here I'm gonna write copy colon, and then I'm gonna pass the copy student. Okay, I missed the comma here. Now if I run the code, you'll see that the original student dictionary has 2 key value pairs, name Gojo and age 25. We have that original dictionary separate, and we have another dictionary here now as a copy, and there in that dictionary we are adding a key called a grade, and we are assigning the value A in that key. So as you can see, the original dictionary stays how it was before, and the copy dictionary, means the copy student, gets updated with the new key value pair. So behind the scene, what is happening here is copy method creates a solo copy of the dictionary. This means the new dictionary has the same keys and values but is completely separate in memory, and changing the copy dictionary doesn't affect the original one, which is this one. Now let me comment these two lines, and we can create a copy with the dict constructor as well. So here we used the copy method. Now we are gonna perform the same task using the dict constructor. So again, I will take another variable called copy student, and there I'm gonna call the dict method or the dict constructor, and I'm gonna pass the student. Okay, now if I run the code, you will see we have our original dictionary as well as the copy dictionary. This works same as the copy method, just another style that some developers prefer. Now you can add grade as well to the copy student dictionary. So now if I run the code, you'll see the copy student dictionary has this extra key value pair. Now let me comment this and see what happens when we use the assignment operator, which is this equal sign. So assignment, let me remove these two lines as well. Now let's say I have another dictionary called original. There I have a key called x, which holds the value 10, then another key which is y, and that holds the value 20. Now let's have another variable called clone, and we just want that it should be equal to original, means that original dictionary. Now let's see what it prints if we try to print the original and the clone. Now if I run the code, as you can see, both prints same values, means we have a clone inside this variable. This is also identical dictionary of this dictionary. Now what if I write clone and try to add a key value pair with the key name z and the value 30, and if I do this and run the code, as you can see, it added the z key value pair in both of the dictionaries, in the original dictionary as well as the copied dictionary. Because this is actually not a copy, you are just assigning a new variable that points to the same dictionary in memory. Any changes to clone will affect the original too, because both point to the same memory. So in the memory, both dictionaries are same, but in the previous examples, those were stored as original in the memory in some part, and when we created a copy dictionary, it got created in another part of the memory, so they were different. One was a backup and another one was a new dictionary. Now let me comment all the codes in this file and give you a bonus code, a bonus example actually, about the topic deep copy, to copy some nested dictionaries. So to do that, we have to import a package offered by Python, and that is the copy package. Okay, so we imported that. After importing, let me create a dictionary first. So the dictionary name is nested, and there I have a key called name, and the value is Ichigo. Then I have another key called scores, and this holds another dictionary, so a nested dictionary inside the parent dictionary, and this has a key called math, and the score is 90. Then another subject which is English, and the score is 85. Now create a copy of this nested dictionary. We can use deep copy. So let's take a variable called a deep_copy. By the way, you can name this anything. Then we're gonna use the package we imported, so copy.deepcopy, and just pass the nested dictionary. So it will create a copy of the dictionary, and that will be inside this variable, which is deep copy. Now if I write the print statement and try to print nested, then again if I try to print the deep copy dictionary and run the code, you'll see both prints that nested dictionary. Now how you can update nested dictionary key value pairs? So for that, what you can do is you can write the parent dictionary name, then in between square brackets just write quotes, and there you have this key which is course, which has another dictionary as a value. So what we can do is, after these square brackets we can have another pair of square brackets, and there we can have some quotes, and now we can access these keys as well, like math or English. For example, I want to access English. Okay, now if I pass this to my print statement and run the code, you will see it prints the score of the English subject. And let me remove the print statement, and let's try to modify the score of math. Previously it was 90, and let's make this 50. Now if I write the print statement and pass a deep copy, run the code, you'll see now the math score is 50. So this is how you access the nested dictionary key value pairs and modify them as well. So the question is, why use deep copy? Because if your dictionary contains nested dictionaries or lists, a solo copy will still share inner data. Deep copy copies everything completely, even nested structures. So that wraps up how to copy dictionaries in Python. We learned how to create a separate copy by using just assignment is dangerous, means the equal sign, because if you modify one dictionary it will affect the original as well, and how to safely copy nested dictionaries using the deep copy. Now you are fully equipped to work with Python dictionaries like a pro. If you found this helpful, please hit like, leave a comment, and subscribe more beginner friendly Python videos. See you in the next one, and happy coding. So in some of our previous videos we learned how to work with dictionaries. Now it's time you practice by yourself. So for that, what you can do is you can go to your Google and search for Python dictionaries exercises geeks for geeks, and go to this website. You'll see bunch of basic dictionary programs. You can open them, you can run, you can edit them, and you can copy these codes and get back to your PyCharm, paste them, modify the code, and try yourself. And if you don't want to open PyCharm, what you can do is you can search for a one-line compiler. So online Python compiler, and visit this site and just copy this code and paste here and just run, modify the code and try yourself. Okay, so this site is very helpful. Then if you want to try some question answer session, you can search for Python dictionary exercises and W3 schools. Open this link. As you can see, there are many topics, and this contains many question and answer sessions. So you can open one of the topics, complete that, and then open another topic. For example, I'm gonna open this topic. Now here it is asking which is a dictionary. So this is a dictionary, submit answer. Okay, this was a correct answer. Next question, dictionary items cannot be removed after the dictionary has been created. So the statement is false. Submit answer. Again it is a correct answer. Next question, again it is a true false question. The question is, a dictionary cannot have two keys with the same name. This is true. We can't have two keys with the same name. Submit answer. Correct. The next question, now to know the length we can use the len method. So we are trying to know how many key value pairs are there in a dictionary. So if I submit the answer, that was correct as well. So this topic is finished, this topic, and now you can open this next topic and try to answer them. So if you follow Geeks for Geeks, these programs, try to modify them and play with them and participate in these question answers, it will help you to become a better programmer. So I'll suggest you to try them more and more. So that's all for now. See you in the next one. Now let's talk about arrays in Python. Now you might be wondering, wait, don't we already have lists in Python? So why do we need arrays? It's a great question. Let's find out exactly what arrays are, how they are different from lists, and when you should use them. So the first question is, what is an array? An array is a data structure that stores multiple values of the same data type. Unlike lists, all elements in an array must be of same type, which makes arrays more efficient for numeric data. In Python, we use the array module to work with arrays. So first we have to import the array module, and then we define a variable called numbers. You can name this anything. Then we write array dot array. Then we just give parentheses, and inside quotes I'm gonna write I for making this array storing integer data. Then I'm gonna give a comma, and inside square brackets I'll give my values like 10, 20, 30, 40, 50. Okay, then I can write the print statement and pass numbers. Now if I run the code, you'll see it prints the array. Now behind the scenes, this I is a type code for assigned integers. As you can see, this PyCharm is showing it is a type code. Now there are other type codes, for example F for float, then D for double data type, means larger float, then we have U for Unicode character, and etc. Now let's see how we can access array elements. Now here we also have indexing just like lists. So what I can do is I can write the print statement, and then I'm gonna write the array name, which is numbers, and in between square brackets I'm gonna pass 2 as parameter. Now this 10 has index 0, this 20 has index 1, and this 30 has index 2, so it will print 2 if I run the code. And this 30 has index 2, so this will see the output 30. Now you can modify. So for example, I want to modify this 40, so what I can do is I can write numbers, then square brackets, and this 40 has the index 3, and then I'm gonna write the equal sign, and let's make this 45. Now if I write the print statement and pass numbers and run the code, you'll see it prints the array, but this time 40 becomes 45. So it works just like lists. Index starts at 0, and you can read and update values using index positions. Now let's see how we can loop through an array. So what we can do is we can write the for keyword, then take a variable, for example num, then the in keyword and the array. Then I can give a colon and just print the num. Now if I run the code, you'll see it prints the array items 10, 20, 30, 45, then 50. Just like looping through a list, each element gets printed one by one. Now let's see how we add elements to an array. So if I write here the numbers array, then I can call the append method just like lists, and I can tell that I want to append 60. And after that, if I write the print statement and pass numbers and run the code, you will see it appended 60 at the very last of the array. Now if you want to insert an item in an exact index or position, you can do that as well. So for that we have to use the insert method. So I can write numbers dot insert, and first you give the index. So I want to insert after 10, so the index would be 1, and the value I want to insert, that is 15. And after that I can write the print statement again and pass numbers there, and if I run the code, you will see it inserted 15 at the index 1. Now we can remove values from arrays as well, just like lists. So I can write here numbers dot remove, and let's say I want to remove 30. So after that, if I write the print statement and pass numbers and run the code, you will see before 30 was there in the array, now 30 got removed from the array. Now we can use the pop method as well to remove the last element from the array. So I can write numbers dot pop and just call the method. Now if I write the print statement and pass numbers and run the code, you'll see it removed the last element, which is 60, and that is missing in the last print output. Now we can get the length of the array as well, so I can call the len method and pass the array, which is numbers, and now if I run the code, you'll see it prints 5 because there are 5 elements in the array currently. We can get a specific index of a specific value, and I can just write the array name, for example numbers, then dot, and I want to know the index of 20. So I'm gonna call the index method and pass 20. Now if I run the code, you'll see it prints 2 because this 20 has the index 2, 10 has index 0, 15 has index 1. Okay, we saw many things about arrays in Python. Now the question arises when to use arrays instead of lists. So use arrays when you are working with large numeric data and you want to save memory and you want faster performance for mathematical operations. But for most general tasks, lists are more flexible in Python. And that's it for today's lesson on arrays in Python using the array module. We saw how to create arrays, access and modify them, add, remove, and loop through elements. In the next video, we'll be covering functions, so stay tuned. Now let's dive into functions, one of the most important concepts in programming. By the end of this video, you will be able to create and use your own functions in Python like a pro. So let's go. So the first question is, what is a function? A function is a block of code that runs only when it is called. Functions are used to organize code into smaller parts, avoid repetition, and make your code reusable. Now to declare a function in Python, we use the def keyword. After that, we write a function name, and let's create a function called greet. Then we give parentheses and the colon sign, and inside that block we write the function body. So for example, I can write the print statement, and in between quotations I can write hello, welcome to the Python course. Now if I run the code, you will see no output because we define this function, but if we want to tell Python to execute this code, we have to call this function. So now how do you call a function? So for that, you just have to write the function name and just parentheses, just like we called list methods and tuple methods and etc. Now if you run the code, you'll see it prints hello, welcome to the Python course. Now you can say that why we are writing 3 lines, we could do that just writing this single line. If we did not use function and just use this single line and run the code, you'll see the same output. But let's say you have a 3 print statement and this has another long text, then you have another print statement and this has long text, and if you run the code, it prints those 3 lines. But now let's say you come to a situation that you need to print this again. So what you have to do is you have to copy this and paste them below, then run the code. Okay, those got printed. Now let's say you want to print them again. So if you run the code, they got printed again. But now you can see, to write these 3 lines, we have to write some of 11 or 9 lines of code. Now if we used function here, what we could do is we could remove these lines and just wrap these print statements inside a function. So for example, that greet function. So now there's 3 print statement inside this greet function. Now if I run, you will see no output, but whenever you need output, you just call the greet function. Now if you call the greet function, it will print or execute these codes for 1 time. Now if you need that output again, you can call that function again, run the code, you'll get those output for 2 times. Now you can call that function as many times you want. You run the code, as you can see, those lines got printed for 3 times. So again, the def is a keyword used to define a function. This greet is the function name, and the code inside the function only runs when you call it using the greet, means the function name, and the parenthesis. Let me remove some of the code from here and create another function. So I'm going to write the def keyword, and this time the function name would be greet underscore user. Now here in this function we are going to work with parameters as well. So we wrote the def keyword, then the function name, we write the parenthesis, and inside the parenthesis we can take our parameters. So for example, we want a parameter called name, then we give the colon sign, and now I can write print, then hello, and we can concatenate with the name parameter. Okay, so now when we call the greet user function, we can pass a name. For example, I can pass Gojo here. So when we call the function greet user, it will take this data or the argument, this value, and it will store that inside there in the name. Means it will pass this value to this name parameter, and it will go inside the function and print hello and the name, which holds the value Gojo. So now if I run the code, you'll see it prints hello Gojo. Now you can call the function again, so greet user, and now you can pass Naruto, and if you run the code, you'll see prints hello Gojo, then it prints hello Naruto. So behind the scenes, name is a parameter. When we call greet user with Gojo, the string Gojo is passed to the function as an argument. So this is argument and this is parameter, and it gets printed inside the function. Now we can work with multiple parameters as well. So after name, if I give a comma, then I can take another parameter, for example last name, and after name here we can also print the last name. But as we have 2 parameters in the function, we have to pass them when calling the function, otherwise it will throw error. So after the first argument, we have to give another argument, for example Satoru. In the second function call as well, we have to pass another argument. So here we can tell that the surname is Uzumaki. Now if I run the code, you'll see it prints hello Gojo Satoru, and in the next line it prints hello Naruto Uzumaki. Now you can have as many as parameters in the function declaration, but you have to keep in mind that if you have those parameters, you have to pass arguments for them as well. So the first example was about a normal function, and this one was function with parameters. Now we can have function with return value as well. So what I can do is I can write the def keyword to create a new function. First, let me create a comment, and that is function with return value. Now after the def keyword, I can write the function name, and here let's say I expect 2 parameters, for example a and b, then colon, and inside the function body I want to add a and b, so I'm gonna write a plus b. Now I don't want to print that inside the function. Instead of that, I want to return the addition result from this function. So I don't want to use that result here inside the function, but I want to use this result outside the function. So I can return that to use outside the function by calling the function. So what I have to do is I have to call the function by add and parenthesis, and I have to pass the arguments. For example, I want to add 5 and 3, and it will return 8. So I have to store that inside a variable. So let's call that variable result. You can name this anything, doesn't matter. And then you can write the print statement, and inside quotation you can write sum is, then give a comma and just result. Now if you run the code, you'll see it prints sum is 8. Now again you can write the print statement, and inside the print statement you just can call the add function and here pass 6, 4. Now if you run the code, you'll see it prints 10. So the addition result was 10. So this return sends the result back to wherever the function was called. Now let's see an example of a function with the default parameter value. So this example would be on function with default parameter value. So to define that function, we're gonna use the def keyword, and the function name would be greet_student. Then we give parentheses, and here we can take some parameters. For example, I want the student name. Now let's say when you call the function, you don't want to pass the student name as argument always. You can provide or you cannot provide, as you wish. So for that, if you provide, you want to print the student name. Otherwise you just want to print a default value like a general student. So for that default value, you can write the equal sign, and then inside quotation, if it is a string, then you can write that value. Okay, now you can give the colon sign, then you can define your function body. So here you can write the print statement, and then you want to say hello and then just the name. Okay, so now it won't print anything unless we call the function. So we have to call greet_student. Now as you can see, though we haven't provided any argument here, it is not throwing any error or does not showing any squiggly lines because we have a default value there. If we don't pass any argument, that will use this value instead of a name. So now if I call the function, you'll see it prints hello student. I haven't passed any argument here. But if you pass an argument here, for example greet_student, and if you pass for example Ichigo as a student name and run the code, you'll see instead of hello student, it prints hello Ichigo. So this default value got overridden by this Ichigo name. Now you can have multiple parameter, as many as you want. So you can have a last name as well. Then you can have a default value, for example surname, and you can give the comma, then write the surname, means the last name. The parameter name is last name and the default value is actually surname. So here after Ichigo you can give here Kurosaki. Okay, now if you run the code, it will print Ichigo Kurosaki. But if you do not give the second argument and just pass Ichigo and run the code, you will see it prints Ichigo, and for last name it prints the default value, which is surname. But if you don't provide any default value, you have to provide the parameters. So this becomes a mandatory parameter. So I have to pass Kurosaki here. Now, so we fixed the second function call, but as you can see in the first function call, it still shows error. And if we hover on the last name parameter, you can see non-default parameter follows default parameter. So we should not use a parameter which has default value before a parameter that does not have a default value. We should always use the parameters which does not have default value at the beginning, and then we should use the parameters with the default value. So now if I run the code, from here I can pass Uzumaki for last name. Now if I run the code, you'll see it prints hello student Uzumaki, because name, we have not passed name here, so the value is used is student. Hello student, then a last name is provided, and that is Uzumaki. So it is printing hello student Uzumaki. And in the second function call, we are telling last name is Ichigo, but the last name should be Kurosaki, and the name should be Ichigo. Now if I run the code, you'll see it prints hello Ichigo Kurosaki. So keep in mind that we should write the parameters which has not any default value at the first place, then we should add the parameters with the default value later. Now we can have a function with multiple return values. So functions with multiple return values. So now the function name would be calc. Then we want two parameters, for example a and b, then the colon sign, and let's have two variables like add, and there we want the addition result of a and b, so a plus b. And after that, let's have another variable called sub, and we want the subtract result there, so a minus b. And now we can return both of them. So write the return keyword, and we want to return add and sub. Now when you call the function calc, so you want to know the addition result of 10 and 3 as well as the subtract result. And now this function will return them, so you have to store them. So we can store the addition result inside x, and we can store the subtract result inside y. So x comma y, then equal that function call. Now I'm seeing as squiggly lines because this variable name is add, and we have a function named add at the top. But let's see if that works or not. Now I can write the print statement here and add result, that would be x, then again print, and sub result, and that would be y. And now if I run the code, you'll see it works perfectly fine. And first we get our add result, 10 plus 3 is 13, and then we get our subtract result, 10 minus 3 is equal 7. So a function can return multiple values as a tuple, which we can unpack. So this function is returning add and sub as a tuple, and we are unpacking them. If you can remember, we understood how packing works in tuple in one of our previous video. So at the very end, again, if we ask that why we use functions, the answer would be it keeps code clean and organized, helps you use logic, makes debugging easier, and it is essential for modular programming and object-oriented programming. Now there are some naming rules for functions. So first of all, function names should be lowercase. As you can see, every letter of the function name is lowercase. You can use underscores or multi-word names. For example, calc underscore num, like this. And function names should describe what the function does. So this one is calculating, so the function name should be reasonable. You can name this z, but that does not make any sense. So if you write the function name calc, other programmers will understand that this function does some calculation. So descriptive name. So the summary here is we covered how to define a function and call a function, and that is with parameters and arguments. Then we used return statements, then default values, and we saw how to return multiple values as well. And now that's a wrap on today's lesson about functions in Python. In the next video, we are going to explore Lambda functions, a quick way to write small functions in just one line. So don't forget to like, comment, and subscribe for more beginner-friendly Python videos. See you in the next one, and keep coding with confidence. Now let's explore Lambda functions, also known as anonymous or one-line functions. They might look simple, but they are super useful when you understand how and when to use them. So let's go step by step. So the first question is, what is a Lambda function? A Lambda function is a small anonymous function. It can take any number of arguments but can only have one expression. It is useful for short, simple tasks without needing a full def block. The syntax of a Lambda function is, first we write the Lambda keyword, then we give the arguments, then colon sign, and then the expression. It automatically returns the result of the expression. For example, we can have an anonymous function called add, then we can write equal, and we're gonna write the lambda keyword, and we want two arguments. First we need the argument a, then the argument b, then we give the colon sign and the expression like a plus b. The expression result will be automatically returned. So now we can write the print statement and call the add function, and let's say we want to know the result of the addition 5 and 3. If I run the code, you'll see it prints 8. So here this lambda function defines two input arguments a and b, and a plus b is the expression being returned. And this function call add 5, 3 behaves just like a normal function call. Now we can use a lambda function inside a map function as well. So lambda inside map. Let's say we have a list called numbers which holds values like 1, 2, 3, 4 and 5. Let's take a variable called squared and let's call the list method, and inside that let's call the map method as well, and inside the parentheses we are gonna write the lambda function. So I'm gonna write the lambda keyword, then we want one parameter and that is x. After having the parameter we give the colon sign, and then we write the expression which will be returned. For example, we want the square value of x, so we're gonna write x into x, and we can give comma, and for the second argument of the map we're gonna pass the numbers list. Now if I write the print statement and pass the squared variable and run the code, you will see it prints the square values of these numbers. So as you can see 1, 4, 9, 16 and 25. So behind the scenes, map applies the lambda function to each item in the list, and lambda x colon x star x squares each number. Now we can use lambda function inside a filter method as well. So lambda inside filter. Let's say we have a list called nums, and there we have values like 1, 2, 3, 4, 5, 6. Now we want the even numbers, so we have to filter them to get only the even numbers. So I'm gonna have a variable called even, and let's call the list method. Inside that let's call the filter function, and in between parentheses I'm gonna write the lambda keyword, then I want one variable x, means one parameter x, then I will do a mod, so x mod 2, and I want to return that number if that mod result is equal to 0. And to this filter method I have to provide the nums. Now if I write the print statement and pass even and run the code, I will see it just prints the even numbers 2, 4 and 6, does not print the odd numbers. So the filter returns only items for which lambda returns true, means if this logic is true, then it should return the number from this nums list. Now we can use lambda function inside sorted method with custom key. So inside sorted method with custom key method, let's say I have a list called names, and there I have values like Naruto, then Kazi, then Ichigo, and then Gojo. Now let's take another variable called sorted underscore names equal, and we call the sorted method and pass names there, and for the key we are going to define a lambda function. So I'm going to write the lambda keyword, and I want the name parameter, and I'm going to pass name inside the len method. So it will pass the length of each string, means each name, to this len function, and it will sort with that length, because this lambda will return each name's length as key to this sorted method. So now if I run the code, you will see nothing because I haven't printed them. So I'm going to write the print statement and pass sorted names. Now if I run the code, you'll see it prints Kazi, Gojo. So Kazi is at the first place because it has only 4 letters. Gojo also has 4 letters. By the way, Naruto has 6 letters, and Ichigo also has 6 letters. So it sorted them. Because Kazi was at the first place, that's why even Gojo has 4 letters as well. Kazi is at the first position. So I hope you understood how the sorting happening behind the scene. So here we are sorting the list based on the length of names using the len method inside a lambda. So now the question arises when to use lambda functions. We use lambda functions when we need a short function used only once, or let's say we want to use them, or let's say we want to use a function inside method, filter, or sorted, or similar functions, and whenever we want a cleaner and compact code. Now when to avoid a lambda function. So if a function has multiple lines or logic, then we should avoid lambda functions. And when we want to make the code more readable and maintainable. So if I write a regular function with the def key, for example double the function name, and we want the x as parameter, and we want to return x into 2. Now we can achieve this using the lambda function as well. So if I write double here, then equal, and if I write the lambda keyword, then x parameter, then I want to write the expression x star 2. Okay, so we have redeclared the function. So let's call this double 2. So this function name and this function name is different now. But if I call both of them inside the print statement, if I call double function with the argument 4, and if I call the double 2 function with the 4 as well as argument, if I run the code, you will see both prints the same output, because at the end of the day they are both doing same task. But again, when you want to make the code more readable, use this approach, and when you want to make your code compact, use this approach. So that's all for this video. See you in the next one. Today we are diving into an important programming concept, and that is recursion. This is when a function calls itself, and it's a common technique used in many real-world problems like calculating factorials, solving puzzles, and navigating tree structures. So let's break it down for beginners in the simplest way possible. So first question is, what is recursion? Recursion is when a function calls itself to solve smaller instances of the same problem. It needs a base case to stop the loop and prevent infinite recursion. For example, we can create a function called func, and inside that we can call that function func. Okay, so calling the function inside that function means it is a recursion, but we always need a base case to avoid endless calls or infinite calls. So here let's have a parameter called n, and in the function body let's have a condition if n equal 0. If that is the case, we want to just return. Otherwise we want to call our function, but this time with n minus 1. So we are reducing the value of the provided parameter by 1. Okay, so this is how we create a recursive function. Now if I run the code, it will do nothing, but to make this real world function, we can rename this. So we can call this function count down. Then if n equal 0, we want to print it is done, and we want to return also. Otherwise, if n is not equal 0, we want to print n. After printing the current n, we want to call the countdown function again, but this time reducing the parameter value by 1. Now again, if I run the code, you will see nothing got printed, because this function will call itself, but for the initial call we have to call that from the outside. So I have to call this function, and for parameter I'm gonna pass 5. Now if I run the code, you'll see it prints 5 4 3 2 1, and then when n becomes 0 it prints done. So what is happening is, in the first function call, 5 is there inside n, so this logic is not true because n equal 5 not equal 0. So it goes to the outer block, does not goes to the if block and prints 5. Then again it calls the countdown function, and previously it was 5, now this time it calls the countdown function by reducing by 1, means 4. So again goes to the function, now n is 4 not equal 0, so it does not go inside the if block and prints 4, and then it reduces by 1 and call the countdown function again with the value 3. Okay, so for now in the function n is 3, which is not equal 0, so it does not renders this part and goes to the next line and prints a 3, and in the next line it reduces by 1 and becomes 2, and now it calls the countdown function with the value 2. Then again it goes to the function, this time it calls the function with 1, and as you can see it printed 1, but after the last time when n become 0, after reducing by 1, now n is equal 0, so it prints done and a return. That means it stops calling itself because it does not go there. Before that it just returns. Okay, so let me comment this example. Now there is a famous thing in mathematics, and that is factorial, and let's see how we can solve some problems like factorials using recursion. So we can create a function called factorial, and there we can pass n, and there we can have n as parameter, and here we're gonna say if n equal 1, if that is the case we want to return just 1, otherwise we want to return n into, then we're gonna call the factorial function and n minus 1. Okay, now it won't do anything unless we call from the outside for the first time. So here I'm gonna write the print statement and write factorial and pass 5 as argument. Now if I run the code, you will see it prints 120. So what is happening is, when we first time call factorial function, n is 5. Okay, so that is not equal 1, so it does not executes this line but goes to this line. So n is 5 into, and if we do factorial n minus 1, so we are calling that function again, so 5 minus 1 means 4. Okay, so ultimately now we have 5 into 4. Again it comes here, and now it calls the factorial using the value 3. Okay, so again it goes to the function, now n is 3, which is not equal 1, it does not execute this line, and it goes to this line, and with these values it add star 2, because 3 minus 1 is 2, so it calls the factorial function again with 2 as well. So now n is 2, which is not equal 1, so it does not execute this line, so it goes to this line, and now n becomes 1, so now it goes to the function again. So 1 equal 1, this is true, so it returns 1, so it does not goes to this line anymore, so the ultimate result becomes 120. So if I run the code, you will see the output 120. So if I show you a behind the scene process with some comments, so it is working like this. So it was factorial, then we are calling this with the argument 5, then in the next line we have equal 5 into, then factorial 4. Okay, and in the next time when it calls the function, it becomes 5 into 4 into factorial, and we call this function with the value 3. Okay, and in the next step it becomes 5 into 4 into 3, and again we call the factorial function with the value 2. Again in the next line we get 5 into 4 into 3 into 2, and we call the factorial again with the argument 1. And lastly, what we get is 5 into 4 into 3 into 2 into 1, and that's how it becomes 120. Okay, so I hope you understood how it is working behind the scenes. It keeps calling itself with n-1 until it hits the base case n = 1. Then each call returns and multiplies back up. Now let's have another example, and this is another interesting thing in mathematics, and that is sum of natural numbers. So we can create a function called sum numbers, and here we expect a parameter called n, and here the base case would be if n = 1, we want to return 1. Here I missed the colon. Okay, and we want to execute, so return n plus we want to call some numbers function with n-1. So if we want that this should be called for the first time, we have to call that from the outside. So I'm gonna call that some numbers with the argument 4, and let's print that as well. So I'm gonna write the print statement and pass some numbers function call inside that print statement. If I run the code, we'll see it prints 10. So in the first call, n is 4, so here we say 4, then plus, and we call some numbers function again with 4 minus 1 means 3. We pass 3 as argument, which is not equal 1, so it does not execute this line, and we get 3 here, and again it calls the function, this time n becomes 2. So 2 is not equal 1, it does not execute this line, and in this line we get 2, and this function gets called again, now this time with the value 1. Now 1 is equal 1, so it returns just 1 and does not go to this line again. This is how it becomes 10. Well, 10. So now if I visualize this like before, here first we are calling some numbers with argument 4. Okay, in the next line we get 4, then plus, and the sum numbers function calls itself, and this time with the argument 3. In the next line it becomes 4 plus 3, and we call the function again with the value 2. In the next line we get 4 plus 3 plus 2 plus, we call that function again, but this time with the argument 1. And in the next step we get 4 plus 3 plus 2 plus 1, and this is how we get the output 10. So every time a recursive function calls itself, Python stores the current function on a call stack. Once it hits the base case, in this case this one, it starts returning values back one by one. Think of it like stacking plates. Once done stacking, you return them from the top one by one. So now let's discuss about some risks of recursion. So risks of recursion. So the first risk is, if you write a function def ini, for example, and if you call that function inside that function, but if you do not include a base case like this one, it will become an infinite function. The function keeps calling itself infinitely. So if I call this function from outside, it will become an infinite recursive function. As you can see, it says maximum recursion depth exceeded. So when working with recursion, make sure to always provide a base case. Means when a function should stop calling himself, because Python has a recursion limit and the default is 1000 calls. Now when to use recursion. So it is good for breaking problems into smaller identical problems, for example tree or graph traversal, sorting algorithms like quicksort, etc. So the summary is, in this video we learned what recursion is and how it works, how to write a base case to stop recursion, And we saw some real world examples like countdown, factorial, and a number sum. So that's all for now. See you in the next one. In this video, we are learning about zip function in Python. It is one of the most underrated but super useful tools when working with multiple lists. By the end of this, you'll know how to merge list element like a pro. So the first question is, what is zip? The zip function takes two or more iterables like lists or tuples and returns an iterator of tuples. And each tuple contains elements from the iterables at the same index. Think of it like zipping two jackets. Their teeth get joined together pair by pair. Let's say we have two lists. First one is called names, and there we have values like Alice, then Bob, and then Charlie. And the second list is scores, and there we have values like 85, then 90, and 95. Now we can have another variable called combined equal, and we can call the zip function and pass names list and scores list as argument. Now if I write the print statement and pass combined, and if I run the code, you'll see it prints zip object and some memory location. So what I have to do is I have to call the list method and pass combined there to see the output properly. Now if I run the code, you'll see it combined two lists, and it took 0th index value from list 1 and list 2 and created a tuple at 0th index of this list. Then for 1th index, it took the 1th index value from names list as well as the scores list and created a tuple in the combined list at 1th position or the first position. And this happened for the 2nd index as well. Created another tuple with the value Charlie and 95. The result is a zip object which we converted into a list to see the result. Now we can look through zipped lists. So I can comment these two lines, and I can write the for keyword, and I can take name and score, and I'm going to write the in keyword, and inside zip I can pass names and scores, and I can print. So I can do some string formatting, and here I can write name, scored, and the score. Okay, so this will return each tuple in the for loop. So in the first iteration, it will have this tuple and will unpack name and score from this tuple and print that. And the second iteration, when index is 1, this tuple will be there in the for loop and will unpack Bob and 90 from this tuple, and we'll do the same thing for the third tuple as well. Now if I run the code, you'll see it prints Alice scored 85, Bob scored 90, and Charlie scored 95. Now we can zip as many as lists we want. For example, we can have another list called grades, and there we have grades like B, then A, and A plus. Now we can use zipping here by passing grades in the zip method, and we can unpack grade as well. And here we can say name scored score and got grade, and in between curly braces I'm gonna write grade. Now if I run the code, you'll see it prints Alice scored 85 and got grade B. Then it prints Bob scored 90 and got grade A. Then it prints Charlie scored 95 and got grade A plus. All three lists are zipped index by index. Just make sure all are of equal length. So every list should have equal length values. So if the first list has 3 values, the second one should have 3 values, and the third one should also have 3 values. Now we can have more or less values in these lists, and it won't throw any error, but it will do some misbehaves. So if I give less values in one of the lists and run the code, you will see it prints 2 lines instead of 3 lines. Okay, and if I give here more values and run the code, you will see the last value of the first list got ignored. If I comment this and uncomment this and run the code, you will see that the last value got ignored. And if I give less values and run the code, you will see that other lists last value got ignored. Now let's make this again 3, so Charlie, and run the code. You'll see the list. Now if I copy this list and paste that here and remove this, and let's store that combined list inside this combined variable. And now let's see how we can unzip a list. So it's a list of tuples. So to unzip, we can write names, then scores, and equal, we can call the zip method, and with star we can pass combined. Now with unzip process, Python will take each first element from each tuples in the list and create another tuple and put that inside this names variable, and Python will take the second elements of each tuple from this combined list and create another tuple and store that inside scores. Now if I write the print statement and pass names, and again if I write the print statement and pass scores and run the code, you will see it prints 2 tuples. So first tuple contains every name and the second tuple contains every scores. So that's all for now. See you in the next one. In this video, we are going to break down scope in Python, what it means, why it matters, and how it can affect your variables inside functions and outside. If you have ever seen an error saying a variable is not defined, it might be because of scope. Let's fix that today. So the first question is, what is scope in Python? Scope defines the area where a variable is recognized or accessible. In Python, there are 4 types of scope. So 4 types scope. First we have local, then enclosing, then we have global, and then built-in. So local means inside a function, a scope. Enclosing means in outer functions and nested functions. Enclosing means in outer functions as well as nested functions. Global means at the top level of a script or module, and built-in means automatically available, like the print statement. Python follows LEGB rule for scoping. So first it gives priority to local scope, then enclosing scope, and global scope, and then the built-in scope. So let's break it down with example. Let's say we have a function called greet, and there we have a variable called message with the value hello, and we are calling to print the message. Now if we call the greet function and run the code, you'll see it prints hello. We have this message variable. We can print that inside the function, means the function block, because both are local inside this function block. But if we don't call this function and run the code, it does not print, but the message variable is there in the code but inside the function block. But if I try to print that message variable outside the function, and if I try to run the code, you will see name error, name message is not defined. So here message is defined inside the function greet. It exists only while the function runs. Outside this function, this variable is not available or visible. Okay, let me comment this example. So it was an example of local scope. Okay, now let's take an example of global scope. So global scope, let me run the code. You can see the output is empty. Now if I write a variable called a name equal Alice, and if I create a function called say hello and write the print statement and say hello the name, as it is outside the function and in the top level of the program, so it is a global variable and we can access that variable inside functions as well. So now if I call the function say hello and run the code, you will see it can access Alice, and so it prints hello Alice. So name is defined outside of the function. Inside the function, Python can read global variables. But there is some gotcha here. So let's take another example. Let's have a top level variable or a global variable. For example, count equal 10, and let's create a function called update count. In the function body, I'll do count equal count plus 1. Then I'll print count. So if I try to do that, it will not allow me. It will throw error because count is a global variable and we are trying to modify that inside a local block inside a function. So if I call the function update count, it will just throw an error saying unbound local error, cannot access local variable count where it is not assigned with a value. So why is this error? Python sees count equal count plus 1, so Python assumes that we are trying to create a local variable inside this function, but you are using it before assigning a value inside the function. So we are using this count variable in the same line, so we are trying to use it before assigning a value inside the function. To fix it, you need to tell Python that you are using the global count. So for that, before this operation, you just have to write the global keyword and just write the count variable name. Now this will fix the error. Now if I run the code, you'll see everything works fine. So the count was 10. Now it became 11 in this line and we are printing 11. So global count tells Python that we are referring to the global variable, not a local one. Let me comment these functions, this as well. If I run the code, okay, the terminal is now clean. Now let's see example about enclosing scope. In other terms, non-local scope. So if I create a function called outer, which has a variable called x and that holds a string called outer, let me make the O capital, and inside that function let's have another function called inner, and there let's try to print x, so it looks in enclosing function. So now in the outer function, if I call the inner function, and outside the outer function, if I means in the main level, if I call the outer function and run the code, you'll see it prints outer. Here x is not inside inner, but Python checks the enclosing function outer and finds it. So for the inner function, the outer function is the enclosing function. Now let me comment this example as well, and let's see the use case of non-local keyword. Let's say we have a function called outer. There we have a variable called count which holds the value 0, and inside that outer function, let's say we have an inner function. Now we can have a non-local variable, so we can tell that we want to use that variable and that is non-local in this scope. So count, and we want to do count plus equal 1, and then I can write the print statement and just pass count. After that, inside the outer function, I can call the inner function twice, and in the top level I can call the outer function. Okay, now if I run the code, you'll see it prints 1 then 2. So non-local tells Python use the variable from the nearest enclosing scope, not global and not local. So it tells Python that do not create a local variable called count, and do not use global variable as well. So if you have a global variable, non-local tells to not use that as well, but just to use the nearest enclosing scope. Means it is the function scope, so its nearest enclosing scope is this outer function scope, means the immediate parent function, you can say. So the summary here is Python checks variable in this order, which is LEGB, local, enclosing, global, and built-in. Use global keyword to modify global variable inside a function, and use non-local keyword to modify a variable in an outer but not global function. Scope might sound scary at first, but once you understand LEGB and how Python looks for variables, you will write cleaner and safer code. So that's all for now. See you in the next one. Hey everyone, in this video we'll learn how to gracefully handle errors in Python using try, except, and even finally. Instead of your program crashing with a scary red error, you can catch it and handle it smoothly. This is what professional developers do, and you are about to learn it too. So the first question is, why try and accept? So imagine asking a user to enter a number and they type text instead, and your program just crashes. It's not cool, right? So using try and accept, we can anticipate errors and deal with them without breaking the program. So the basic structure of a try and accept block is, first we write the try keyword, then give a colon, then we get a try block. Inside there we write the code that may cause error. Okay, it may or may not cause error. So if it cause error, we handle that in the accept block. In the accept block we get the error. For example, the error is some error, then we give a colon, and inside the accept block we tell Python what to do with the error. Okay, now that you have understood the basic structure, let's have a real world example. So I'm gonna write the try block again, and here let's say I have a variable called x which holds the value 10. Then we have another variable called y, and that holds the value 0. Okay, now if I write another variable called result, and there if I try to divide x which holds the value 10 with y which holds the value 0, and then try to print the result, now it will throw error. You know it, I know it, so you have to handle that. So for that we write the accept keyword, and now we accept the 0 division error. Then we give a colon, and we tell the Python if any 0 division error occurs in the try block, then just print you cannot divide by 0. Now if I run the code, it prints you cannot divide by 0. But if I make this 2 and run the code, you'll see it prints 5. So Python executes code line by line. First it executes this line, then this line, then it executes this line, and run the code, you will see it prints you cannot divide by 0. Now let's comment this out. Let's say we don't want the try block or the accept block. We just want to run this code as we used to do normally. So we have these variables x and y, then we try to do the division operation, 10 divided by 0, and we want to print the result. If I run the code, you'll see it not only throws error but also crashes the program and shows the error in a scary way. But if we wrap the code inside the try block and we handle that inside the accept block, then it will tell the user about the error, but it won't crash the program. As you can see, it does not crash the program but notify the user that you cannot divide by 0. Now this try and accept blocks shines when we work with the user inputs. So let's see another example. Let me comment this code actually, and let's define another try block. So I'm going to write try and colon, and here let's have a variable called num, and here we expect a user input. So I'm going to call the input method, and here we tell the user that enter a number. Okay, now Python takes every input as a string, so we have to convert that into integer. So let's wrap this input method inside the int method. Okay, then after that, when user gives the number, we want to print that you wrote and then just give the number. Okay, now here a value error can happen. So if user gives letters instead of numbers, so it can throw a value error. So we expect a value error here. So I'm going to write value error, then colon, and write the print statement. Inside there, I'm going to write that is not a number. Okay, now if I run the code, it asks for a number. So if I give here 12, Python will take 12 as a string, but as this string contains a number, this int method will convert that string into a number. So if I submit, as you can see, it tells that you wrote 12. But if I again run the code, now let's say if I write ABC, now this ABC is not number, so this int method cannot convert this ABC to an integer. This is actually impossible. So if I submit this, it says that is not a number. So this line causes value error. So Python does not goes to this line and just jumps to the accept block. Now let's see how we work with multiple accept blocks. Let me comment this and write another try and accept block. So let me write the try block, and here let's say we have some codes that can throw two kinds of error. So here I have a equal, and here let me call the int method and just pass ABC. Now int method cannot convert letters into integer, so this line will throw error. It will throw a value error actually. Then let's say we have another operation which is b equal 5 divided by 0. Now this is not possible either, and this will throw zero division error. So we have to handle both probable error with the two accept blocks. So first I'm gonna write the accept block, and this line can throw value error. So let's hold the value error and colon, and let's print value error occurred. Now this line can throw error as well, and that will throw zero division error. So I'm gonna write the accept keyword again, and it can throw zero division error. Then I'm gonna give this colon and just write the print statement, and I'm gonna write division by 0 is not possible. So now if I run the code, we'll see that a value error occurred. So as you know, Python executes code line by line. So first it executes this line, then it goes to the next line. When it sees that there is an error, it just stops in the try block and jumps to the value error part and prints value error occurred. But let's say we fix this error and put here 12 and again run the code. Now when Python comes to this line, it does not sees any error, so it does not jumps to this block, but it goes to this line and finds that this line holds error, and that is zero division error. So it jumps to this accept block and prints division by 0 is not possible. So the flow of the code should be maintained while handling the errors. Now as you can see, this throws value error, this throws error type of zero division error. But let's say your program can throw an error whose type you don't know. So how will you handle that? So let's see how we can handle that situation. Let me define another try block. Let's say I'm gonna say name equal my name. Now my name is not defined, so this line will throw error surely, but the type of this error we don't know that. So to handle this kind of errors, what we can do is we can write the except keyword, then we have exception, so we write exception, this keyword, then we say we want all the exceptions as E. Now you can name this anything, E or R or error, it doesn't matter. Let's call this E, then colon, and we just can write print an error occurred, and let's also print the E. Now if I run the code, you'll see an error occurred, which is this message, and the actual error is my name is not defined. We can hold all the errors whose type we don't know in this exception. Now let's see the use case of the finally block. Let me comment this. So let's write the try block again, and here let's do x equal 1 divided by 0, and let's write the except keyword, and here we expect the zero division error, and in the print statement we just say that error occurred. Okay, then after this except block we can write a finally block, and there in the print statement we can say that this will run no matter what. Okay, so if I run the code, you'll see that it prints error occurred, then it prints this will run no matter what. So what is happening here is Python coming to this line and seeing that here we have this zero division error, so it jumps to this block and prints that, and we tell Python that after executing this, finally you have to execute this part. So even if I do 1 divided by 1, then print x and run the code, you'll see it prints x, which holds the value 1, and it also prints the finally block print statement, which says this will run no matter what. So this part of the code will run if the try block succeeds, or fails means the except block executes. So as you can see in this case, first it printed the try blocks print statement, then it printed the finally blocks print statement. But if I write here 0 means 1 divided by 0 and run the code, at this time it didn't printed the try blocks print statement, it printed the except block print statement and the finally block print statement. So keep in mind that the code inside the finally block will run no matter what happens. It will run if error occurs, and it will also run if error not occurs. Now we can merge try except and finally with the else block as well. So let's see that example too. So I'm gonna comment this, and here I'm gonna write the try block. Let's write the print statement, just write no error here, and we can write the except block, and in that block we can tell that something went wrong. Okay, now if the except block does not executes, we can't execute the else block, and there we can say that try block succeeded. Okay, so you can consider this too as if else. So if any exception occurs here, print that from this except block, otherwise go to the else block and execute the code in the else block, and we can have the finally block as well, and there we can say that it runs always at the end. Okay, now if I run the code, you'll see it prints no error here, means there is no error in the try block, so it ignores the except block. So as we are not executing the except block. Instead of this except block, it goes to the else block and executes the code inside the else block. And this block, as you know, will be run always. So we see the output, no error here, then it ignores this line, it prints try block succeeded, then lastly it runs always at the end, means the finally block. So I hope you understood how we work with a try, except, else and finally. I hope now you are ready to stop your programs from crashing and start handling problems like a real developer. So that's all for now. See you in the next one. Today we are going to learn how to debug Python code using PyCharm. It is one of the most powerful tools for Python development. Debugging means inspecting your code step by step to understand exactly what it's doing and where things might be going wrong. So let's get into it. So the first question is, why debugging? So sometimes your code doesn't give the expected output or breaks in ways you can't easily see. Instead of guessing the problem, you can watch it happening live using a debugger. And to do that, we use breakpoints. Now, what is a breakpoint? A breakpoint is a red dot you place beside a line of code in PyCharm. When you run the debugger, the program pauses at the breakpoint, allowing you to inspect variables and the flow. Let's define a function called add and divide. And here we expect two parameters, a and b. Inside that function, we want to know the sum of those two parameters. So a plus b. Then we can have another variable called result, and there we can write sum underscore divided by the subtraction result of b minus a. Okay, and after doing that, we want to return the result. Let's say we have another variable called x, which holds the value 5, and y, which also holds the value 5, and we can define another variable called output, and we can call the add and divide function and just pass x and y there. Then after getting the output, we can print output equal output. Okay, now if I run the code, it will throw an error. As you can see, it says 0 division error. So what is happening here is we are passing 5 and 5 for the parameter a and b. So here in this line, sum becomes 10, and we are dividing 10 by 5 minus 5 means 0, so it is throwing 0 division error. But it is a small code. If the file was a little bit big, means let's say it holds thousands of lines of code, then how will you debug? You can't just read every line of code to find one bug. That's not how the things works. And in this situation, the debugging comes into the picture. So as you can see in the left side, we have the code line numbers. We can add some breakpoints on those lines. As you can see, that red dot. So let's add a breakpoint in this line, and instead of running the code, we are gonna click on this debug button. Now it will show a debug menu to you. Now here you can rerun the debugging, stop the debugging, resume the program, pause program, then step over, step into, then step into my code, step out, and there are many options. And now the beautiful thing about this is you can see what is happening in each line. As you can see, it stopped in this line, in the line number 3, and in the line number 3, as you can see, the value of a is 5 and the value of b is also 5. Okay, now this step into and step over, these two buttons is more used than the others. These are really helpful. So let me tell you what these do. If you click on this step over button, it will go to the next line and execute the next line. But if you click on this step into, it just tells the Python to go inside the function calls. So now if I click on this step over to go to the next line, as you can see, now again a is 5, b is 5, but the sum variable now has the value 10. As you can see here also it says sum variable holds the value 10. Okay, now again if you click on this step over to go to the next line, it just tells you that the error is in this line. As you can see, it says in this line we have a zero division error, and it indicates with the red thunder sign as well. Okay, so this is how you can inspect the code by yourself and find the bugs in your code. Now you can right click on a variable here in the terminal and add to watches, so you can keep track of that variable, means in which time and which moment it is changing, it is updating, or whatever happening to its value, you can track them easily. Okay, and after finding the bug, you can just stop the program and just fix that and run that. Let me fix the bug, say this one, and if you click here it will remove the breakpoint. Now you can just run the code. You'll see it says the output is 2, because when sum becomes 10, if we divide by 5, the result is surely gonna be 2. You can use this debugging mode to understand the code as well. So here if I remove this code, or let me just comment this, and let's have a variable called I which holds the value 0, and I'm gonna write a while loop, and I'm gonna tell that while I is less than 5, I want to print I. Okay, and after that I just want to increment I, so it does not goes to the infinite loop, and I want to increment by 1, and I have to reassign the updated value inside I again. So now if I run the code, you'll see it prints 0 to 4. Now let's say you want to understand what is happening here. Let me remove the above code, actually I don't want that. And now let's say you want to understand what is happening behind the scene in this code. So what you can do is you can add a breakpoint here, then click on this debug button. You will see this error. It says name error, name A is not defined. That is because in the previous example we added the A variable to our watch list. So right click on this error and click on this remove all watches. Okay, now stop this and click on this debug button again. As you can see, now it is running properly. So we have added the breakpoint in the first line, so there is no changes in the code. But if I click on this step over, as you can see, after executing this line, I becomes 0. If I again click on this step over, now we are inside the while loop, so it prints 0. Again if I click on this step over, still I is 0, but after executing this line, it goes to there and I becomes 1. So again it is in the third line. If I click on step over, it goes to the print statement, means the line number 4, and prints 1. Again if I click on step over, it adds 1, and after executing the line, I becomes 2. So by this you can see what is happening in the code step by step. Again step over, it prints 2, step over, for executing this line, step over, I becomes 3. You can click the step into as well. Again step into, again as you can see, I becomes 4. So this is how you can see the code execution process step by step using the debugging mode, and you can fix the bugs of your code as well. So PyCharm's debugger lets you run code line by line. You can pause, inspect, watch and fix bugs easily. So breakpoints and stepping are your best friend. After seeing the coding process or debugging, you just can stop the debugging and fix if there is any bug, and you can just run the code. You can see the output. So that's all for now. See you in the next one. In this video, we are starting a new section, which is file handling in Python. And the first step is learning how to open a file, read its content, and understand how it works behind the scenes. So the first question arises, why file handling? Sometimes we need to read data from a .txt file like user data or logs or something else, etc. And we need to process that data and analyze that data after reading that data from a file. And sometimes we need to save some output into files. So in those cases, we need to handle those scenarios. Now, how to open a file? So in Python, we have a built-in function called open, and inside that open function, we give a file name and a mode. So the file name is basically the name of the file, including the path, means where the file is located if not in the same folder. And the mode tells Python how to open the file. So there are a few modes, for example R, which means read mode. Then we have W, which means the write mode. And by name you can understand that read mode actually reads a file. But the gotcha here is the file must exist. And the write mode creates a file if not exists and overwrites if it does. And then we have A mode, means the append mode, and it adds to file keeping existing content. So if a file contains some content, it adds further content after that previous content. Then we have X mode, means exclusive creation, and it fails if the file exists. Then we have B mode or the binary mode. It is used with other modes. Then we have the T mode or the text mode, which is the by default mode. Now if I open this panel, you can see we have created so many files here and all of them are Python files. Now let's create a text file. So I'm going to click on this plus icon and click on this file, and let's name this test.txt. Okay, so now it is a text file and it is in the same folder. So as you can see, this file where we are working on, it is in the my project folder, and this test.txt means this text file is also in this folder, means the my project folder. So both are in the same folder. Now let's write some text inside this file. So for example, hello, subscribe to this channel. Okay, now I can save this file. Now from this file, means this Python file, we want to see what is written in the text file. Now how we can do that? We want to read that content and print that in our output, means in the terminal. So for that, what we can do is we can have a variable. You can name this anything. I'm gonna call this file, then equal, and we just call the inbuilt method of Python, which is open, and here we give the file name in the first argument. So the file name was test.txt. As you can see, the PyCharm is suggesting me the file name. Now after that, we want to tell our Python in which mode we want to read. So the mode is R, means read. So why these suggestions? Okay, so after writing this line, what you can do is you can write another variable, for example content, and you have to write the first variable, which is this one, file, then dot, and you just write the read method and call that. Okay, now if you write the print statement and pass the content, Python will go to this file, read that, and it will print that content in the terminal. And it is the best practice after using the file.read method, we should close that. So I'm gonna write file.close. Okay, so now if I run the code, you will see it prints hello, subscribe to this channel. So how amazing is that? We are getting content from a file. Now you can copy this line and paste 100 times, or let's say 5 times. 100 times is very much. Then you can have other contents, for example other content, then long content. You can save this, and if you go to this files.py file and run that, you'll see Python reads the whole file content and it prints in the terminal. So behind the scenes, this open method opens the file in read mode. This one, it opens the file in read mode, and this file.read reads the entire content from that file. It opens and it reads the entire content. So always remember to close the file with file.close to free up resources. It is best practice. Work with the memory more efficiently. Now, if your file is too much big and contains thousands of lines text, you can make this more efficient. So after writing this line, what you can do is you can write a for loop. So just write for a line in file, then give the colon and just write the print statement, and inside there you can just write line dot strip, okay, and call that method. Now this strip removes a new line. That means we are looping directly over file and it reads it line by line, which is more efficient for large files. Okay, so now if you run the code, you'll see prints line by line. You won't see the difference here, but if you have more content here, for example 2000 or 3000 lines, then this program will become more efficient, because now file reads the content line by line instead of reading the whole file at the same time. Now let's see another example with the with keyword. So what I'm gonna do is I'm gonna write with open, and inside there I'm gonna write the file name, which is test.txt, then obviously read mode, then I'm gonna write as file, means I'm taking this variable, you can name this anything, and after the colon we get a block, and there we can say that content equal file dot read method, and we can just print the content. So if I run the code, you'll see again the same output. If you add more content here, paste that, save, go to the Python file, run the code, you will see it prints the whole text. So the question arises, why use with keyword? So if you use the with keyword, you don't have to close the file manually. It automatically closes the file, and it is a bit cleaner and safer code, you can say. Let me comment this code, and again let's write the first code, which is file equal open, and there test.txt, mode is R, then we have this content variable. Inside there we call file.read, then print the content, then we just do file.close. Okay, I can run the file, it works perfectly fine, but we have this test.txt file in our folder. But what if we want to open a file and that is not available in the folder? For example, I want to open testing.txt file, which is not available in this folder. As you can see, it is not available. So what will happen? Let me run the code. You'll see the error, file not found error, no such file or directory, testing.txt. In these scenarios, when a file can be there or it can be unavailable, so to handle that, you can use the OS module. So what you can do is you can import the OS module, import OS. Okay, after importing OS, you can check if os.path.exists. So we're gonna check if the file exists or not. So in the exists method, we're gonna pass the path of our file. So the path is the root, means we are in the root folder, the file is in the root folder. So here I'm gonna tell that testing.txt. Okay, we want to check that if this file is available. So if it is available, then we want to continue the process. Okay, and if the file does not exist, so we are gonna write the else part. Instead of terminating the program or crashing the program, we want to handle that. We just tell that file not found. Okay, so now if I run the code, you'll see it prints a file not found. But instead of the testing.txt, if I give the test.txt, and here as well, if I give test.txt and run the file, you'll see it reads the file and prints its content. Okay, now you can use this code as well. So you can copy from that here and paste that here. Let me do uncomment. Okay, so before reading the file, we are checking if that exists or not. So now if you run the code, you'll see it works perfectly fine. So while handling files, beginners do these common mistakes. So they try to read file that doesn't exist, forgetting to close the file, or using wrong mode like W when you want to just read. Okay, so I want to show you some more things, and that is if I comment this code and copy just this part and again paste here, just uncomment this. Okay, run the code, it works perfectly fine. But what if you want to read a file which is not available in this folder? It is inside another folder. So how will you do that? So let me open our project folder in our file manager. So if you right click on your project folder, you'll get this option which is open in. If you are on Mac, you will find this option which is Finder, or if you are on Windows, you will get an option which is open in File Explorer. So as I am in Mac, I'm getting this Finder option. So let's open my project folder inside the Finder app. As you can see, the folder got open in my Finder. As you can see, the my project folder, and here as you can see, we have so many Python files which we created throughout this series, and we have our txt file as well. As you can see, this one. Now let's say instead of having this file inside the my project folder, we have another folder inside the my project folder, and the folder name is test folder, and the test.txt file is inside the test folder. So now that test.txt file is not inside the my project folder. If I go to my PyCharm and scroll to bottom, you will see there is no test.txt file here. Okay, instead of that, you can see that a test folder, and inside there we have this test.txt file. Okay, you can see the text. Now if you run this code, you will face error file not found, because we are telling that there is a file in the project folder, means the root folder, test.txt, but this test.txt is not inside the root folder but inside the test folder, which is inside the root folder actually. So we have to specify that. So for that we give a dot, then /, and here we write the folder name. So inside the project folder we have this folder which is test folder. As you can see, we get the suggestion from PyCharm, and inside that test folder, so we give another /, we have that test.txt file. Okay, now I can close this, and now if I run the code, you will see it works perfectly fine. Now again, if you have another folder inside this test folder, so let's have a directory called another. So inside the test folder we have another folder, and if we move this inside the another folder, okay, so now the test.txt file is inside the another folder, and PyCharm has updated our code actually. But if you remove this and try to read the test.txt file from test folder and run the code, you'll see the error file not found error, because now the test file is not inside the test folder anymore. We have to go to the test folder, then there we have a folder called another, and the test file is inside this another folder. So now if you run the code, you'll see it works perfectly fine. Let me show you another thing. I can move this text.txt to our root folder. So now, as you can see, the test.txt file is inside this my project folder. Okay, it is not inside test folder, it is not inside the another folder. But what if our working file, means the files.py file, we move this inside the test folder? What will happen? Let's see. Let me click on refactor. Okay, so PyCharm automatically removed the error part, but previously this was the code. Okay, so now files is not inside the my project folder. So now if I run the code, it is inside the test folder, which is inside the my project folder. So after running the code, as you can see, we get that error. So the txt file is one level up, means it is one level in the parent folder. So we have to handle that. So Python is inside this file whose parent is this folder, which is test folder, and that's parent is my project folder, and that contains this file.txt, this one. Okay, so to tell go outside of the test folder and go to my project, we have to give 2 dot then /. Okay, now Python understand that, okay, we are in this file, but the test.txt file is outside the test folder. We have to go out of this test folder and go to the my project folder and search for test.txt. Okay, so if I run the code, you'll see it works fine. Okay, now if I move this to this another folder, again it will refactor. So PyCharm fixed the error. Let me show you the error. Let me remove this. If I run the code, you'll see the error because files now in this folder, a file from this folder, we have to tell Python to go out. So we are telling that go out one level up. So Python goes to this test folder from another. Now we have to again tell Python that from test folder go to my project folder. So again we give / then dot, and after going to my project folder, find text.txt. Okay, as you can see, now it will find the file. Now if I run the code, you will see it works fine. Okay, even if I right click here and open in my finder, you'll see my project, and there is this test folder. Inside there we have another folder, and as you can see, the files.py folder. When we give 2 dot from another folder, Python goes to test folder. As you can see, test folder. Then when we give / 2 dot again, it goes to the my project folder, and there it finds the test.txt file, so it can read that file. So I hope you understood how to work with files, specifically reading a file with some multiple scenarios, and I hope there should not be any confusion regarding this topic. So I hope you understood all the things discussed in this video. So that's all for now. See you in the next one. In the last video, we learned how to open and read files. Now it's time to learn how to write data into a file, something you will need to for saving user input, logs, or generated results. So there are multiple modes to write into a file. So we have the W, means the write method, which creates file or overwrites the existing one. Okay, then we have the append mode, which adds content to the end of the line. Then we have this X mode, means exclusive, and it creates a new file but gives an error it already exists. So let's dive into each step by step. So first let's have a look over the write mode. Now we have a text file, which is test.txt file, which we created in our previous video, and this text file contains some content, which is hello, subscribe to this channel 5 times, then some other content, then a long content, and again some text. So keep in mind that we have this file already in the root folder, where the writefile.py is located. Keeping that in mind, let's proceed further. So now I'm going to write with open. By the way, we learned this with keyword and the use case in our previous video. You can check that out. And inside open, we can tell a file name, for example, notes.txt. Instead of file name, you can give a path as well. So if you want to create the file inside another folder, for example, if you want to create the file inside the test folder or this another folder, you can just write the path here by this. So test folder /. But let's not go there. We understood this in our previous video. We want to create this notes.txt file in the my project folder. Okay, so in the root folder. And after writing the file name, we give the mode, and that is W, means the write mode. And after that, we just write as and file. You can name this anything. And inside this block, you can just write file.write, and here you can put any string. For example, Python is awesome. Okay, and you can write /n as well for a new line. So after writing this line, it will move the cursor to a new line. Then you can just write another line. So file.write, and here we can say let's keep learning, and again /n. Okay, now as we are using the with keyword, we don't have to close the file, so we don't have to call file.close. But if we don't use this with keyword, then we have to close the file manually. So keep that in mind. If I run the code and if I open this folder and if I check if the file got created, yeah, actually Python created this file, which is notes.txt. And if I open the file, you will see we have those two lines. Python is awesome, then let's keep learning, and an empty line because we used /n after this line. Okay, so behind the scenes, if notes.txt doesn't exist, it's created. But if it already exists, it gets overwritten, and the /n is used to insert a new line. You will understand the overwritten part if I remove this line, and here instead of Python is awesome, we can write subscribe to this channel. Okay, so now this notes.txt contains those two lines, but if I run this code now, it will overwrite this file, means it will remove these lines, it will delete the notes.txt file and recreate the notes.txt file with this content. So if I run the code and if I go to notes.txt, you'll see that now it contains the content subscribe to this channel. Okay, now let's say you want a way so it should not recreate the file, but it should append the content with the previous content. So for that, we just comment this and let's see the example with the mode A, means append. Okay, and here we can write with, then open, and here we give notes.txt. By the way, you can give here any path. So we are just writing the file name because it is in the same folder where the right file is located. Then we give the mode, which is A, means append, and we want that as file and colon to get the block. And here we can say file.write, and here let's write the string, which is this line will be added without removing previous line. Okay, let me close this file section. Now this notes.txt holds this text, which is subscribed to this channel, and other code in this file is commented out. Now if I run this code and visit this notes.txt file, you'll see it does not remove this line. Instead of removing, it added the new line after that old line. So it just appended this line. Okay, So it keeps the previous data and adds this line at the end. Now again, let me comment this code and let's see an example with the mode X, means exclusive. So if I write here with open, and let's call this file new file.txt, and the mode is X, and as file colon we get a block, and here I can write file.write, and we can say that this file is created using mode X. Okay, now if I run the code and open the file portal, you will see that new file.txt got created, and the text, this file is created using the mode X. Okay, but let's try to create this file again with the mode X. So in the previous example, the file was not available, so it created without any error. But what if the file already exists? So now the file already exists because we created that in our previous example. So if we try to create that again with mode X, it will create, but it will throw an error. So file exists error, file exists new file.txt. I hope you understood these codes. Now let's see some cool examples which is not related to the basics. We understood them. So let's see how we can write multiple lines at once. For that, let's say we have a list called lines. There we have some strings. For example, this is line 1, then /n, and comma, line 2, /n, then a line 3, and again /n. And here we can write with open, and we can create a file which is multiline.txt, and mode would be write as file, and inside the block we can write file.write lines, and we can just pass the lines. Okay, the list of the strings actually. Now if I run the code and check my folder, as you can see the multiline.txt file got created, and as you can see there are some lines, line 1, line 2, and line 3. Okay, so I hope you understood how to insert or write multiple lines at once. Let me comment this out and show you another cool example, and this time with user inputs. So for example, we have a variable called user input, and there we call the input method, and here we tell the user that enter a note. Okay, and then we do the file handling part. So we write with open, we give the file name or the file path, you can say, so notes.txt, and the mode would be a, means append. Then we can write as file, then colon, and we can just write file.write, then we can just have user input, then we can concatenate with /n for a new line. Okay, now if I run the code, now before that let me show you what we have inside notes.txt. As you can see, inside notes.txt we have this two text which is subscribe to this channel, and this line will be added without removing previous line. Okay, so we have those two lines. So after running the code, it will ask the user for a note. So let's enter a note, for example Naruto, Hinata, Gojo. Okay, now if I submit and if I go to notes.txt, you'll see that it adds Naruto, Hinata, and Gojo after the previous text. Okay, it is attached to the previous line because we haven't used /n before the user input here. Again, if you run the code, it will ask for a new note. For example, the new note is Jujutsu Kaisen. You submit and go to notes.txt. As you can see, Jujutsu Kaisen is being added in the file. So whenever or how many times user will run this file and he enters a note, that will be added in that notes file. As you can see, it added. So I hope you understood all the topics explained in this video. In the next video, we'll learn how to delete files in Python using the OS module. It is very useful for cleanup and temporary files, so don't miss it. See you there. In this video, you will learn how to delete files and folders using Python, something every developer needs when cleaning up temporary data, logs, or old files. And we'll use the built-in OS module for this task. So first, we have to import the OS module. This module lets you to interact with the operating system, including file and folder operations. Now, if I show you the files in our project folder, means the my project folder, you will see that we have some text files, for example multiline.txt, newfile.txt, notes.txt. so there are many text files, so we will delete one of them. So before deleting, we want to check if that files exists or not, because if we don't check and Python tries to delete a file which does not exist, it will throw error. So for that, first we are gonna check if os.path.exists, and we want to check if notes.txt exists or not. Okay, now you can give here path instead of file name. We are giving the file name because this delete file and this notes.txt file both are in the same folder. But if both are not in the same folder, you can give the path of that file. We discussed about paths in our previous two videos, so you can check out them. After checking if notes.txt exists or not, so if it is yes, means if it exists, then we tell that os.remove, and we just want to remove notes.txt. Okay, and we just want to remove notes.txt. Okay, and after removing, we just tell that notes file deleted. And if the notes file does not exist, we go inside the else block and write the print statement, and there we say notes file does not exist. So behind the scenes, this line checks if notes.txt exists or not. If exists, this line executes and the file gets removed. Otherwise, it just prints file does not exist. So if I run the code, you'll see notes.txt file got removed. Now let's remove this test.txt file. So here I'm gonna write test.txt, and here also test.txt. As you can see, this test.txt file here. Now look closely. When I click on this run button, the file will get disappeared. So run, as you can see, the file got disappeared, means it got deleted. If you check here, you'll see that the file does not exist anymore. Okay, now again, if you try to remove that file, that is not available anymore. So if you try to run this, you'll see notes file does not exist. But if you don't check this, means if you comment this out, just remove the indentation here. Now if you try to run the file, you'll see it throws file not found error. So this is the necessary why we use this checking. Okay, if you run the code, it says notes file does not exist. Basically it would be test file. It doesn't matter actually. So test, because the file we want to work with is the test file, and the code says test file does not exist. Now we saw how we can delete files. Now what if you want to delete a folder? So here we are in the my project folder, and let's create another folder inside this my project folder. So new directory, and we are gonna call this note folder. Okay, now this folder got created, and keep in mind that this folder is empty. So let's see how we can delete an empty folder. So first we check if that folder exists or not. So we write here the folder name. So the folder name was note folder. Okay, note folder. And if that note folder exists, then we want to remove that note folder. And after removing the note folder, we want to notify the user that folder deleted. And if that folder does not exist, we want to tell the user that folder does not exist. Now if I run the code, you will see that this node folder gets immediately deleted. So look closely here. I click on the run button. It says permission error. So why is that? Oh, because we are using the remove method. Here the method would be os.remove directory. Okay, so now look closely. We have this node folder. Keep in mind that this is an empty folder. That's why this method will work. So whenever I click on the run button, the node folder will get disappeared. As you can see, the node folder got disappeared, means the folder got deleted, and you can see the message folder deleted. Now if you try to run the code again, it will show folder does not exist because we have already deleted that folder. Okay, now we have another folder which is test folder, and inside that folder we have another folder, and let's see if we can delete this test folder with this method. Instead of node folder, we want to check if test folder exists or not. If that exists, we want to delete the test folder. Okay, now we want to delete test folder which holds some other folders. So if I run the code, you'll see it prints OS error directory not empty. Means by this procedure we can delete a folder which holds some file or folder. So we have to follow another method, and that is using the Tuple module. So instead of this, what we can do is we can just write that import Tuple. Okay, and we can tell Python that Tuple dot remove means remove tree, means rm tree. Okay, and we just give the folder, and in this case that is test folder. Okay, now when I run the code, you will see that test folder and another folder both gets disappeared. So look closely here. I click on the run button. As you can see, both folder got deleted. So how cool is that? Now I hope you understood the basic things, but let me show you cool tricks. You will find that interesting as a beginner, I think. So here, let's say we have a variable called file underscore name, and there the file name is newfile.txt. Means we are targeting this file, newfile.txt. Okay, now we have to import the OS module. So import OS. Okay, and let's check if os.path.exists and we give the file name. So if the file exists, then we can have a variable called choice, and there we can call the input method with some string formatting, asking the user delete, and here let's pass file name, and we can ask the user if he wants to delete that file. Then he can type yes or no. Okay, then after user writes yes or no, we can check that. So if choice dot lower means if he writes yes in uppercase letter, we want to make that to lowercase. So after making lowercase, we want to check if that matches yes. So if user typed yes, then we want to remove the file. So os.remove, and we just give the file name or the file path. Okay, after that we can just write print some string formatting, and here we can say that file name and then just deleted. Okay, and if user does not write yes, means he wrote other thing, no or any other string, so in that case we just can print that operation cancelled. Okay, now we are targeting this file which is newfile.txt. So let's see what happens. So if I run the code, it asks the user delete newfile.txt. If user says no and submits, says operation cancelled. If I run the code, it will again ask if he writes something gibberish and submits. As you can see, operation cancelled. If I run this code again, it will again ask if he wants to delete the file. If the user writes yes and submits, you will see that newfile.txt will get removed. So as I hit enter, as you can see, the file got deleted. So cool, right? So I hope you understood and enjoyed this video. So if you enjoyed, you can hit the like button or subscribe to the channel and recommend the channel to your friends. So that's all for now. See you in the next one. Now let's explore the datetime module in Python, which helps you work with dates, times, and timestamps. It is great for logging, reports, or time-based actions. So to work with datetime, first we have to import the datetime module, okay? And this gives you access to powerful tools like datetime.datetime, then datetime.datetime if you want both date and time. Then it gives access to datetime.date if you want only date, and it gives datetime.time if you want only time, not the date part, and more. So let's see how we work with that. Let's have a variable called now. You can name this anything. Now we can write datetime dot, and in the datetime we have some tools, and the first one is datetime. And if we give another dot, you'll see some methods. So first we have this now method. We can call this, and it will return us the current time when the program is running. So what I can do is I can write print, then current date and time, then comma, and we can just write the now variable. Now if I run the code, you'll see it prints current date and time, then the year 2015, the month, the day, and the time, which is 2:29, then the milliseconds. Okay, then we can have only date without time. So for example, we can have another variable called today date. You can name this anything. Then we can write datetime dot date, then we can call the today method. Okay, and we can just print today's date, comma, and today date. Okay, now if I run the code, you'll see it prints the date of today. Now you can just access the year or the month or the day itself. So if you write here dot, then just year, and run the code, you'll see it just prints the year. If you write here month, run the code, you'll see it prints the month. If you write here day, run the code, you'll see it just prints the day. Okay, now you can have custom dates as well. So for example, we have a variable called birthday, and there we can write datetime dot datetime, and inside there we can pass a year, for example 1999, then a month, then a day, for example 5, then a time, means first we give the hour, then some minutes, for example 30. Okay, you can give seconds or milliseconds, but let's not go further. And now if you write the print statement and just write my birthday colon and just write birthday, now if you run the code, you'll see it prints in a nice date formatting. Now we can format this kind of date to a beautiful looking string as well. So for that, what you have to do is you just have to take another variable, current time equal datetime dot datetime, then dot now. Now if you just print the current time, if you run the code, you'll see that this is how it looks. It is not that much readable. So to make that more readable, what you can do is you can write another variable called formatted equal current time, means this one, this variable current time dot strf time. So this will convert this date to a string, and inside the method we can tell that how it should format. So in the formatting, first it should hold the day. So we give %d, then it should have a hyphen, then we give %m for month, then another hyphen, then %y for year. We can give the capital Y here. Then let's have a space after having the date, then we can have the time. So %i for hour of 12-hour format, then we can have this colon, then %m for minutes, and %p for AM PM. Okay, now here we can just pass formatted, means the formatted time. You are seeing this kind of ugly date, but when I run this code, you'll see now this date looks nice. First it gives the day, then the month, then the year, and then the formatted time as well. Now let me comment out this code, run the code. You'll see the output is empty, and let me show you some more things. So let's say we have a date string. It is not a date but a string, means a date in a string. So it is 2104 then 2025. Okay, so it is a date, but in programming it is considered as a string, because if I write the print statement and say that type method, and inside if I pass the date string and run the code, you will see it is a string. But if you want to do some date operations, then you have to convert this string into a date. So how will you do that? For that, we can parse this string to a date. So let's have another variable called parsed date equal datetime dot datetime, and again dot string p time. And if I pass that date string, and in the second argument we can give the formatting. So first we want the date, then we want the month, and then we want the year. Okay, now if I run the code, you'll see it is saying string because we are passing date string in the type method. We have to pass the parsed date. Okay, so now if I run the code, you'll see the type is datetime. So first it looked like this one. So now after parsing, if I remove the type method and just print the parsed date and run the code, you'll see how it prints. It prints in a nicer way. Now you can have the time as well. So after a space, you can have %i colon %m then %p. If you run the code, now here you will get this 00, but if you give the time, means a clock time, then it would be added here. Now let me comment this and show you some more date arithmetic operations. So here what I'm gonna do is I'm gonna have another variable called a today equal datetime dot now. Oh, I have to write datetime dot datetime then dot now. Okay, so after having this, we can just write future equal today plus datetime dot time delta, and we can give here days equal 7. Now it will give the date after 7 days, so we can print that. So print 7 days from now, and we can concatenate with just future. Now if I run the code, you'll see it gives the date after 7 days. If you give here 30, it will give the date after 30 days in the future variable. So if you run the code, as you can see, it gives the date after 30 days. So I hope you understood the use case of the datetime module. See you in the next one.